Hey Nivida, can you hear me? Nivida, can you get my screen? Awesome. And if you can confirm that I am audible. Nivida, can you confirm if I'm audible? Okay, great. Thank you. Let me get my screen up. Hello everyone. Good morning and good afternoon and good evening to the people who are joining from other parts of the world. And you are welcome to session one, which is a breakout session on day one of Azure Community Conference 2021. And you are in the right track. It is track two. And if you wanted to go to a wrong track, I'm sorry, I was just kidding. I meant if you wanted to go into a different track, time is now. Okay, let's see what is the topic for today. Cloud Cops, what Azure, AWS, GCP rely on as a foundation of robust cloud architecture. Oh my God, you must be thinking the session name is so long and so confusing, I'm already sleepy. Don't worry, everything will make sense in few minutes. For now, just remember that Azure, AWS, and GCP provide common guidance to architect applications on cloud, and that's what we are going to talk about today. Something about me. I am Sanjay Naran. I work at EY as a global lead for cloud architecture and strategy. I have over 2 decades of experience both in organizations which create technology products such as Microsoft and HP, and in the organizations which consume technology at a very large scale, such as EY. I have been leading adoption of cloud and digital for quite some time now. Earlier in Microsoft, I helped large enterprises as well as startups in their cloud and digital transformation. In fact, I pioneered this role called Cloud Solution Architect in Microsoft India, as I was the first CSA back at that time. Now at EY, I'm leading our own cloud transformation at a much larger scale. I work in our global CTO group as a strategic builder and thinker, and I love sharing information, and that's why I'm here today. You can always connect with me on the handles that are given here. Okay, so, what we will learn? We'll learn a lot of things, but if you can capture these three things, your 1 hour will be well spent. And the first one is what exactly is the cloud architecture framework from Azure, AWS, and GCP? And what are their COPS pillars? I know. This COPS pillar, many of you may not be aware. Wait for a couple of more minutes and we'll make that clear. And then this framework is part of a larger landscape which has many more resources. We'll learn about what I'm calling as cloud COPS landscape. And when you know both of them, how do you leverage them and extend it for your own purpose and for your own organization? That is what we will learn. Moving on, I want to start with a question, and answer me. I understand we are not on a Teams call and you can't unmute yourself. And don't even type on the chat because I'm not looking at chat right away. We will do that in a Q&A time. But just think in your head and answer in your head. Remember, should be your head, not someone else. Can you remember one, two, or more best practices or principles that the three providers have given and which are common? I'll give you a second. And while you are thinking about it, let's look at that. Why are we talking about this topic? What is so significant about this? And I'll tell you about this. In 2020, there were a series of launches and releases. In July 2020, Microsoft released what they called as Azure Well-Architected Framework. In sometime back in May 2020, Google had launched what they called as Google Cloud Architecture Framework. And in July itself, Amazon also released version 8 of what they called as AWS Well-Architected Framework. In fact, they had released and they were using it internally for a long time. But when they went to public in 2015, that was their version 4. And in June 2020, Oracle also launched something called Oracle Cloud Infrastructure Best Practices Framework. Do you think all this is coincidental? I don't think so. I think there was something other. And what I can guess is, if you look at that time frame, we were already into about 3 to 4 months of lockdown because of COVID first wave. There were many businesses who were not in cloud, who were doing physical business. They were planning to go to cloud, and they were really looking for some kind of guidance that how do we deploy workloads on the cloud. And all these cloud providers found that as an opportunity and they released their best practices framework, what they called as well-architected framework around that time. No one told me that, but that's what my guess is. There's another thing which is very interesting. Is all of them are based on exactly same principles or pillars. And those are reliability, security, cost optimization, operational excellence, and performance efficiency. And we'll get deeper into them in a while. But look at that. If all these cloud providers are coming up with a guidance which is common and based on common pillars, there has to be something significant about it. And that's something that I would want to tell you now so that you can use those principles when you architect applications, when you are working. Okay, so let's look at what exactly is well-architected framework. And before we do that, let's see what are the challenges that as architects and cloud professionals we see every day when deploying applications to cloud. We all know innovation is happening at a huge speed, unprecedented speed. Every day, either a new service is getting released or some new feature is getting added to a service. It has become almost impossible to keep track of each and everything which is happening. In that, how do we make choices that what is right option for me in current requirement? Challenge. Then, for the same workload, for the same functionality, there are multiple ways to architect an application. Just think about compute options in Azure, right? We have virtual machines, and then we have containers. And in fact, containers also you can deploy in multiple ways. You have AKS, you can deploy containers in Azure Web Apps, and you can also deploy containers in Azure Container Instances. Then we have serverless options such as functions and logic apps. And then we also have software as a service option from Microsoft called Power Platform. How do we choose what is the best technology for me for the current requirement? Another challenge. The third one is When we're looking at architecture that we created or our team created, how do we ensure that that architecture will meet the needs of modern cloud native applications? There is no consistent way to assess that architecture. Another challenge. Fortunately, the hyperscalers, Azure, Microsoft and Google and Amazon realized that there is a challenge and they released something to navigate us through those challenges. And what they released is what is called as well-architected framework. I wanted to emphasize that well-architected is just a name which is adopted by AWS and Azure, but otherwise it's just an architect framework for cloud. And what exactly it is? And it is set of guiding tenets, principles, and best practices. For what? To build high quality, secure, high performing, resilient, and efficient cloud application and workloads. These attributes are important. I just did not put it for the sake of putting them here. They have a significance, and we will see that in a while. And these principles and best practices are categorized across 5 common pillars. Another thing to note about the framework is they are general concepts. They do not give you a single prescriptive guidance that this is the way to develop or architect a particular workload. That won't be even correct. They give you a common framework and best practice so that you know that you are doing the right thing. And second important thing is they're agnostic to technology or the cloud provider. I'm talking about the principles and the best practices. The technology they will provide you to implement that will be specific to that cloud provider. But in general, in terms of principles, they're agnostic, which means if you are learning something in Azure well-architected framework, you can apply that as well to GCP as well as AWS, or for that matter to Alibaba or Oracle Cloud or IBM Cloud. Let's move on. Okay, so this is what we saw earlier. What are the common architecture pillars across these providers? And that's what you can see on the screen. Okay, I've just hidden it. And let's do a memory test now. I again want you to reflect or recall these 5 principles in your head. And remember, it should be your head. Can you remember that? Now, some of you might be able to remember them exactly, and if you have seen them earlier. For many of you, including me, it may not come easily. And that's when we just saw them about few seconds back. But when we are in day-to-day work, we are actually having so many things in the head. We look at so many guidances which are available on the web and from the cloud providers, and we use all that guidance when we are actually designing something. And when we do that, we need these basic pillars to be in our subconscious mind, and it should apply. And we should be able to remember that always. And that's the reason I introduced this term called cloud COPS. Each letter in this word COPS represents one pillar. So C for cost optimization, O for operational excellence, R for reliability, P for performance efficiency, and S for security. Remember, that is COPS, not COPS ending with E, which is a dead body. And there is another meaning to this word. If you go to the dictionary, you will find the meaning is it's a group of people who are connected because they are involved in a particular activity. And this very much applies even to our pillars. If you look at all 5 of them, they do not work in isolation. They are well connected to each other. Cost, for example, whether you want to increase operation excellence, reliability, performance, or security, your cost is going to go up. And then let's say you want to build a really secure application and have depth in defense with all the layers well secured, that is going to impact a little bit of your performance. So just be aware of that they go hand in hand, and we might need to do some trade-offs when we are working with them. And we'll go deeper into each of them a couple of slides later. Okay, now let's look at that. What exactly is the COPS landscape? As I said, the framework is just one part of the overall landscape. Our cloud providers provide us many more tools and resources to help us design and operate our workloads successfully in the clouds. The first one is architecture frameworks. AWS calls it a well-architected framework, Microsoft calls it well-architected framework, and Google simply calls it as cloud architecture framework. And all of them are based on those 5 pillars that we just discussed. But if you look at the Google, they brought in a little bit of differentiation here. For security, they actually said security, privacy, and compliance. And they combined performance and cost optimization into single pillar. But they also had a 5th one, which they call as a system design. And they are saying that this system design is foundation for all the other 4 pillars. But otherwise, they are more or less exactly same. Now, the framework is primarily the documentation. You have to go and read about it. But in addition to that, Azure and AWS also provide you tools to validate that whether you're following that documentation or not. And that's what I'm calling as well-architected tools. So AWS calls it simply well-architected tool. Microsoft calls it as well-architected review assessment. Google does not have it at this point. They are actually set of questionnaire. You need to answer the questions. Every question has multiple choices. Based on how you're designing your workload and how you're answering the questions, it will provide you a rating and recommendations that you can put in your design. Very useful tool, and we'll see that in a while in our demo. Then we have add-ons. The basic framework applies to all the domains whatever you deploy in the cloud. But then some specific domains can have some additional best practices and principles and guidance. Okay. So that is covered through these add-ons. AWS calls it as well-architected lenses. So they have these lenses both for technology domains such as machine learning, data analytics, high-performance computing, IoT, as well as for industrial domains such as financial services. Azure does not have these specific domain lenses as of now, but I'm expecting that they might come pretty soon. And Google also does not have it right away. Now, the tool that we spoke, well-architected tool, is based on what answer you give them. It is not in workload which is deployed on the cloud. Then all these providers have the tools which can actually inspect, scan, and analyze your workloads and all the resources which are there in that, and can provide you personalized and actionable recommendations. So they work on your workload. For example, in Azure Advisor, it can tell you that if some of your servers are underutilized, it will tell you that you can actually downgrade them. If some of your VMs are not protected through network security groups, and they're open to internet, it will highlight that. So very useful tool. Now, whatever I spoke so far assumes that your organization has already adopted cloud. What if your organization is still considering adopting cloud, or they have adopted cloud to some extent, but they are not sure whether they're going in the right path or not? For that, there is another set of frameworks which all these providers provide you. That's called Cloud Adoption Framework by all of them. Right? These cloud adoption framework help you to identify activities of adoption, gaps, and objectives in all areas, whether it is people, processes, or technology. They provide you tools, documentation, and best practices to implement and plan both technical strategy as well as business strategy for your adoption. And that is the reason it is not only targeted towards cloud architects and cloud engineers, which other tools were, it is also targeted towards business decision makers in your organization. So this is what we call as cloud landscape. And now let's get on to the next slide. This is the longest slide and maybe most boring slide of the session, but I must warn you, this is one of the most valuable slide of the session. So you may not want to miss things here. I'll give you a second to just have a look and then we go over points one by one. Let's start with cost optimization. Monitor, analyze, and optimize is the first strategy there. Now, if you remember in the on-prem worlds, we used to do capacity planning and estimate the cost only at the start. And after that, we used to forget it for months and years till the refresh comes up. But that doesn't happen in cloud. In cloud, you need to continuously monitor and have opportunities for saving cost. For example, as I told you in Azure Advisor, your servers might be underutilized. Not only servers, even some other workloads might be underutilized. So you can look at that and reduce your cost. Or you might observe that application insights is taking a lot of your cost. There is a possibility that some developers are pushing debug logs into that, and that is hiking your cost. You need to look into that. And sometimes it could be something completely different and outside your workload. If you look at it, the compute cost has gone down over time. Right? The performance that was required by your workload, the same performance infrastructure or VMs is now available at a lower cost. So you may want to switch to that. So there are multiple aspects that you need to continuously monitor, analyze, and optimize. Adopt a consumption model, second strategy. In this case, I've seen many architects when they design the workload, they have some kind of a cost model. For example, one very common one is the production workloads will run 24 hours, whereas dev and test workloads will run only 50% of times, which is a good model. But what happens in reality, no one remembers to do that, put that automation for switching on, switching off. So that's important. Have the model and execute it also. Aim for scalable costs and try to use auto scale wherever possible. And not only for scaling up when demand goes high, but also for scaling down when demand goes down. During the COVID time, I'm aware of many businesses whose business got impacted, their online presence got impacted. The people who were running in the cloud in an optimal way, they were able to scale down their infrastructure and save considerable cost and pass that to more priority initiatives. But the people who were not in cloud and people who were in cloud, but their workloads were not scalable, they were not able to make use of this opportunity. So this is an important one. And before we move to the second pillar, I just wanted to emphasize one point, that the strategies that I'm giving here are very high level to give you an idea that what goes in these pillars. But there is much, much more and detailed content in the documentation that each of these providers provide. So you may want to go and refer to that later. Okay, let's start with operational excellence. First strategy is increase software development and release velocity. Wow, does that ring DevOps? That is DevOps best practice, right? Exactly. And DevOps and cloud goes hand in hand. In fact, many of the best practices that we do in DevOps apply to this pillar? So whether it is related to automation by using infrastructure as a code, operations as a code, configuration as a code, or using CI/CD pipelines to release our software. If you do that, your workload will be much more consistent, manageable, and operatable. And you must do that. Monitor health of your systems, and not only systems but also for the business functionality they are supporting, because ultimately that is more important. How do you do that, right? You can actually use, for example, in Azure application insights and instrument the code and inject custom business metrics to do that. The next one is my favorite one: plan and design for failures, or sometimes we call it as fail-safe design. In the cloud world, things are going to break. There could be outages in the cloud, the whole region might be down. There could be network issues, both in terms of latency or bandwidth. So there could be threshold that you might be hitting for the cloud limits. You need to plan for that and have a design for that in your applications, right? Whether you are following circuit breaker pattern, or you're doing a retry strategy or a timeout strategy, whatever it is, you need to plan for that. And then we take sometimes operations as granted, but that's not the one-time activity, whatever processes you set. We need to continuously learn from the lessons or the failures that happens in operations and try to improve our operational procedures on a regular basis. Let's get started with reliability. Define and test availability and recovery targets. I've seen, and many of you would have seen, I've seen some architecture documents, they say availability target is my application should be always available or mostly available. That's not the right way to put the targets. You need to have SLAs or SLOs, service level objectives, to define your availability targets. They are generally put in terms of number of nines, 3 nines, 4 nines, 5 nines. And recovery targets are put in terms of hours or minutes. Recovery point objective, RPO, recovery time objective, RTO. You need to have that. You should be able to detect your failures automatically. Not only detect failures, but automatically recover from them, what we call as self-healing. In today's world, if a user has to come and tell you that your application is not working, that means your application is not well designed. Obviously, you need to design for the reliability requirements and the targets that you have set, and try to go with horizontal scalability than a vertical scalability. In cloud, small is beautiful, and small scales horizontally beautifully. You need to test any of fault tolerance and recovery procedures that you might have. How many times you have realized that you are taking the backups, but when it is time to restore, either you are not able to find where the backup is, and if you find that, you are not able to restore because the backup is corrupt. Have you been there? I've been there, right? And same applies to DR procedures. It is not enough to set up a DR site. You need to do DR drill and see if everything works well, both for fail over as well as fail back. And obviously, you need to have your capacity management. In terms of performance efficiency, you obviously need to have your performance requirements. Again, I've seen some architecture documents saying that my response time should be fast. But what does fast mean? Is it like 3 seconds? It is 10 seconds? What exactly it is? Right? We need to have that. Then, obviously, we need to go with the scalable design patterns, and testing is important. You need to have load testing as part of your strategy. Moving to security, zero trust is important. Do not give any additional trust to any account, whether that is a user account or a service account, and always work with principle of least privileges. Have traceability and accountability, and generally the audit logs help us with that, but you may not want to have trusted subsystems where there is one service account which is acting on behalf of all the users. That may not be a good approach. Then have depth in defense and apply security to all layers, right from the outer world layer to the network layer to the application layer, and in each tier of the application, whether it is front end, middleware, back end, have them secured. And just not having security is not good enough. You need to also implement monitoring and keep analyzing for any events that might happen. Okay, congratulations. The most boring slide is over. Let's move to the next slide. And next slide is demo. Let's switch to demo. So what you can do is you can actually search for Microsoft assessments. It will take you to Microsoft assessment page, which has well-architected assessment as well as many other assessments, as you can see here. And if I click on, and if you have taken some assessments, you will be able to find those assessments here. They are saved if you log in. And I strongly recommend you to log in before you take an assessment. So let's start with well-architected assessment. And when you start here, it actually asks me whether you want to do a new assessment or create a milestone. It's a very good, actually, strategy that this assessment is not one-time activity. You do it at the time of design, and then you can have milestones and see that how your score is increasing after you implemented the actions that were provided in the previous milestone. So for now, we'll start with new assessment. So you will give it a name. So this is the name here. And then it is a very nice feature which got added to the assessment, that now you are able to connect to your subscription in Azure and pull in the recommendations which were provided by the Azure Advisor tool. So even Azure Advisor, when it gives you the recommendation, it also categorizes those recommendations into all these 5 pillars. So when you get recommendations from this assessment, they will have collective recommendation from both the tool. Pretty good feature. Now, and we can choose our interests. We don't have to do an assessment for all of them together. And when you select an interest, for example, when you select reliability, what you see here on left-hand side, multiple, I guess there are about 13 questions which get added on reliability. And if I select security, there are additional questions which got added on security. Then if I go with cost optimization, same for cost, same for operational, same for performance efficiency, right? And once you select your interest, you can start the assessment. Now what happens is when you start, one by one, you need to answer each question. So there is a question, if you look at the question that we are right now, is what reliability targets and metrics have you defined for your application? And one very good feature of Azure well-architected assessment is you don't have to go out to see details of that particular question. There is a very brief summary of that guidance here. For example, if you see here, it's saying that you need to have SLAs and RTOs as metrics for your application. And in fact, there is a video also for many of the questions, and which is a small video. For example, this is just 1 minute video, which will talk specifically about that question, that what it is measuring. So very nice feature. And as we are looking at the answers, there are multiple choice questions. So are we using RPO and RTO? Yes, we are using. Are we using SLS and SLS? Yes, we are using. Are we having metrics such as MTTR and MTTBF? MTBF we have. So I'm just selecting that, but you will select whatever applies to you, right? And then have you ensured that your application architecture is resilient to failures? No, none of above. Let's move on. And same way, you can in fact skip through the questions and let me go to the last question. So there is a question about what are the problems. I will say none of these, or I will say some other option, and I will say view guidance. Now what happens is it provides me my overall results. Because I did not answer most of the questions, it is critical that I have a lot of things to improve. I get an overall score, and then I also get score for each pillar. If you see here, 5 pillars, because I did not answer any of the questions in 3, so I did not get any rating there. So let me show you one of assessment that I had done, which had little more answers. So I can go back to assessments. I can go back to an assessment this is today's assessment, so I was doing yesterday. So it has a high-level summary of my assessment. There were 55 questions which have been answered in this, and what is my current score. I can, because it was not complete, it's giving me an option to continue. Let me say continue. And this is the final question. Let me say view guidance. Now, if you see here, because I have answered many of the questions, the results here overall is moderate. And then I have better results in each of the pillars that are here. Based on my answers, it gives me 3 very critical things that I should do as next steps. So these are the next steps which are given to me. This is not static. And then it has detailed recommendations for me to take for all the pillars. So if you see under reliability, I have 25 recommended actions, in security 60. If I click here, these recommendation actions are there, and each of them is a link which will take me to some guidance where I can refer to them. Now there are many, right? So if you see, it's not easy to implement all, but you can actually do a filtering. So if I say only high, it will reduce and show me only high, so that let me take care of that first, and then I will take care of others later. So I like this tool very much. And another thing about this tool, many people generally ask me that I'm trying to get to the cloud architecture from a different stream. How do I become a cloud architect? Now, becoming a cloud architect takes some time. It needs some kind of experience. You need to know about all the technologies. You need to know about all the architecture skills. But if you are new to this role, I would say that you must leverage this tool. If you are designing some application, I have seen this tool is providing kind of a checklist, which is the most comprehensive I've seen to provide you points across all the things which ideally an architect should be doing, right? Very important. So definitely useful, not only for the new ones, but even the experts people. What happens is, once we become expert, we try to forget some of the important points. So this checklist will ensure that you do not miss any point for your workload. Let's get back to presentation. That was the demo. Okay, so this is another question. Again, there's some kind of a head practice. You need to answer this question in your head, not someone else's head. So let's say you're working on Azure and deploying a workload to Azure. Is it recommended that I should refer to AWS COPS resources? What do you think? Reflect on this while we go to the next slide. Now you have COPS landscape, but how you can leverage that. So here are some of the recommendations from me, but obviously you will have different ways to leverage it. Now, the first thing is understand all the resources which are available in COPS and what are the relationship between them, because then only you will be able to leverage them. For example, only when you know that AWS provides some kind of lenses for specific domains, you will be able to refer that even when you're working on Azure, right? So understand that. And then I would say that refer to other cloud providers, documentation and landscape whenever required. In fact, when I was going through the documentation for all of them through Azure, Google, and AWS, though the pillars were same, there were some very good points in Azure, but at the same time, there were also some good points in AWS documentation and Google documentation, which was not there in Azure documentation, because everyone is providing guidance based on what they feel right. So it is good idea to refer to the guidance in each of the provider. And many times, even use the tools provided by others. For example, if you are working on Google Cloud, and I would recommend that you can take the Azure well architected assessment, because you remember that I told you these principles are cloud agnostic. So most of that guidance will apply even to Google Cloud. The only thing is the recommended actions, they will tell you about some technology to apply that particular best practice. Now that may not apply to Google Cloud, so you will find which is an equivalent option in Google and use that particular one. Same way that if you are working in financial services, you're deploying a workload in financial services in Azure, you may want to refer to the domain-specific lens that AWS provide for that. Now, that is what is provided by default by the cloud providers. But there is a huge scope of extending the well-architected framework for your own organizations. Every organization has governance, rules, and policies which are specific to that organization, and you should be able to customize these best practices or extend them according to that. So depending on which department you are or a business function you are part of, you can actually build lenses for those business functions. You should be able to even integrate these questions through APIs into your applications so that you don't really have to go. And these APIs can also help you to assess multiple workloads across all the subscription that you have. Azure does not have APIs yet, and Google does not have, but it's easy to build these APIs. AWS actually has provided APIs they released in the last December. And then you can actually provide some kind of hands-on labs for different areas, whether it is reliability or it is for performance. And you can build your own labs for that, your own scenarios for that, and people can use sandbox environments to do those labs. So that was how do we leverage the landscape. Okay, so we are at end of the session. Congratulations, you survived so far. Let's quickly review the takeaways that we had at the starting. So we learned about the cloud architecture framework from all of them, and COPS, I hope, is no longer an acronym that you are not aware of. We also learned what are the different kind of resources by different providers in cloud COPS landscape. And we also learned that how we can leverage and extend these cloud COPS resources for our organization. Okay, so that is end of this session, and I will stay here for Q&A session, and you can easily forget whatever you learned here. No, I'm just kidding. I have some homework for you. So you want to see what is your homework? And this is another head practice when you do at home. Reflect on this question. How can I leverage cloud COPS to enhance cloud architecture in my organization? And I guarantee you, if you seriously think about this question, you will be able to think 1, 2, 3, and many more areas where you can improve the architecture of the applications that are deployed in cloud in your organization. That will help both your organization as well as you personally. With that, let's see if there is any question.
Hello, Sanjay.
Yeah, hi.
Okay, there is one question here. Let's say that was from Sachin.
Mhm.
Okay, so we need to migrate our on-prem data centers to cloud. Then at which stage we should apply this framework? Is Microsoft providing any Azure Migrate and other frameworks for migration? So where this fits in? That was the question from Sachin.
Sure. So ideally, I would say that before even you deploy, so when you are planning your migration, you should apply this framework, because when you're planning, you would need to see that how will I build reliability in my workload. Now, think of the scenarios. For example, in on-prem world, we never used to think that my web server may not be able to connect to my database server. We always take that connectivity guaranteed because they are in the same data center in the same machine. But when you move to cloud, you need to start thinking that that connectivity may not be available, and you need to bake in that failure in your design. So you need to do at the planning time. Or the another thing is cost, right? As I said, right, in on-prem what we used to do only costing at the time of when we were planning for that workload. But you need to plan that when you migrate this workload to cloud, what will be the cost and how much you can save. So all the times. In addition to that, so the one question on what does Azure provide? So Azure has many migrate services available to you, tools available to you for that. But I would also recommend you to have uh, look at cloud adoption framework, because if you have not used cloud, and see that are you implementing cloud in right, are you putting the right strategies overall, not just for that particular workload. And there's another assessment here which I showed. If you go to assessments called Cloud Journey Tracker, this is something related to the cloud adoption framework. You can take this assessment also at the start at while you are planning for your migration. So any other question we have?
No, for now there is no question. We'll wait for one more minute. Yeah, one more question is there. Is this assessment tool useful for developing cloud native apps only?
So interesting question. So I mean, I wouldn't, I'll say not really. So there is a different definitions of how people look at cloud native, and many times say people think that the microservices and container based architectures are more cloud native. If you're going with that definition, and your question is whether it's applicable only for that or is it applicable even for the infrastructure as a service or a virtual machines related, it's absolutely applicable to all kind of workloads that you deploy on cloud. It will make much more sense in the cloud native, but it definitely applies to infrastructure as a service workloads also.
Okay. We'll wait for one more minute, Sanjay. So we'll see whether any question arises.
So while we are waiting, uh, I wish you all the best. There are 2 days of learning, in fact, 3 days of learning. Make use of that as much as you can, and you can always connect to me on the LinkedIn and Twitter handles that I provided.
Okay.
So we'll end the session.
Yeah, Sanjay.
Devis.
That was an amazing session from you. Thank you so much.
Thank you, everyone. Have a
Thank
great
you.
day.
Hello.
Hello.
Hello, Melissa. How are you?
Yeah, I'm good, thanks. How are you?
I'm good too. So, hello everyone. I would like to invite Melissa. She would be giving a talk on travel with me to .NET MAUI. The stage
Yeah,
is
that's right.
yours, Melissa. Yeah.
All right, thank you very much. And thank you to everyone who's tuning in to the conference today. I hope you enjoyed the first talks that have happened so far. And thank you for specifically tuning in to mine. I know there's a few different streams with really awesome talks going on at the same time. So before I begin, I'd like to do a shout out to the sponsors of the event. Without them, this event wouldn't be able to happen. And there's so many amazing people involved. So we really do want to thank and shout out our sponsors that we have for today. So a little bit about me. So my name is Melissa Houghton, and I'm a lead software engineer at a company called Azenix, and I'm a Microsoft MVP in developer technologies. I'm coming to you from Melbourne, Australia, so a different part of the world. And I know we have people tuning in from all over the world, but the conference is based in India. So it's really great to be able to at least virtually connect with people from all over the world. My socials are up on the screen if you'd like to connect with me. I love connecting with people who have similar interests to mine, which in this case is technology and specifically .NET and Azure. I'm an application developer who works mainly with .NET, and I've been working mainly with .NET in terms of web development. And recently, I've been exploring what else that you can do with .NET. And that's when I came across .NET MAUI. I had never used Xamarin before, but I've always had a keen interest in it. And about 10 years ago, during one of my first jobs in tech, a coworker told me about Xamarin and how I should invest in some of its stocks. And I was much younger at the time and a little bit naive, so I didn't listen to him, unfortunately, and Xamarin went on to be purchased by Microsoft in 2016. And now here I am telling all you how far it has come. So today we are talking about, we are going to take a trip and travel with me to .NET MAUI. Unfortunately, it's not the Maui in Hawaii. It is a beautiful place. If you ever get an opportunity to go there, I would highly recommend it. I did try to use some photos of Hawaii throughout so that, kind of makes us feel a little bit like we're on holiday there. But we're not talking about Maui, Hawaii. We are talking about .NET MAUI. And .NET MAUI stands for the .NET Multi-Platform App UI. So in this talk, I'm going to give you a bit of a background about .NET MAUI and what .NET MAUI is, how it came to be, how you can get started with it today, and why I am really excited about it. But first, an update. If you have heard about .NET MAUI before, you may have heard that it was supposed to be released as part of .NET 6, which is coming to general availability next month in just about a week's time as part of .NET Conf. However, the team has announced that MAUI will not be ready as part of that November release. So they said it's not going to be ready for production yet in .NET 6, and they are instead planning for Q2 of 2022 for .NET MAUI to go general availability. So it's currently in preview, and we've had quite a few preview versions come out already. So we still can play around with it and have a bit of a look of how we can use it and what it looks like. And there is still, because it's still in preview, there are some issues, and similar to the main tool to use with this is Visual Studio 2022. And I just saw like a second before I came onto this talk, my Visual Studio was doing some weird things, and now it's telling me I need to restart my computer to use Visual Studio. So I'm going to try and still show you some cool things and show you some code at least, but I might not be able to show you full working demos. Unfortunately, that's part of the issues with things being in preview. But hopefully you can still get some really good information and value out of this talk today. I do commend the team for for sort of delaying the release to make sure everything is in good working condition. Because we all know, if we've been involved in video games and seen what's happened with some video games when they're launched before they're ready, how that can turn out in a negative way. But I'm excited to see what they continue to do with MAUI. They're currently on Preview 9, which came out earlier this month with .NET 6 release candidate number 2. So they're continuing to do updates, and they'll have updates pretty much on a monthly basis leading up to Q2 of 2022, which is I think about like June time next year, April to June. So yeah, we'll see how we go. Cool. So what is .NET MAUI? .NET MAUI is a cross-platform mobile-first framework for Android, iOS, macOS, and Windows. And it can be written in either C# or in XAML. And really, it's an evolution of Xamarin Forms, which has been extended from mobile to desktop scenarios. UI controls have been rebuilt from the ground up for performance and extensibility. You can build your apps for any device from a single codebase and project using one language, one set of libraries, and one UI stack for all. But it still allows you to have platform-specific code and resources if you want. So .NET MAUI is really for developers who want to write cross-platform apps using either C# or XAML from a single shared codebase in Visual Studio. Those who want that shared UI layout and design across all the platforms, and who want to have the ability to share their code, their tests, and their business logic across all the platforms as well. So when we describe MAUI, we say it's an evolution of Xamarin Forms. But what is Xamarin and Xamarin Forms? Well, Xamarin, which I mentioned at the start, is an open source app platform for building modern and performant iOS, Android, macOS apps with .NET. So Xamarin is the Android and iOS bindings for the API for those iOS and Android applications. And so it's letting you write your C# code for creating those native apps. So you might have seen things like Xamarin.Android and Xamarin.iOS, and those are now being renamed to .NET for Android and .NET for iOS, and they're being rolled into .NET 6. And Xamarin Forms, on the other hand, which is what MAUI is an evolution of, is the cross-platform UI framework that sits on top of Xamarin and allows you to build your apps with .NET from that single shared code base, and enabling the sharing of your UIs across the different applications. So it really adds this layer so you don't have to worry about the APIs for the different platforms underneath, and helps you just focus on writing your code. And so what we have there with Xamarin Forms is what is now evolving into .NET MAUI. And they're saying it's an evolution because it's really a re-architecture, and think of it as like a really big update to Xamarin Forms. It's not a completely new thing. We've had the ability to write cross-platform .NET mobile applications before. They've just done a whole lot of things to improve it and make it a lot easier to use and help integrate it into that .NET ecosystem that we know and love. So if you come from a background of working with Xamarin and Xamarin Forms, your skills will be directly translatable, and you'll see a lot of similarities when you go to build your applications. And if you have any existing applications that are written in Xamarin Forms, Microsoft has said that they'll have a simple migration process for you to upgrade those applications. And in fact, because MAUI is still in preview, they're recommending that you start with Xamarin Forms for any sort of apps that are going into production, and then migrate those once MAUI goes into general availability. Because there is a lot of features that are still missing from MAUI, so they're hoping to get that all solved by middle of next year. So overall, the value proposition that we have from the .NET MAUI team is that .NET MAUI is the most productive way to develop native apps that perform great on any device that runs Android, iOS, macOS, or Windows from a single code base. So really, it's about being more productive and more performant. That's what we're looking at when we're looking at the updates that have come with MAUI compared to Xamarin Forms. And it's going to be highly improved and easier to use and better than ever before. So next, I did want to show you a demo. As I mentioned, my Visual Studio isn't working, so I'm going to just quickly show you the code. I opened it in Visual Studio Code, so we can see sort of what this looks like. So hopefully this is big enough. There, zoom in a little bit. Cool. So what we're looking at here, this is an application that was developed by David Ortenow, who is a principal program manager at Microsoft, and he is on the .NET MAUI team. So he's much more experienced with MAUI than I am. And he's written a really nice application that is a weather app. And this application has is more advanced than your traditional Hello Worlds that you might see in your getting started things. And basically what we have in, let me just close this first. So this is an older version here, but at the moment there's 2 project systems. So this is in one of the earlier previews, but in the current previews, everything is rolled into one. So you'll see just the one folder, one project, that one code base for your application. And if we expand this, there's a folder for the platforms. So there's one specific to Android, specific to iOS, and one specific to macOS. So that's where you can put your platform-specific information there. But then everything else, so defining all of your views and your pages and any sort of services, that's all shared across all the different code bases. So what I have open here is one of the pages. So this is just a home page, and the default when you are creating a new MAUI application is to use XAML, which is carryover from Xamarin Forms. That was the traditional format there. But as I mentioned, you can also do it in C#, and we'll take a look at some code that's using C# there as well. So XAML is a templating language that lets you define your UI. And you can do things like having flex layouts. So MAUI works on different size devices. It's for desktop applications, so like Windows apps, as well as your mobile phone device. So using this flex layout helps make it a bit more dynamic. And then you can also add things like you have your widgets and all that. So if we say the favorite page, for example, has a bit more, there's some image and some text, and you bind that information to the back. They've added a whole bunch of new controls and new features, and there's a lot of flexibility with what you can do with this application with .NET MAUI. I have a photo for you of what that looks like. So after the weather app is generated, you can target all the different platforms. So this is a bit of a GIF of it on all the platforms. So we have the Android device, and it has some images. There's little widgets moving around. You can get cool little animations, and you can have it have the menu look differently on your Windows app versus your mobile app, and all of that. So there's a lot of flexibility with what you can do with your MAUI applications. And you can have integrated things like this map, and all these different features will work on the different devices, which is really, really cool and makes it super simple and easy to use. Cool, so the road to MAUI. We're talking about, it's an evolution of Xamarin Forms, but how did we get here? How did we decide we need to evolve Xamarin Forms, and we need to come up with this new thing called MAUI? How did Microsoft decide that is the question. So let's take a journey on the road to MAUI. So it all started with Xamarin. Xamarin was founded as its own company back in 2011 by the same developers who created Mono, which is an open source development platform based on the .NET framework. And within Xamarin, they have the Xamarin.Android and Xamarin.iOS, which expose the complete packages, the complete SDKs for .NET developers, allowing you to build fully native apps using C#. So this was a new thing, being able to write mobile apps in C# when they created Xamarin back in 2011. So Xamarin development was all based on the same language and allowing code to be shared across the supported platforms, which we've seen carried over to MAUI today. However, the UI was not reusable until 2014 when they released Xamarin Forms. And then Xamarin became really popular and it was all focused around C# and .NET. So the company was actually acquired by Microsoft in 2016. And it's continued to be a really popular cross-platform product for developing mobile apps within the Microsoft ecosystem. And since then, Microsoft has been working on improving the platform and helping us bring to where we are today. And Microsoft also has this really big goal of having a unified .NET. They see .NET as your platform for building anything, from desktop and web to cloud, mobile, gaming, IoT, AI, all of it can now be done with .NET. And part of this unification goal, they've been combining .NET Framework, Core, and Xamarin all into one thing that they're now calling just plain old .NET. So you'll see the core and the framework notation go away. And it already has started to go away. The plan is to deliver this fully with .NET 6, which we know is coming to general availability in November. And they started this unification process with .NET 5. So we already have it cross-platform and open source. We've already starting to see some of those different packages rolled in. And first, they're focusing on that desktop and web, and now extending into the other areas as well. So Xamarin Forms, which is the UI framework for Xamarin, evolving into .NET MAUI, is all part of this unification process. And having Xamarin.Android and iOS folded into .NET and renamed is part of that as well. So there's a lot of renaming happening, but they're also looking at the improvements and the re-architecture of how they can make it better for all of us as well. And make it easier for .NET developers to get involved too. So part of this vision and idea is that if you're a .NET developer coming from, say, the web side or even the gaming side, you'll be able to go to any other piece, pick up mobile, pick up AI, and it'll be a very similar environment that you can easily get started in, which is really cool. And as a .NET developer myself, I'm really excited about that. So overall, the focuses for MAUI specifically are looking at improvements in productivity and performance. For productivity, we now have support for .NET Hot Reload, which is coming for all of .NET 6. So it's not specific to MAUI, but it's available for MAUI as well. And we also have C# 10 along with some other features. There's also a new command line availability for MAUI specifically, which we didn't have with Xamarin, which will make things a lot nicer if you're used to doing that. So I'm just trying to see if my tech is going to be working on the side over here. Cool. And we also have more support for tooling within Visual Studio itself, specifically for MAUI. So they've been really focusing on making it easier for those developers using Visual Studio to get going. And .NET Hot Reload supports XAML with better speed and coverage. It has C# method body replacement. And it's also your Razor pages and CSS will be hot reloaded as well. And you can also use it with the debugger or without, which is cool because before you always had to be using the debugger. But if you've ever worked on one of those massive projects where you might have, a whole bunch of things that you want running at once, you don't always want the debugger running. So they've given you that flexibility to be able to do that with you as well. And it's all going to be within one single project, so you don't have to be switching around to look at different things, which is really nice. In terms of the performance side of things, there's a whole bunch of new layout managers, which give us more flexibility when we're setting up the look and feel of our application. And they also centralize the logic to reduce the measure loops and increase that performance. They've also changed the application startup to use explicit registration rather than reflection. So we get some performance savings there. And it's using the .NET 6 base class library, which is shared across everything, and that improves the performance throughout as well. So we mentioned there's a single project system for all of it in .NET. And when you open it in Visual Studio, this is what it looks like. So we saw it quickly in code, but it doesn't group things in the same way that your Visual Studio tool would be. But basically, we have the resources, which can be shared across all the different applications. So, any sort of logos and fonts and all that, you only have to upload it once, which is nice. And then the platform-specific code. So if you need something specific for your Android versus iOS devices, or you want to customize it in some way, you can do that in the platform folders. But overall, you can basically just choose from the target run dropdown which application you want to target. And it just tells you, which packages are included in there. So it's really nice, and you can use all the same tools, same project system that your other .NET projects use. So as I mentioned, coming from world of web development with .NET, it's all familiar. It's the same sort of tools that you're used to, and it also has simplified binding for native libraries for application developers as well. So, okay, we're talking about a native UI, which means it's compiled into those native app packages, but it's also cross-platform, and it's all in .NET, which I think is really amazing and really cool. Because basically what this means is when it's native to the application, it's running in the language that Android or iOS understands, and you can utilize those tools for each platform and consume those native platform APIs. It's faster, it's more responsive, and it's more efficient because it's made for that application. But you're also getting the development benefits of this cross-platform technology and being able to share information and share your resources and write it in .NET, which is cool if you're a .NET Microsoft fan like I am as well. So really it gives you the best of both worlds by producing native apps for each target platform. So how does this all work? So everything starts with your application code. This is where you want to spend most of your time being productive, where you are going to be writing everything that you want to do. And you want that to be delivered to your devices, your Android, your iOS, or your Mac OS or Windows application. So first we have those native packages there going to all of them. And then above that, we add in the native platform SDKs. So that's what's running. So first we have, the native platform SDKs, which is what's running the Google, Android, and what Apple and Microsoft ship for those platforms. And to get our app code running on those devices, we need something that can run .NET code. So that's where we then put the .NET runtime on top of it. Under the hood, it's kind of using MongoVM and Core CLR for Windows, but really there's another layer of abstraction over that. So we don't care too much about that because on top of that, we have the .NET base class library. And this is the common .NET API that we can write our code against. And this is the same that's used across .NET 6 and your other application development as well. So it's using the very same runtime base class library that you would see in other places in the world of .NET. And then we have we use .NET against native platform SDKs with a .NET representation of them. And we do this via a .NET API binding and implementation to the native API. So that's where we have the .NET for Android, .NET for iOS, and WinUI, which used to be Xamarin.Android, Xamarin.iOS, and all of that. But they have re-architectured it and restructured it. And even this whole how it works that I'm showing you now is different to how it was done in Xamarin. So they've really thought about how they can improve this to make it more universal and similar across all the .NET 6. So what's happening when you call a native method in C#. It's just as if you had done it from Objective-C or Swift or Kotlin or whatever your native application is expecting. And really the final layer of the cake that in this layers that we're looking at is .NET MAUI. So that's what we're all excited about. So .NET MAUI provides all these layers to make it so it gets this really nice native cross-platform application. It provides a rich library of controls, layouts, and services that work across all the platforms supported. So you only really need to master that one API to get those native applications. And so .NET MAUI is really just giving you the direct code that you need to have a single framework to give you access to everything, which is really cool and really exciting. So tools you need to get started. So Visual Studio 2022. So this is in preview now. So this is also going to general availability in November, just in about a week, probably less than that actually, just a few days time now. As I mentioned, it is good to make sure that your environment is all set up correctly, because I've had an issue just before this where it's telling me I need to restart to get it working, but that's okay. It's still fun to play around with, and there's lots of tutorials and getting started things out there on the Microsoft resources that can help you set it up on your machine. I do have to say that Visual Studio 2022 for Mac, the first preview came out in September, but MAUI is not yet supported on there. So you can still open your MAUI projects on Visual Studio 2022 for Mac, but it has very limited support at this time. So you're better off if you have a Windows device to play around with Visual Studio. The other thing that's cool, though, is because the command line is supported, you can use Visual Studio Code to run your MAUI applications. There's not as much functionality and support if you do it that way, but it's still really nice to get started. You will also need to set up some emulators, so Android emulators with version API 31 is the recommended one. And the other cool thing is you can also set up what's called an iOS simulator. So if you're on a Windows machine and you want to debug and test out your iOS applications for your MAUI code, you can do that on your Windows machine by setting up a simulator. What you do is you need a Mac to first connect to get like the Xcode and the tools, but you only need it for that initial setup, and then you can do everything on your Windows computer. There's also some ways to do it online, or if you have a physical iPhone device, you can plug that directly into your Windows machine, and you can have the device launched onto your phone and test it out that way, which is nice. So there's a lot of different ways to get started, and they're continuing to improve these tools for us every day. And other than that, there's also a tool that the Microsoft team have made called the .NET MAUI check. So this was made by one of the developers who works for Microsoft. It's no longer required because Visual Studio comes with all the workloads and things you need, but it's nice to just check out your machine using this tool to see if you have everything. So this will check to make sure you have like the correct Android SDKs and all the different workloads. And if you don't, it'll try to install those for you or give you recommendations on things that you want to get started. So, and then afterwards, you can just run .NET New MAUI and it'll create a new application for you. So I'm going to do that for us now. Oops. I'm going to just go see if my keyboard works. Oh. Go first into my dev folder because that's where I like to keep all of my my code. I'm going to say .NET New -n .NET New MAUI as const MAUI. Oh, and it created the template. So I'm going to go over to my Visual Studio Code because, as I mentioned, my Visual Studio is not working. So I just made it in this folder here as MAUI, and we're gonna open this up. So you can Visual Studio, yes, I trust myself. So you can have, go into Visual Studio and just say, create a new application there using their templates. They have the templates in Visual Studio 2022 ready to go for you for MAUI, and it'll create basically the same exact thing. So you have that as well. Cool. So similar to what we saw in the screenshot for the system, we just have the platforms here. So that has Android, iOS, and all that. We have the resources. So this is the shared. I'm just going to ignore this for now. The shared fonts and images across the application, and it's all in one project folder. So in that other thing that we were looking at had the separate folder for WinUI, so that doesn't exist in these new applications. It's all just there in one, and everything is shared across. And what it creates for you is a little Hello World application. So we have a sorry, I don't have all the correct extensions installed. And so you can install some extensions in Visual Studio Code, which help understand what everything is in your C# code. And those warnings I got were to download some of the missing NuGet packages, I believe. But basically what it gives you is a Hello World application that has a scroll view with just a base label, a button that you can click, and an image. And so this button, all it's doing, it has an on counter click behind the scenes. And we can see that in the behind file, which is here, and it's just binding to the counter label to say how many times it's been clicked. Now I think I'm going to see if I, on my other screen, just open up Android emulator, see if I have that. Maybe I don't. My applications, folders. I'm just trying to see if I can open up an example for you. Oops, don't want it on here. To see it running, but it's a little guy who's waving and saying hello, and he's just making it nice for you. Shoot, it's disappointing. Yeah. Well, I apologize that I can't get it running for you, but hopefully you can get it running on your own computer afterwards, and you can see what it looks like. The other cool thing is when you're using it in Visual Studio, there's a little demo here on the side that shows you what it looks like when you're working on it. So you can see things as you're changing it, and you can do that hot reload, which makes it really nice to play around with. Cool. And so it's really easy to get started if you have your environment working. The hardest parts that I had when I was getting everything set up was setting up the emulators. If you haven't worked with emulators before, there's some troubleshooting you might have to do, but Microsoft has some good troubleshooting documentation to help you get through those different steps. I do see a question in the chat here about, will Visual Studio 2019 get an update for MAUI, or is it only part of Visual Studio 2022? So there is, in 2019, there is a version that has MAUI. I can't remember the version number off the top of my head, but there is one of the more recent versions of 2019 does have MAUI. I don't know if it has the templates, but it has some of the tools to help you run it. So you might still have to use the command line to create the initial template, but it should have that hot reload and the nice tools to allow you to interact with MAUI. But I would say Visual Studio 2022 is generally available within about 1 week. So hopefully you can start using a stable version of that very, very soon. It's supposed to be very powerful. It's 64-bit and all of that. So I'm excited for the general availability stable version to come out shortly. Cool. So we just saw a quick demo of just how easy it is to get started. And you can add it with different tools and all of that. Cool. So there's also a lot of other cool features that have come with this update to MAUI versus Xamarin Forms. So one of the things that's new is they've introduced some modern application patterns. So we have the model view model and XAML pattern, which is existing in Xamarin Forms application and is the sort of traditional approach to writing cross-platform .NET applications. And when we quickly looked at the Weather 21 application, that had the model view model format going on. And that was using XAML as the template. So basically what that does is you have the model, and that binds the data and commands to the view model, and then the view model updates the model, and it sends notifications throughout the process to keep everything up to date. So the UI with MVVM is mutable, which makes managing the state difficult at times and can cause issues depending on what you're doing with your application. It does enable us to keep the UI logic and the business logic and data, all of those things, very separate, which can make it easier to maintain. So there's pros and cons to different approaches, but this has been one of the traditional ones that's been there as well. You could also use reactive UI, which is a framework which enables reactive programming over the top of the MVVM design pattern. But now .NET MAUI will further introduce the model view update development pattern. So this is known as the Elm architecture pattern, which is a functional programming language approach. So basically, it allows you to have write fluent UI, generally using C#. So this is the preferred approach if you're writing your UI in C#. But it's not limited to that. So we'll take a look at that in a second. But basically what the MVU pattern is doing is you have the model sends the state to the view, and then bindings and commands to the update area, and then it sends on the state changes. So it's more of a reactive programming, and you have in the past been able to do this with Xamarin through the community toolkit, but now it's a first-class citizen. So it's built in and supported within MAUI. They haven't yet set up getting started templates using the different patterns. By default, it's just using XAML, but I'm hoping that in the future, that's a feature that they come out with so that it makes it really easy to get started in one way or another. And so we can also, as I mentioned, use C# or XAML. And so you can write out, if you're using XAML, that's on the right-hand side. So that's the template where you have, your label and defining the text and all of that. If you're using C#, it looks very similar. You're basically just creating a label object with the properties, and you can have your action code in the same file if you want. Generally, if it's a bigger application, you want to separate it, but you have a bit of flexibility there. In terms of defining default values, you can do it no matter which format you're doing. So if you're using C#, for example, you can still define, I want all the text to be white and all the background to be blue, or whatever you may have as your defaults within your application. So you still have that full flexibility no matter which approach that you use. So I do want to take a look at the .NET. So the next sort of thing I wanted to show you was the community toolkit. So I'm just going to move this over here, zoom in a bit. So hopefully it's a bit bigger now. Cool. So the community toolkit is an open source thing on GitHub that holds a collection of control and helper libraries for different .NET technologies. And this is part of the .NET Foundation. So it's more community run, and it is open source. You can contribute to it. But they have, there's always been a Xamarin Community Toolkit that had a lot of big community support. And now it has, they've moved out over to MAUI. So they have the regular MAUI section of their Community Toolkit, which has a whole bunch of different elements that developers tend to reuse across applications that might not be first-class citizens in the regular MAUI world. So you can even contribute. They have ways that you can add features here. The regular MAUI is all open source as well, so you could contribute that way, but there's a bit more rules around how you can add features. So there's some really nice tools that are in here. But there's the other part of this is the, if I go back to the Community Toolkit, they also have something that's called MAUI Markup. So MAUI.markup is a repository of examples and tool extensions that allow you to use Fluent C# for your MVVM model, the application. So if you want to follow that model view model pattern, but use plain C# you can, and this community toolkit has helped you do that, which is nice. If I go over to, let me open this repo here. So this was created by Brandon, who is on the MAUI team as well, and he's one of the main supporters of the community toolkit. He just recently, in his own repository, created this application, just Hello MAUI Markup. So it's just an example of how you can use that. And so he has some examples of how you can create your Fluent UIs using C#. So we have things like here, he's defining a label and setting out the rows and the layout. And you can have, your buttons and all the same things, and having the .NET bot. And this is basically the same exact Hello World application that we had when we created using the template, but now written in C# instead of XAML. And this is what it looks like. If I had, maybe I'll zoom out for showing you the bot. If I had been able to run it, it would, on the emulator, it would just look like this. So if we had the XAML, so it has that button that we click, it bound to the label here of the counting, and that has a little image there. If I quickly jump back to the thing that the getting started, Hello World application, the template, we can see has the same .NET bot, and it has the button with the click me and the label with the current count. So that's the same as what we see in the image here. But in this example, he's changed it to now using plain C#. So there's a lot of flexibility with how you can approach it there, which I think is really nice. Cool, so I'm going to go back to my slides. So with MAUI, we have a really rich library of different controls. So a lot of native controls, and then they're even more supplemented by the community toolkit that we were just talking about. So there's 50 plus controls, and a lot of things have been carried over from Xamarin Forms and updated, and now they're adding even new things as well. We have new navigation, we have adaptive layouts, so they've used the standard layouts that already existed, but then they've added a couple new ones as well. So now we have the options of doing a grid layout, a flex layout, and different kind of stack layouts as well. So there's a horizontal stack or vertical stack, depending on how you want your different items to appear on the page. And that can help when you're going from smaller devices or to bigger devices as well. So there's also a focus on accessibility, which is always nice. So having it be compatible with screen readers and things like that. So that's built into the controls that we get with MAUI. And there's already as well support for a bunch of third-party component libraries as well. So vendors such as Telerik and all those ones that you may have used with your Xamarin projects a lot of them have already transferred over to supporting MAUI as well. So we have a lot of opportunities and things that we can do to get started. If you want just a simple little date picker, or you want, you want a little slidey thing, that all comes native built into MAUI for you already. So another cool feature is the .NET MAUI Blazor applications. So Blazor is a new web framework that enables the building of client-side web UI using .NET. But sometimes, say you want your web application to be on other platforms as well. So now what you can do is host your Blazor components in .NET MAUI applications to build cross-platform native apps using web UI. And those components run natively in the .NET process and render web UI to an embedded web view control using a local interrupt channel. And so this hybrid approach really gives you the best of native and web, and your components can access that same native functionality through the .NET platform using the .NET Base Class Library and render that standard web UI. And so basically your .NET Blazor apps can run anywhere that MAUI can. So in your iOS, on your Android, and all of that. So you can write your Blazor code and have it as a mobile application. So basically, if you do getting started with that, I'm going to see if I can open some other code for you. When you do a brand new one, do I have it on here? I might not have it on this computer. MAUI app. I have a lot of things I was playing around with. That's okay. But basically, if you've ever worked with Blazor before, when you create a new Blazor MAUI hybrid that's also a template option within Visual Studio, what you get is the same starter template that you would have with those Razor pages for your Blazor application. So in my slides, if I go back to the previous one, this image here is the WinUI desktop application of the Blazor hybrid, and it's the same exact template that you have within your Blazor app. So you're writing your Razor pages, and you can reuse that information. So you can either go from having a web application, if you're a Blazor, you have your website written in Blazor, and you can port it over to MAUI and share some of those components and images, or you can go the other way around. If you are just a Blazor developer starting out fresh and you want to keep using Blazor for your mobile apps, you can do that as well. So there's even more flexibility with what we have with Blazor, which is really cool. So basically, I am really excited about all of this. It makes it so that .NET developers coming from different parts of the .NET ecosystem can really get started on all these different areas. Makes it a lot easier to pick up writing mobile apps if you come from web, and even expanding into all the other areas. And because it's all written in C#, if you want, you don't even have to try and figure out some new templating. You can use those modern application patterns, or you can stick with what you know if you're familiar with the Xamarin Forms world, and use those patterns that you know and love. So there's a lot of flexibility that has now been introduced. They're working on these performance improvements and making it really a productive space for developers to work on, and really creating that code-first development experience. So if you're like me, a .NET developer coming from a web development background, you already have the skills you need to get up and running fast. And Scott Hanselman, one of the partner program managers from Microsoft, says that we no longer need to hire mobile developers or web developers. We just need .NET developers. And with the re-arch of the UI controls, I'm very excited to see what we can do with .NET MAUI. So where are we now? If I quickly open up the roadmap, as I mentioned, it's been delayed. So it was supposed to come in November, but we're a little bit out from that. But you can check this roadmap to see the upcoming milestones and things they've already accomplished. So they have some bug fixes and things that they're still working on now. There's another preview coming sometime next month, so we should see some more updates and things improving with the life cycle over the next month. And they'll continue to update things in December and into the middle of next year when they plan to go generally available. You can also check the status report page, which shows you exactly what is done and what it still needs to be worked on. So we have our different views. There's still some things with the way board buttons look that they're working out. Carousels is something they're still working on. Checkboxes are all there. But basically, you get the idea. You can scroll through and look at the different components and see what's done and what is still sort of in progress. So this can help you when you're creating MAUI apps at home and really figuring out what you can do to get started. So other than that, we have, if I can go to my next slide. So we have heard a lot about what .NET MAUI is, how it works, how it came to be. We heard about the .NET unification and all of the work that Microsoft are doing to really get this one .NET. And they're working on a whole bunch of improvements from the existing frameworks that we had, and they're going to make it a really nice, flexible framework for us to build mobile applications and desktop applications, which is nice. So we saw a little bit of code. Apologize that I couldn't show you it actually running, but I hope that you go out and are inspired now to go do the MAUI tutorials, open up Visual Studio, say new MAUI project, and take a look for yourself and hopefully see the cool hot reload features and all those things that they have going for you there. We've also seen a little bit about the community toolkit and all the great work that's happening in the community to support MAUI and also make sure that it's a really good application for us. So before I finish, I would also like to give a shout out to the partners of the conference. Thank you to all of them. And also thank you to the communities that are supporting this conference as well. I'm excited to see a lot of ones that are focused towards women in tech. Obviously, that's something that's near and dear to my heart. But overall, thank you very much for tuning in today. If you scan the QR code on the screen or you go to the link there, you can access all the resources that I used today and even my slides as well. So thank you again. I think I have just a couple minutes for questions if we do have any other questions that I missed.
We have one question.
Hello, Melissa. We have one question here.
Here we go.
Is my application lightweight in terms of size and with compared to Android and iOS native applications?
Yeah, so because it is compiling down to a native application in the end, it is comparable in size. Obviously, it'll depend on what you put into your application, but it's more lightweight than one of those frameworks that doesn't go down into a native app in the end, if that makes sense.
Yeah.
Cool. Any other questions for me today?
No, for now there is no questions.
All right. Well, yeah, thank you very much for everyone who tuned in. And I think there is also a feedback option going around as well. So I'd love to hear what you thought of my talk today and how I could improve as well. But thank you very much. And I hope you enjoy the rest of the conference.
Yeah, that was a nice session, Melissa. Thank you.
Thank you. See ya.
See you. Hello, everyone. Hello. Hello. Am I audible?
Yes, I can hear you.
Yeah, okay. So I would like to invite Asenka for the next session. He's gonna give us a talk on a decentralized reference architecture for cloud native applications. So stage is your.
Thank you. Can you share my slides, please? Okay, great. We go full screen. Okay, good morning, good afternoon, good evening, everyone. It's a pleasure to be in this conference, and I would like to thank the program committee as well as organizers for inviting me. I'm based in California, and it's 11:30 p.m. for me, but still I'm excited to share this concept with you. So before jumping to the topic, I would like to give a quick introduction about myself. So I'm the chief evangelist at WSO2, but coming from a strong product engineering and product architecture background, I'm on the open source arena for a while. I'm a committer of Apache Software Foundation, and most of my efforts are on distributed computing and middleware development. So as the deputy CTO, I authored this architecture paper, and the today's session is going to be around that. And as the chief technology evangelist, I am telling the WSO2 story. And WSO2, we are a technology company providing open source technologies focusing on API management, integration, identity, and access management. If you are interested, you can go to wso2.com and find more information. So during next 50 to 55 minutes, what I'm going to do, take you through these three areas: why I create a new pattern, and how this pattern is created, and what it is basically. And if you want to find out more information, I have put the URL at end of the slide, so you can go there and take a look. The entire specification released under Creative Commons 4.0. So feel free to provide feedback, send an update using a PR, or even you can criticize. So we are welcoming your feedback. So I get invited to many architecture conferences to pitch this particular style. And then when I see the audience, when it was physical events, I get this feeling from the audience. They come to the session because of the interest about the topic, but they have this question, and a question of whether this guy is smoking, because there are a lot of architecture patterns are available, and industry thinks microservice architecture is solving almost every problem that we have. Actually, I wasn't smoking. There was really good motivational factors for me to define this architecture. The key motivation factor was the gap that we identified in the market, or we found a mismatch. Basically, architects are looking for a reference architecture, but available reference architectures are not meeting the requirements that they are looking from a architecture style. The second motivation is basically the existing architecture styles are centralized and layered. So the layered architecture is creating a problem, because when you have layers, the layers creating gates, and gates are slow down the movement or efficiency of the workforce. And this layered architecture creating siloed teams as well, and those are creating more friction, and that is slowing down the productivity plus agility of an organization. Then the most of the architecture diagrams architects are drawing looks like this. Those architecture diagrams are very clean, modern, well aligned. I call them as PowerPoint architecture because if you look at the enterprise looks like this because we have a lot of data, we have a lot of systems that we purchased during last 2 decades, and we can't just throw them and create a new architecture style. So basically we can't just move into greenfield applications overnight because we have a lot of legacy and monolithical applications inside the enterprise. And if you look at deeper into the enterprises, legacy and monolithical applications are more than these microservices and greenfield applications. And another thing we identified, most of the reference architectures are either addressing brownfield or they are addressing greenfield. So we thought we need to define a new architecture style that can address both spectrums. Then another thing that we identified, most of the reference architectures are available are not reference architectures per se. Why I claim that? Because those reference architectures are specifically bound to a technology or even bound to a specific vendor. So those are not vendor and technology neutral. So that's why I call them as reference implementations. If it is a good reference architecture, it has to be completely technology neutral as well as vendor neutral. So that's another area we thought we should address. Then the underutilization of the technology, because if you go to enterprise and talk to architects, they will say, I have a Kubernetes cluster or I have a Kafka message broker, but I can't use it because my architecture is not flexible enough to do that. So we thought of, okay, we need to provide that flexibility for the architects as well. Another issue in the industry, there's a gap in between the architecture, development, and deployment. If I rephrase it, there's a gap between architects, developers, and DevOps engineers. Architects architect something, and then developers build something slightly different, and DevOps go and deploy something completely different from what architect thought. So we thought we need to find a way to bridge this gap and connect these three user personas as well as connect the artifacts generated in each and every stage of application software development. Then microservices creating another complexity because you get many moving parts now. Because of that, you will see a lot of microservices running inside your enterprise. So this is the famous Death Star diagram from Uber. So you need dependency management, and we thought we need to address this issue clearly in the reference architecture that we are going to define. So before moving to the new architecture style, let's take a step back and look at what kind of architecture patterns we used so far. So if you look at the timeline, in 70s, we started with monolithical architecture styles that the user interface, business logic, and the data bound in single process. And it moved to a two-tier architecture with the advancement of data technologies. And then most interesting era came the three-tier architecture that the data, business logic, and the user interfaces got into 3 tiers. And there were few sub patterns of 3-tier architecture like model view control 2 came during that time as well. Even I started my career during this interesting 3-tier architecture came into the picture. And then the 3-tier architecture moved to service-oriented architecture. What happened during that time, the business logic got wrapped inside services and APIs. And then event-driven architecture, web-oriented architecture type of service-oriented architecture styles came into the picture as well. Then it moved to microservices architecture, and now we are at this cell-based architecture level. So what I want to highlight here, we were moving from layered and centralized architecture into a segmented architecture, and now moving to a completely decentralized architecture style. So this is a timeline, and depending on when you started your career in software engineering, you might have experience about these different styles. If not, you can go and Google about these styles as well. Even I authored an architecture paper about layered and segmented architecture. So if you are interested, you can go and take a look about that as well. So this is a layered architecture that I identified long time back, I think around 2010, 2011 time frame. And it is not a typical layered architecture because this is two-dimensional, that all the system of different system of layers are coming in one dimension. And then I use the application development lifecycle and quality of services in another dimension. So we use this architecture in many solution development, had many productive discussions with architects, and still some of the organizations are using this architecture style. So it was a success story, but there was an issue that we identify around 2011 timeframe. A platform that we built with an agile team failed to deliver this platform till 3 years after they released this app platform. There were around 100 APIs, 60 message flows, 80 services, and n number of databases connected to the system. And it was multi-tenanted, and they had 3 active tenants when they went into production after 3 years. But the project was not accepted by the business, and we were wondering why this took this much of time, because they are following agile principles. Then we realize even they operate in an agile mode, the architecture is not agile enough for them to be truly agile. And it was an eye-opener for us. So we thought we need to take a new way, or kind of look at a new do a new paradigm shift that to the industry to solve this problem. So we were looking at more of a agile iterative architecture after these incidents. Same time, microservices came into the picture. There were a lot of theory behind microservices at that time, but we looked at people who went into production with microservices like Netflix, Uber, eBay, and Gartner. Gartner even defined some concepts around microservices. So if you look at all these 3 examples or 4 examples that I have listed, they had a common pattern that they put a layer on top of microservices when they went into production. So Netflix called this layer as APIs, Uber called this layer as edge gateways, eBay called this layer as API facade layer, and even Gartner came up with this concept called a mini services layer on top of microservices. So if you look at the business definition and technical definition of the services, you will understand why these organizations did this particular exercise and brought a layer on top of core microservices. So this is a technical definition of a service, and it is not much. If you look at the code, it's just a code snippet that you annotate and make it a service. It's basically an interface that you can access through the network, or it generates a network accessible interface for the service, and it has a message format, and it has a binding that is listening on a port, and that is a typical service if you look at the technical definition. So business definition of the service is drastically different. The business is looking for a solution for a business problem. When you try to create a solution for a business problem, you have to connect number of services. That's where the composition, service composition, or a composite service or a gateway come into the picture, and you have to connect these services using a choreography or orchestration type of message integration patterns. So if you look at the technical definition of a microservice, that is not vary too much. It's again, you divide that monolithic service into small chunks based on the scope, not based on the size, because a lot of people do this mistake by dividing microservices based on the size. It has to be based on the scope, and scope defined based on a single purpose done by a set of done by a single service. And the code will look same, that you write the code and you annotate it, and it becomes a network accessible interface. So the business definition of the microservice, again, it has to provide some business capabilities in a modular fashion. And when you try to provide a business capability, again, you have to connect number of microservices. That way, you have to use a gateway or a composite service as well. So this is the reason behind why these organizations try to put a layer on top of core microservices. And during that time, 2011, 2012, the architecture looked like this. Even you had microservices, it was inside a layer, and again, same layered architecture modified with microservices. And some of the organizations, they enhance this architecture by having segmentation inside each and every layer, that I call it as the segmented architecture. Even some organizations move to this concept called platform of platforms, that same layered architecture duplicated for each business unit and deployed separately. So all these styles, the segmentation, platform of platform, were addressing some of the concerns, but it was still layered architecture. So we hit a dead end. Basically, the whatever the improvements that we did for the architecture didn't come out from that layered style. So we thought we need to find a new way to address this problem. So that's where we started looking at few things. One is quantum computing. Second thing, we looked at some of the distributed computing concepts used by Kubernetes. And interestingly, we looked at biology and system biology. That's where the cell name came into the picture. So the cell is the basic structural, functional, and biological unit of all known living things. So that's why we thought even an enterprise, a complex enterprise, looks like that. So this concept of a cell is a really good way to address this issue. That's where the name cell-based architecture came into the picture. So now let's take a look at what is cell-based architecture. So in the cell-based architecture, the atomic unit, we call it as a component. So a component can be a microservice, a component can be a normal service, it can be a gateway, it can be a database, identity component, message broker, like that. Any component you run inside your runtime, we call it as a component in this architecture, and that is the atomic unit. So set of components create a cell. So this is a cell. Inside the cell, you will get many components, and then there's a cell gateway on top of each and every cell. And if you are familiar with biology, even a human cell contains a membrane that does the communication in between cells as well as the things inside the biological cell. The same way, cell gateway is the controller or the communicator of the components inside the cell as well as with other gateways in another cell. So this is basically the units of enterprise architecture that we call it as the cell, and it is independently deployable, and you can manage it independently as well as observable as well. So while we are going through the detailed concept, you will understand how these three capabilities are incorporated into the architecture style. So we talk about you need to connect number of microservices, right, to provide a business value. So that's where the cell concept coming in. So that grouping of microservices that connect to a gateway is what we call the cell, and that is where the cell boundary comes when we map to that business and technology definition of a service or a microservice. So you might have this question, what is the ratio between cell and the components? In most cases, it is one to many, and in some cases, it can be one to one. Excuse me. So that's the usual ratio, and in some rare cases, it can be one to one. As an example, a message broker or a database that you define as a cell, it can be one to one. In other cases, you will get many components inside a cell. So you need to communicate within the cell as well as between the cells. So that's where the connected cell concept coming into the picture. To do that, we are using this concept called a control plane, data plane, and a management plane. So my analogy to explain these three concepts is a train system. If you look at the control plane, those are the rail lines. And if you look at the data plane, that is the actual train compartments that takes the passengers, or in network computing, that's basically the messages that going between different hops. And then in somewhere in the train system, you get a control or a management layer that they monitor and then configure these different type of routes. That's where the management plane come into the picture. So those same concept apply in networking, and we are using those three concepts when doing the communication within a cell as well as between cells. So it's basically contains with two layers, a local control plane and a local data plane inside the cell, as well as there's a global control plane and a global data plane. So I call them as local mesh and global mesh. If you are familiar with service mesh technologies, this is service mesh plus plus. That is more than service mesh, that you have two meshes here, a local mesh and a global mesh. So the cell communication happens in this way. The calls coming to the cell, or the ingress calls, should always come through the cell gateway. So that is a rule. But if there's an egress call going out from the cell, it can use different type of patterns, like it can use a sidecar, it can use the adapter pattern, or it can use the ambassador pattern as well. All these three patterns are valid, and even you can do a direct communication from a component to another cell gateway. But every ingress call should go through the cell gateway. That is one rule we have in this architecture style. So the communication happens through gateways, and I call this as a API first architecture as well. Why I call it as API architecture, I'll explain in this slide. So the components inside the each and every cell expose the capabilities using an API, and then the capabilities you are exposing from the cell expose through the cell gateway as an API as well. But it's not only RESTful services. You can use pull APIs using RESTful, HTTP, and gRPC type of styles, and then you can have push APIs like events using JMS, AMQP, SMTP type of protocols, and then there can be streaming APIs using Kafka, MQTT type of protocols as well. So entire communication happens through APIs, and you expose these capabilities using different kind of APIs. And if we dig in deep into this concept, even I categorize APIs into three buckets: utility APIs, domain APIs, and edge APIs. In most cases, the cell APIs exposed by the cell gateway, we call them as domain APIs, and there will be a edge gateway layer that exposes the edge APIs that I will explain when we get into the enterprise architecture view of the cell-based architecture. So the gateway on top of the cell, or the cell gateway, creates some governance, because it's automated governance, that all the ingress calls are going through this cell gateway. Because of that, we can enforce policies at that level, as well as the gateway can act as a observability layer that can capture these messages going through the gateway and then feed into a observability layer, as well as it can link to a policy store and then pick these policies and do the policy enforcement as well. So that is the beauty of using a gateway pattern, and by default these capabilities will inherit to the architecture, because each and every cell contains the gateway, and components inside the cell is secured by this cell gateway as well. The security of the cell is really important. We have identified two common patterns. First pattern is basically a self-contained cell, that all the security decisions required to make authorization, authentication, or entitlement decision can make by the cell itself. The local control plane will contain a security token service, and it will do this work. So that is one common pattern. The second pattern, sometimes the local control plane or the STS inside the local control plane cannot make this decision, and it might require additional attributes. So it will go to the control plane in the or the global control plane, and it will talk to a IDP and get these different type of attributes. And sometimes IDP might connect to many policy information points, so PIPs, and get this additional information as well. To make it more efficient and high performance, the pattern 2 can improve by caching some of these additional attributes inside the local control plane. So basically, if we look at this architecture based on security principles, the cell gateway is a policy enforcement point, or a PEP, and then the STS acting as a policy decision points, or a PDP, and the IDP acting as a policy information point in this particular architecture. Like that, you can map it to the security concepts. So the developer experience is really important when it comes to an architecture style, because I explained about the problem that there's some gap in between architects, developers, and DevOps. So that's where the developer experience matter a lot. So developers will do many activities. So they might create a brand new cell and then add components to the brand new cell, or they might have microservices already written, so they will group them and create a cell by using existing microservices. They might update an existing cell, or they might create a new version of an existing cell as well. All these activities are possible. But if you look at what they are doing, the typical developer activities will not change. A developer will look at the requirements, write a component, commit it to the local repo, test it, and then debug it. And once the tests are completed, he or she will push it to the remote repo, and CI/CD process will kick in. So CI/CD process will deploy these components into a cell, or it will redeploy the entire cell. It totally depends on what type of infrastructure that you are using. If you are in a container-friendly environment, you have the flexibility to deploy an entire cell. But if you are in an old hypervisor-based infrastructure, you will not have that luxury. So you might have to deploy a component itself as well. But those two patterns are valid, and you can utilize some of the container and container orchestration systems capabilities to enhance this architecture. In some cases, you might not have a very rich CI/CD process. Even a situation like that, a release engineer can do this task by running few DevOps scripts and deploy a component or redeploy a cell. That is the developer lifecycle. And the lifecycle of a cell, basically, each and every component, like you see in the right-hand side diagram, will contain a version. And in some cases, same component will have many versions running inside the cell, depending on the usage. And each and every cell contains a version as well. So in different environments of your development life cycle, you will have these different versions of the cell, and you can use different deployment patterns to deploy these cells as well. So basically, it creates a structured agility that there's a version inside the component. So you have agility at the component level. And then you have the agility at the cell level. And you have agility at the enterprise level. So that's why I call it as a structured agility. And there are many other capabilities coming with that concept. So there's dependency management, one motivation factor that I highlighted at the beginning. And then these things get auto-wired using the mesh concept that I explained, using the local mesh and the global mesh. And these are highly reusable because you expose the capabilities by using an API. And APIs creates the really composable enterprise that you can reuse most of the capabilities that you build. And this enhanced the microservice and cloud native architecture styles as well. And all these components or cells can deploy by using blue-green deployments, canary deployments, and mix of these things that we call as a rainbow deployment as well. So those are individual components, like what are the components inside the cell, and then what are the architecture unit or the cell concepts that involve in this architecture style. But that doesn't help to build larger systems, right? So you need to look at how this connect to enterprise architecture. So we are going to take a look how cell-based architecture can incorporate it with enterprise architecture. So if you look at a holistic view of how an enterprise will look like using cell-based architecture, it is like this. There are a bunch of cells running inside the enterprise, as well as there are other cells that we connect outside the enterprise as well. And as I explained, these capabilities are exposed using different type of APIs, streams, and events, so on and so forth. So with that, we can categorize cells as well. So these are the categories that I have identified based on different type of implementations done. But if there are new types required, we can introduce them as well. But I would say almost every use case that we can find in the current market dynamic can be addressed by using these cell categorizations. So first cell type, we call them as logic cells that contains microservices, functions, micro gateways, lightweight storages, like that. And then there are integration cells. So micro ESBs, integration microservices, and caching type of technologies will go inside integration. Then there are legacy cells that you can't convert into a greenfield. What you will do, you will put a cell gateway in front of these legacy systems and make them as a legacy cell. So those are the existing systems and legacy services. And there can be external cells, because as an organization, you have to connect with SaaS applications that you are utilizing, like HRM systems, CRM systems, and many other these type of capabilities. And you have to connect with partner systems as well. So when it comes to the enterprise architecture, you treat them as external cells. And there are data cells like relational databases, NoSQL storages, file storages, and message brokers can act as data cells. Then there are identity cells. IDPs and user stores will go into that category. And last but not least, you have channel cells. Those are the web applications, mobile applications, and edge processing or IoT related applications goes inside the channel cells. So logic, integration, legacy, external data, identity, and channel, those are the cell types that you can find in a typical enterprise. So let's look at reference implementation. I divided the reference implementation into two levels, level 0 and level 1. So this is an example that it contains a bunch of cells, employee, order, customer as first level cells. And if you look at the employee cell, it connects to a user store, and then it connects to a HR system that act as external systems. And then it connects to a data cell, as well as it has a connection to order OMS system, and it goes through that particular gateway of the OMS system, and it exposes an employee API that connects to a mobile or an order management application. Then there's the order cell connects to the order management system or the OMS, and it exposes a order API as well. Then there's a customer cell connects to a CRM system and external CRM system, as well as an internal CRM system. So we can treat the internal CRM system as a legacy cell, and the external CRM system is basically a SaaS application. So you can treat it as an external CRM system. So that is how, if you map this concept into a real world example, it looks like. And we have built many complex systems using this particular architecture style. So let's dig in deep into the architecture, and this is the level 1 of reference implementation. So my definition of level 0 and level 1, level 0 is a technology and vendor neutral architecture. L1, you map the technologies and particular vendor products into that. And if you use the same example and map it to technologies, it might look like this. So basically, I have used bunch of WSO2 components and then some other technologies as well, like Nginx, Spring Boot, and then you have this different type of user interface technologies like Angular, React, so and so forth. Then the external systems are Workday as the SaaS HR system, Salesforce as the SaaS CRM system, SAP as the internal CRM system, and the technologies used to deploy this vary. Some are using Docker and Kubernetes, and if you notice, some of the cells are using VMware, like virtualized environment using hypervisors. So this is an example, and what I want to highlight here, you can apply any technology based on your preference. So that's the beauty of this architecture. It is not bound to any technology or any vendor specific technology. Based on your technology portfolio or your desired technologies, you can use them and build a system without any issue. So these are very human-centric architecture. So you know this concept of two pizza teams, so autonomous teams. And those teams require a boundary as well. And cells are creating a nice boundary for these two pizza or autonomous teams to operate, because self-organized teams have to plan, build, test, run, and manage these applications. So this cell creating a boundary for that. Now you might have this question, how I can define the cell boundaries? So the one advice that I can give is domain-driven design. So if you're following the domain-driven design concepts, you can either use a domain as a cell or a subdomain as a cell based on the granularity level of the domains that you are defining. So that's a good way to identify the cell boundaries that asking when I give them consultancy or advice on this particular architecture style. So now as a technologist, you might like to adopt this particular architecture style, but business will not care whether you are using a layered architecture or a decentralized cell-based architecture. So that's where measuring the success is really important. So I advise many users who's trying to use this architecture style to stick to couple of metrics. So first thing is we call as the flow efficiency. Because of the decentralized and agile nature of this particular architecture, it increased the flow efficiency. And flow efficiency is basically compute by taking the actual productive time and wait time. As I explained in the motivation factors, when it comes to a layered and centralized architecture, the wait time is higher than the productive time. As an example, if you're operating in a layered manner, then to create a database, it takes a couple of days. And to deploy something, it might take a week. So those are the wait time. But with this kind of an architecture style, you will increase the flow efficiency by making the work time is higher than the wait time. And that will result in another two things. One is called the mean time to repair, or MTTR. So basically, because of this agility and the componentized nature of the architecture, you can quickly detect something and repair something. So quickly detecting something, we call it as mean time to detect, or MTTDD. So basically, flow efficiency, mean time to repair, and mean time to detect. Those are three good metrics that you can use to show the business how this particular architecture style making an impact and how you can measure the success. So if I summarize, so cell is self-contained, and cells are the unit of enterprise architecture, and it can independently scale, and it has a local data plane and a control plane. Then the architecture-wise, this is decentralized, microservices compliant, cloud native, and this is completely technology neutral, and it is human-centric, and even you can build APIs as products as well. In this particular example, you can treat a cell as a product and expose these capabilities through APIs. So those are the overall concepts that we can identify this as a architecture style. So the contributions to this concept done in multiple forms. First thing is the architecture paper. So that's where the reference architecture catalog that we have created. And if you go to github.com/WSO2 reference architecture, you will find the complete implementation. So I didn't stop at that level. I took another step by defining a methodology. So that's where the reference methodology, second URL, coming in handy. That's basically a process or a methodology to implement this architecture. And if you are planning to use this architecture style, that might be a really good reference. And my analogy for a methodology is a GPS system. So when you are moving in a path, or if you are going in a journey, a GPS will help you and guide you. Even if you lose the path in the middle of your journey, the GPS will reroute you, right? So same way, a methodology is really important in case at the middle of this particular architecture journey, if you get distracted or lose the track, it will put you back in the correct track. That's where a methodology will come and help. And inside WSO2, we introduce a new language called Ballerina, and Ballerina can heavily use to build components inside cells. That's where you can go to ballerina.io and get more and more information. And it is completely cloud native programming language that you can use to build component. And other than that, at WSO2 we have released many products, open source products that you can use as component. As example, API gateways, IDPs, mediation components can be used from the WSO2 stack. And then the celery.io is a pet project that we did some time back. So it's about to kind of verify this concept. We created that project on top of Kubernetes. And if you are interested of developing this particular architecture style, celery.io can be a good reference. So we are not continuing that project because it's a pet project that we created as a proof of concept, but still it is valid that you can take a look. And in Celery, we used Kubernetes pods as components and Kubernetes CRDs or namespaces as cells. So you can take a look at how it looks like. So if you like to continue this discussion, these are my contact details. And if you need to get more help, you can get strategic consulting help. That's where the first URL. And you can email me. You seek the email address that I have put here. And I'm active on Twitter and LinkedIn. You can follow me on both channels and get connected. And I'm happy to help you if you required more additional help on implementing the same architecture. So that's all I have lined up. And if you have any questions, I'm happy to answer during next 5 to 8 minutes. Are there any questions?
For now, there is no question.
Okay.
So we'll wait for 1 more minute so that.
Yeah, sure. Looks like there are no questions, right?
Yeah.
Yeah, great. I think it was helpful. And I would like to thank again for the program committee and the organizers of the event, and hopefully talk to you in a different event on a different topic as well. Thanks again.
We have one question
Oh,
here.
okay.
Do each cell have its own gateway?
Yes. So that's the idea. Each and every cell will have a gateway conceptually, but when it comes to the physical deployment, it has to be a cluster because you need to have the high availability. So that's where you deploy it in a Kubernetes pod in one implementation, or based on your infrastructure, you can decide it. But the answer is yes, each and every cell contains a gateway.
Great. So thanks, Asanka. That was a nice
Okay.
session from you.
Yeah. Thank you very much.
Yeah. Thank you so much.
Bye.
Hello. Hello, Michael. Okay. I would like to welcome Michael to speak on Azure in a cost-effective way.
Super. Thank you for inviting and also introduction. Let's start our talk.
Yeah, the stage is yours, Michael.
Thank you very much.
Thank you.
Okay, it's working perfect. I hope you can hear me correctly. Welcome today on my presentation about cloud in a cost-effective way. My name is Michał Kowski. I'm solution architect. I'm working in Objectivity. Together with taking care about the solution and the architecture, I'm also by heart developer and a team leader, especially connected with .NET technology. I'm also Microsoft MVP in two categories, in Azure and also AI. Together with that, I love to travel. I love to take photographs, and also I love to share my knowledge. So we can find a lot of materials created by me on my blog, and also on the Twitter, and also my GitHub account. But today, the session is not about me. Let's focus about the cloud. Let's focus about the cost, and let's focus how we can do it in effective way. As I previously said, I'm connected by heart with .NET, so I'm working mostly in with the Azure. But looking on the topics I would like to cover today, those topics will also cover elements that are available in other clouds. So you don't need to, if you are familiar with other clouds, please stay on the session, because you will find here a lot of tips that you can use in those other clouds. What I want to show you today, I want to show you how we can work with the cloud, how we can work with the cloud in the cost-effective way, and what we should check when we are working with the cloud. And the most important part when I think about working with the cloud, it is that we should do it from first day of the project until we just turn off the light, especially when you think about the costs and with the services that we are using in our cloud environment. But probably we are starting to thinking why I'm saying that the cost management, that cost optimization is so important. When we check the report, we find the information that optimization of the cloud cost is one of the top 5 elements that we should remember about it. So because of that, you can see that 61% of people are just saying that for them cost saving is top one of cloud initiatives in 2021 year. The second item on the list is migration workload to the cloud. The third one is better financial reporting on the cloud cost. So you can see that the first and the third element are strictly connected to the cost optimization. Then we want to use a cloud like our first strategy when we are going with our solution, when we are thinking about what we want to use to deliver our solution, and also we would like to expand the use of the containers. This is the data from 2021. If we look 1 year backward, then we can see that the top 5 elements that have been selected are the same. You can see that even in 2020, the optimization of cloud cost was more important than in 2021. And there's a small difference between what is on the third and the 5 element. But you can see there is like a cost optimization, cost saving, and also reporting. This is very important because when we check other statistics, we can see that 57% of people, of the leaders, have exceeded their budget. And those budgets have been exceeded more than 20%. And I'm sure if I ask you a question when you'll be sitting in the one room and ask you if, raise a hand if you have the same situation that you over exceed your budget, I'm almost sure that half of the room we had the raise hands. Why? This is because sometimes we forget about something. Probably you have a smile on your face, but forgetting about something, it means that, for example, we forget to remove some resources. We forget to delete something. I know situations that people just finish after a few days with the build that have like $20,000 of the cloud because they was learning or making a proof of concept of very expensive services, for example, for reporting. Sometimes we don't know how solutions work. In one of the projects that I have been working last time, we was using the tool to move the files between two storages. And I would say it was quite easy thing to do, but we didn't know 100% the implementation of the tool. And finally, it looks that the tool was using too much listing on the storage that we expected. And those actions show us that the cost of the initial cost that we expected will be higher. The good thing on our side is that when we just onboarded the tool to use in every scenario, we just selected one of 20 scenarios and just run it. And we just spot the situation on the smaller amount of the data, and then we can react, because if we would run this on the bigger scale of the data, the cost could be higher. The other example, my teammate, when we get like a budget for checking Azure integration with the low-code platforms, have just provisioned Cosmos DB with default settings, and it did like a last action of his daily work, and he just do it, turn off the computer, went home. And next day we have like a few thousand bill from the Microsoft because we have so huge Cosmos DB container provision and we didn't use it at all. So we can see that even the people that are working on the daily basis with IT, with the cloud, have the problems with cloud costs. And looking the other number that is coming to my head when I look at the cost, on the one of the latest report, I saw that the Azure cost by average can be reduced by 30%. So look how big we can optimize the cloud. And probably, I hope you have a smile on the face when you can hear me that looking on my all experience of all organizations that I was working in, it is much more easier to like buy a service that costs a few $1,000s in Azure or on a different cloud than getting approval for buying a mouse. This is because with this procurement, this classical procurement, we have like a processes that we need to follow. We need to get like approvals and other elements. In cloud, when we're working with our customers very often trust us and very often give us a lot of possibilities to work with the cloud. If we want to feel more secure there, we should think about using Azure policies and other elements that will limit our possibilities, what we can do in the cloud, and somehow prevent for that kind of the actions. Let's think about what we can do and how we can work with the cloud. And the most important thing that you should remember after my today presentation is that the cost optimization is an ongoing effort. I already started this information at the beginning of the presentation that we should do it from the day one of the project until we just turn off the light and we migrate the project to some other technology. Why this is so important? Because Azure and other cloud, this is like a living organism. So during the time the new services are introduced to the cloud environment, the pricing is changing, some kind of the SLA, some kind of limitation are being changed, and also some kind of the services are being turned off. And working and providing the solution to our customers, we need to remember that we should help them to navigate in this ecosystem to optimize their environment, their application, their system. And today I would like to start from something simple. So let's imagine that we are building web application. Simple web application, like we have like a front end, database, nothing special. And when we're thinking about cost optimization, we should start from the design phase. How we should start it? The most important part is talk with your business. Why? Because when we are building an application, we need to provide the solution that will support business goals. And this is the most important thing that we as a technical architects, as a developers, we need to do in our daily basis work. We need to provide the business value for our customers. And based on those business requirements, we should figure out which type of the services is, which type of the architecture we should use in our environment. The tricky part is that in Azure and in other cloud providers, we'll find a lot of services that will provide very similar value. But the value will be provided by using different pricing, maybe with some limitation, maybe with different, not only prices different, but there may be also with a different pricing model. And we need to figure out which solution is the best for our customers. Also, the difficulties of that is that looking on Azure ecosystem and other cloud ecosystem, we have a lot of services that potentially we can use for doing that. And it is almost not possible to know every services and know how every services works. That's why we should at least know the possibilities what we can do with those services. And I want to do this example very simple today. And I know that when you see my information about the costs, probably you will have a smile on the face, because when you think about your solution, you are working with customers that cloud costs are higher than the things that are providing you as an example. But this is the purpose of doing in that way. It is to showing you how we should do it correctly and how big impact can be. And then later, we can use this knowledge for our bigger environment. So making it very simple, I mentioned web application, let's make it like ASP.NET Core, maybe with Vue. Then let's think about database. I have .NET in my heart, so maybe Microsoft SQL. And let's host this on the virtual machine. I especially use here like a virtual machine because I would like to use the virtual machine like a bridge between the people that are still using on-prem solution and the people that are already in the cloud. So looking on that, this simple architecture generates at the beginning some issues. First of all, the pricing. Each time when we are starting working with our application, we should think about the pricing. We should not assume that we know the pricing. The pricing is changing. The pricing is evolving. In looking on my experience, in most cases, is the pricing are getting more optimal for us. So it's every year those cloud services are getting cheaper. But together with the pricing, also the model is changing. For example, when I was jumping into serverless mode, the Azure function do not guarantee any SLA for the consumption model. At the time, if I wanted to use serverless with full potential, I needed to deliver this high availability disaster recovery in different way using different architecture concepts. Later, a few months later, maybe 1 year later, they introduced an SLA. So those small change in the definition of the service make me that I can just remove from my environment quite interesting component that was somehow allowing function to get the reliability on the level that my customer expected. Then estimation. Estimation, it can be very difficult at the beginning, but we should make it smart, and we should not afraid of doing estimation, because each time when we are doing estimation, we are learning something. And looking on that, we have like a first place where we can compare the thing when we deliver our solution, how it works with the estimated values. When I working with estimation, and especially in the cloud one, I encourage you to provide like a range, to provide your customers information that probably your environment will cost between this and this. Especially for the people that are just jumping from the bare metal environment, I did it too. And honestly, when we was estimating the server for the classical on-prem solution, very often we wanted to make it a bit bigger. This bit bigger means that it costs us a bit bigger to just somehow reduce the risk that we will not select too small server. In the cloud environment, when we make this mistake, it's very easy to just use autoscale option or just turn off environment and provision new one with the correct side. And also, this is it is working in other side. If we deliver something too big, we can reduce the size very easy. And this is very important to not overestimate that. And that's why I prefer to use the range and provide you information that probably with autoscale options, your solution will cost between those two values. The third point is optimization. When we have the estimation, we have like a starting point to which we can measure, and then we can optimize the whole solution to be optimal for our customer. And I always encourage you to measure, to make optimization if we can see that something is not used by us. There's like a pattern. For example, every Friday, people are using our system, like for example, hours reporting. So we can adjust the solution, not by just guessing, but looking on the statistic that we have in the system. So when we know those elements, we can start thinking about our environment and our web application. I mentioned that I would like to use a virtual machine. So starting with the virtual machines, there's like a first challenge for us. There are different types and different sizes of the virtual machines, and we need to select correctly those types and size. Let's maybe start from the type. We should think about the typical usage of our application that we are building. Is it something like typical web application, something that is very common for different cases? Then probably we can use general purpose. So this is like a machine that should work in 90% of situation. But together with that, we have plenty of other options. Thinking about the machine that we need to use, for example, high computation. Then we have like a type that is compute optimized. We have like GPU optimized machine and also like high performance compute. Those elements have more CPUs than RAM or more CPUs related to hard drive. And this is optimal from your case. Maybe you would like to use computers that have the virtual machines that need to have like more memory or more storage. And this is very important for you because you are paying for what you are using. Think about like, let's think about example. Let's think about the telecom component that every last week of the month they are preparing a billing for the customers. And because in the cloud we are paying only for the resources that we are using, and we know that we need to use in this particular case a huge compute, then probably for this purpose we go with compute optimized virtual machine that will be turned on only during the last week of the month and then turn off after the calculation are done. This is beauty and the curse of the cloud environment that we can do it in that way. The next, when you selected the type of the machine, then we need to select the size of it. It's easy, at least in the theory. We need to select the machine that will support the traffic and the user behaviors on our site. Sometimes when the behavior is unstable and we know that we are focusing on doing something very cheap, and in most cases we don't need to use this virtual machine, maybe we should think about something like bootstable virtual machine that in the typical case it can run very smooth, but rather something smaller. But if there's like a peak that can scale up and use some kind of the credits to handle this traffic. If we make any mistake, of course, because of the cloud, we can change it in the later. We can adjust the size and the type of the machine. And we need to remember that in all of these cases, it will mean that we have like small outage of our services. So we need to be careful when we are doing that. And then I already mentioned you that virtual machines can be shut down when they are not used. So you should also implement your solution in that way that when we are not using our computers, let's turn it off and do not pay for them. Then deletion. If we are removing virtual machines, the virtual machines have a lot of elements that are connected to it, like hard drives, network devices, IPs, and other elements. So we should remember that we should always remove everything, not only the virtual machine, but also connected resources. So we know what the type of the size. Then we need to select the location. And this is also tricky because you can see here, this is an example of different prices on the different places in the world. I'm from Poland. Still, we don't have like a Azure region here. It's in the plan. It's already on the map. But looking, for example, if I would like to move my solution and deliver it in the France, you can see that between two regions, there's like almost $50 of the difference. So on this particular one machine, if I decide to host our solution in the France Central, I can reduce the cost about 25%. This is huge, but it can be tricky because on the one side, when we are delivering our solution, we would like to have the solution delivered as close as possible to our customers. So this is the first point. The other point that we should also include is that in some of the regions, not all the services are available. So we need to correct wisely. And this is a tricky part. The third one, that is, I think, the most difficult and the most tricky one is law and the different regulations. Sometimes we need to also remember about, maybe not sometimes, always is a better word. We should remember about regulations related to the branch of business that we are doing. For example, healthcare or maybe financial branches of the business, verticals have different type of regulation, and also some of the regulations said that we don't allow to, for example, leave the data from our customer. For example, in Europe, there is something like GDPR. This is like a law that is saying how we should treat the customer data. And it's very important to also include those regulations in our environment. In Poland, when we didn't have a cloud provider on our land, some of the systems are not allowed to be delivering to the cloud because of this regulation that we don't allow to move data outside of the Poland. So this is also element that should be included in your architecture. So as you already hear that when we are thinking localization, we need to also include some other elements. I didn't mention about the latency because maybe we'll decide that virtual machines can be set up in one region, the other services can be done in the other region, then we are adding latency. In most cases, the small one, if the regions are close to each other. Also, the latency can be added when thinking about moving the solution maybe in the longer distance from our customer. I already mentioned that some services are not available in the region, and also we should remember about additional data transfer costs. This is, looking at my experience and the work with the cloud, this is the element that we very often forget about, that we are focusing on the services and the cost of the services, but we are just don't remember about the transfers. If we have everything in one region, it's easy. It's the transfer between those services for free. But the first time when we just move the service into different regions, then we'll be charged for the transfer. And this transfer cost can be added maybe in not very easy visible way. For example, if we're building like a disaster recovery and we are adding additional SQL server to other region, then we are like provisioning in from the Azure SQL, and the and we are introducing those costs, but the environment is not informing us that those costs will be added. So we should also remember about that and be aware how the clouds work. Something like interesting probably, and we don't have a lot of possibility to change it, is that Microsoft has own exchange rates between dollars and the local currencies. Especially this is important for the people that are using CSPs, and you can see those differences can be up to 5%. At least in last week, the biggest difference was 5% between the local currency, between the official exchange rate and also Microsoft exchange rate. Last year, when I was checking, the biggest difference was 20%. And this exchange rate, based on my experience, are updated every week, at least last time. So in most cases, they're trying to be as close as possible to official one, but you can be also charged a bit, sometimes smaller, sometimes bigger. It depends what exchange rate Microsoft is using. Okay, we have selected the type of the machine, we have selected the localization, so we are on the perfect path to start having our machine and using it. The next thing that we should think about that is reservation. If we know that our solution will be used for a year, 2, 3 or more, we can reserve the resource. And when we say the cloud vendor that we would like to use the resource for the longer period, for example, 1 year or 3 years, then we'll get a discount between 30 and 60%. And this is super because we are reducing the risk for the cloud provider, that we just say that we don't need to use the resource anymore, and they need to be aware of the situation and need to prepare for that. But look at the costs. On the 1 year, this is like the 34%. In the 3 years is 56%. So it means also that if you take the calculator, very often for us, it can be more beneficial to reserve the instance of the machine for the whole year or for the 3 years and use it for a shortened period of time. But you need to just check it and think about what is the most suitable for you. The other option of before we go to the other options, there's a plenty of the services that already allow us to use reservation, and those leases ongoing and changing every half year, and Microsoft is adding new services here. As you can see on the screen, we have like two elements of the cost. The one element is the compute, and for the compute we can use the reservation. The second element is licensing. So in this particular case, we needed to pay like $80 for compute and $67 for the license. But if we have if our customer or we have a license with software assurance, we can reduce this cost to 0 and just use our license. This is valid for Windows virtual machine, SQL Server on VM, and also SQL database. The other option that we can reduce the license cost to 0 is just not to use machine with Windows and just use Linux operating system. Probably you can see I have a smile on the face, because like a few years ago, I would say it is not possible to host something on the Linux, and it is like a challenge. But as soon as Microsoft introduced .NET Core framework, a lot of our customers and a lot of people have started to migrate in .NET framework application to .NET Core framework to be able to run it on the Linux. Look on the previous slide. This is this cost of the license is about $70. And think about the organization of the solution that use the hundreds of virtual machines to support the customers. And they can save this amount of the money every month. So this number is getting very impressive and it's luring them to taking this decision. And this is one of the, I think, very, very common case that when it was available, the customers move to this solution. Looking on those few steps, we managed to reduce our cost from $154 to $33 by selecting region, by making reservation, running on Linux, and so on. This is one machine. Think about what will happen if you have like 100 of them, and this is only the cost per month. So think about the year or maybe longer period. When you are starting your journey into the cloud, you will see probably very often this slide. There's like on-prem that we are responsible for everything, that is infrastructure service, platform as a service, and serverless. I do not want to go deeply. On the blue is the elements that we are responsible for that, and you can see that if we are giving more those responsibilities to the cloud vendor, in this case Azure, probably we're just reducing the time that this is needed for our to manage those resources, but probably the pricing will be changed. And the cloud environments is working that way, that are giving us possibilities. Let's think about API. And looking at the previous slide, we have like a virtual machine that we are, this infrastructure as a service. We are getting from the cloud provider virtual machine with Windows. We are responsible for IaaS configuration, for the patching and other elements. We can select the CPUs, memory, and hard drive, and also we are paying per hour of the work. And then we have the app services. So the app services is platform as a service type of the service. Here, we are getting from the cloud vendor like IaaS that we have web interface for the configuration, and we don't care about the hardware and the operating system that are under the hood. We are getting like a platform that is allowing us to host the environment, and there are already in the service built in like a backup options and also possibility to auto scan elements. The price is a bit higher, but on their side we don't need to care about Windows and elements related to operating system. And the third element is Azure Functions. So this is like a serverless, and it introduces totally different pricing model. Here, our cloud vendor is saying that it will run for us like a small piece of code. We don't need to worry about almost anything, about infrastructure, about the possibility of the scaling up, scaling down. It will just automatically adjust to the traffic. And the pricing model is also here totally different. We are paying for real usage for number of runs of the function. So you can see here like 3 different services can provide the same value for us. And we need to select it correctly. And this is like a challenge because in cloud we have multiple possibilities. There's hundreds of services that we can select that you can use, and as I mentioned before, they can provide very similar features, and they have different pricing and different usage scenarios. I show you API. If we think about the data and storing of the data, here is like only Microsoft products. So we have Microsoft SQL on VM. Probably this was the intention of my talk, was to use this kind of services. But then later we can use Azure SQL, we can use Azure Cosmos DB, we can use the storage. I didn't mention here, for example, about other types of the Microsoft SQL possibility of hosting of on the Azure, and also other types like database. We have MySQL, we have Cassandra, we have Mongo, we have Redis that can be used under the as a database, and it's tricky. And each of those databases have different pricing, different usage model. For example, here like left half, so Microsoft SQL and VM and Azure SQL, this is like typical relational databases. When you think about the right side, like Cosmos DB and storage, this is like a document databases that can store the data, but those data are stored in a bit different way. Together with that, when we working with the cloud, we should also remember about the free services. There are multiple of products that we are getting for free for our customers, and also we should include those elements in our estimations and our architecture. This is especially important when you are onboarding new customer to the cloud, because then you have like a higher possibility that you'll be able to use those free services. Here as example, we have like a Cosmos 1000 RUs per second. App service allows us to create 10 apps. The thing that is used by me very often is Azure Function. We have like 1 million requests for Function app. This is huge amount of requests, and we can make quite nice working solution that are delivering the value for the customers. Not always it cover everything, but task related, some kind of automation, some kind of I name it gluing, just integration between those between two different services can be delivered by this type of element. We have even great notification hub, AKS cluster management, and Azure Policy. Azure Policy is a super service that you can just use to configuration to go the cloud to your needs. Then, when you're thinking about something for free, Microsoft has like a program for the startups. For 2 years, you can get $150,000 of money that you can use for cloud spending. Please be careful with that, because it is like a narcotic. I saw a few examples that companies use those money, delivered very nice looking and fancy architectures based on those bonus, because the cloud was free for two years. And then when those 2 years period ended, they hit the ground, and the cost of the cloud was too high for them. Looking at those examples, those companies managed to reduce the cost to level of 50-20% of the initial cost of the cloud. So this is very important, what I said in the beginning, that we should talk with our business, check their business goals and the requirements, and then adjust our architecture to it. On the startup, when we don't have, for example, a lot of customers in the beginning, probably I would prefer to use servers and other solutions that allow us to pay us less at the beginning, together with the possibility to scale very easy in the short time. And looking at those examples that I have in my head, this is on the one side, this is a good example that cloud can be very difficult and can be also like a very happy place for work, because those systems was using a lot of new fancy trendy elements. On the other side, those elements can be just changed and use other elements that was cheaper and was delivering the same value for the customers. So I have about 8 minutes, and just closing to the end of the session, I'll show you that the cloud cost management is not so simple, but it's also not difficult. There are different ways to meet the requirements. You should know the different services and also pricing. And I also just little touching for the information that there is some kind of limitations that you should be aware, and the pricing is changing. In most cases, it is going down, but you should also remember that not only the pricing is changing, but Microsoft is also sometimes turning off some services. This is like a living organism. The most important part is cost optimization is an ongoing effort. I also mentioned that in the cloud, we are using consumption models, so we are paying for what we are using. It means that we should remove the services that are not needed. We should turn off the services that are not needed. We should try to find elements that are not used at all at any time. So here on the screen, you can see that one of the storage accounts is not connected to our environment. Probably this is the thing that we should remove. Very often, we forget to remove some kind of elements from proof of the concept environment. So I would recommend you to have like an automation that is the deleting all of the proof of concept elements once a week, once every 2 weeks, and then we are 100% sure that we will not forget about something. Then cleaning in the cloud means also that we should turn off the virtual machines, remove not used files like backups, hard drives, and also what is very important, we should use correctly the way how we can store the information in the cloud. So for example, if we know that we will not use the resource very often, let's move the file into the cold storage. Here, it is very important to clean the data, so remove some kind of duplicates, move not needed data to our Hive. The things that we was not doing very often on on-prem world. Here, if we are doing those elements on daily basis, we can just reduce some kind of the costs and also improve our environment. Then, in cloud, size matters. I hope I showed it correctly. Here's an example of scenario that I saw in one of the customers. They was using the service was using in that kind of the way. You can see that it looks like a business application that is run between 7 and 7 with the 2 peak hours on 11 and 2 o'clock p.m. Looking on this pattern, the service is probably 30% too big if we want to look on the peak hours. So probably this is the first optimization. We don't need to pay that amount of the money. Then after this working hours, probably we can turn off the services or just use as small as possible to just have like possibilities to run it for somebody who would like to join during the night. For the to address these peak hours, probably I would recommend to use auto scaling options. So you can see here the middle of the on the box. So you can see how much money, if we just look on those elements like area, how much money we can just reduce by using those small optimization. And then the base, we should think about reserve instances probably, or use other type of elements. It depends, of course, on the cost. I talk a lot about the optimization of the cloud environment, but we should also think about optimization of our application. In Azure, we have a lot of services that are helping us to inform about some kind of the things that we could fix. And here's like information from the Azure SQL, and you can see that we should create some kind of index. We should remove some kind of indexes, and when we implement this recommendation, we can just get reduction of the consumption of the cloud. And finally, we can just decrease the size of the services that we are using. So there's also we should think about our application, our system, to be able to work with this in correct way. Refactoring. As an example, I show you movement from .NET Framework to .NET Core. Please remember that sometimes we are not able to avoid significant refactoring at the beginning, and the refactoring will just generate some kind of the cost of the beginning, but we need to think about total cost of ownership, and then think of how those refactoring impact on the total of the cost. And then each type of this refactoring, we should think about like a project, and then just check if we should implement it or not. As an example, maybe one more thing. Non-production environments. For these non-production environments, they have different workload, different type of their services, and the two most important thing: turn off when our developers tester are not working at the work, and remember that there are like discounts for those non-production production environment. And do not afraid to leave the cloud. It means that sometimes you will find the services that are not in the cloud. And here's like a great example. You probably know the service have been pound, and you can see that when it has been hosted in the cloud, it costs $280 per month. When Troy Hahn decided to change a bit architecture and use Cloudflare, the costs have been reduced to 78 cents per month. So do not stick to the cloud, but think about also other options that you can use to optimize your solution. And just before the ending, just 2 tips that I would like to show you at the end, how you can start working with the cloud, and working with the cloud costs very easy. First of all, it is the advisor. So looking at advisor, you could get recommendation of what you should implement to avoid some kind of the cost. Here you can see an example, see that we can avoid $2,000 per year by implementing 5 recommendation. With this advisor, you get also advisor to other elements like security, reliability, and to the other types of the services that you're using in the cloud. So I encourage you to check every week, every 2 weeks, especially when you're starting your journey with the cost optimization in the cloud, what's happening here. And the second advice is control your spending. Just think about correct subscription design, groups, and tax structure. Then there's like reporting tools that can help you to trace the cost. You can see what you're paying for, what you're paying, and then based on that, you can think about what should be optimized and use the alerts. The alerts allow you to be informed when something wrong is happening on your cloud. Think about DDoS attack. Then when you don't have like an alerting setup, then it can be there can be a risk that the DDoS attack will not stop on the Azure infrastructure and on the cloud infrastructure. The infrastructure will survive, but maybe there's a risk that your credit card will be affected because of this auto-scaling environments in cloud possibilities. So just to summarize the talk, I hope I showed that there's a multiple options of the optimization. I hope you remember that this is an ongoing process, and you should be always updated with Azure pricing and Azure products. I don't say that you should know all the projects by heart, but you should know at least the possibilities of the most important products that are in the cloud. Don't be afraid of the modernization. Even in the short term, it will cost more money. Think about this like a project. Just calculate total cost of ownership and take a decision. And here's the first advice. Look on the Azure Advisor, especially at the beginning, very often. Later, probably you can reduce the frequency. It will help you to learn how to optimize the cloud and especially how to reduce the cost in very, very easy way. Thank you for today. Do you have any questions?
So far, there is no question. That was amazing, Michelle.
Super.
Thanks for yeah, that was great session. Like I got to know about the optimization techniques. Yeah.
Thank you very much. If you will have more questions in the future, please do not hesitate to contact with me by email or Twitter or any other way. I will try to help you.
Yeah. Thank you so much.
Thank you.
social media post கொடுப்பாரு beta பசங்க.
Hi Prajot.
Hi.
How are you?
Yeah, I'm good.
Yeah.
How are
Okay.
you?
So I'm good. Okay. So thanks Prajot for joining the event. So Prajot will be talking about WASH lockdown and operations, Sun Tzu and the art of monitoring. He has a very good experience in monitoring and other Azure activities. Go ahead, Prajot. It's all yours.
Yeah, thanks, Niveda. Yeah. Hi, everyone. So is my screen shared, right? I'm hoping you can see my screen, all of you. Right, okay. Yeah, thanks. Right. So welcome everyone to this session, right? We'll now start with my introduction. So I'm an architect working in Wipro. I have a total 25 years of experience in software, mostly distributed systems. I also work with robots and AI and big data, where we automated industrial robots using 3D cameras and all. So my latest work is with Azure for monitoring solutions, right? Monitoring data pipelines and all. So this talk will actually show some of my experience. I've also built monitoring systems for on-premise systems. Other than building the distributed systems itself, I'm also monitoring solutions for those distributed systems. So today's talk about art of monitoring is actually different from maybe other talks that I've actually tried to bring in some design philosophies and philosophy itself, right? And getting ideas from unexpected locations, right? And to the art of monitoring, right? And the lockdown that you faced in the last 1.5 years also is contextualized here, and we'll see how those learnings from the art of war book and the lockdown experiences can help with operations philosophies. So yeah, that's the agenda. So we'll talk about the creator of the idea, right? The art of war, and this is a software conference, right? So we'll be talking about more the art, right? Not the war, right? And why war has to be avoided, and what are the reasons, and how lockdowns help, right? So that is a different context I take, right? So throughout the session, you will see context switches between the war, lockdown, and operations, right? The three points we cover in the session. So there's an underlying theme behind this that we'll explain, right? The system when the slides go ahead. So then we'll talk about how to win the war, right, without fighting, right? And of course, I'll also be talking about monitoring systems, Azure monitoring systems, and monitoring systems in general, and the terminology around monitoring. Timer. Okay. Right. Yeah. So I've explained this. The table of contents. I thought I'll just show it pictorially how things, this points in the session relate to each other, right? So obviously, this session is about monitoring in operations, but I will be covering only the monitoring part of it. So we'll talk about design for monitoring, right? And of course, that means we need to talk about the DevOps part of it, and application performance monitoring and SRE, which is used in the DevOps scenario. And of course, the philosophy, right? The philosophy is where a lot of the Sun Tzu talk is coming, right? So how Sun Tzu's ideas are very useful in monitoring. And of course, there are other areas in operations, right? We will not be covering all the operations areas, just the monitoring part of it. Okay, so who's Sun Tzu, right? So he's a military general who lived around 2,500 years ago, right, in China, and he's been a very capable military strategist. Other than military strategy, he's also philosophical, right? And many of his ideas are highly philosophical and deeply thought-provoking, right? And he's been highly successful in wars. That's why he's popular now, right? So I think his idea, right, or advice is kind of non-intuitive, right? You avoid fighting. So you go to war, but you avoid fighting. So that sounds pretty non-intuitive, but it makes sense because his success actually speaks for itself, right? So you avoid fighting by managing conflicts, right? So some of the things that we may not feel as ethical, right? Like deceit, hide, guerrilla warfare, used to actually understand his enemies and win wars, right? With least losses to his side and maybe even the other side. So it seems what Sun Tzu actually got is actually could be influenced by the Taoism, right? Another Chinese philosophy, which was supposed to be created by Lao Tzu. So that is a pure philosophy, so Lao Tzu was not involved in wars. So it looks like so I will not be talking much about Taoism. I myself do not know much, but we'll be talking about Sun Tzu's ideas and philosophies in the session. Okay, right. So, like I said in the beginning, right, this the idea that we want to pick from the art of war is the art, okay, how to win, right, and not the war, okay. So of course he was a military strategist, right, but his ideas can be used in corporate strategies, like you want to competitively win a deal, right, or gain a promotion, right. Promotion does not always mean that you have competition, right. You still need to work for it if you don't have competition to get promotion. The other core aspect of his idea is this philosophy of seeing the bigger picture, right. So whenever you're doing something, right, it's not just war, right, or curing a disease, right, ruling, right. Can you see the bigger picture, right? What are we doing? Why are we doing this? And thinking deeply, analyze how to solve before taking action. So that's an interesting aspect. So you get an idea or a request. You don't just start coding, right? You think, design, analyze it, and then start working on it. And then the next 4 points are also very interesting. That know yourself, right? What is your capability? Do you know that? Know your enemy, right? The other side. Do you really have you learned enough of the other side, right? Your enemy, and do you know what you know, right? So like this related to what you. Okay, there's a lot of knowledge in you means you and your team, right? Sorry, your group. Do you know what you know? And the last is the most challenging, right? Most people can't answer this, right? Know what you don't know, right? Which is like really, really close to impossible for everyone. Okay, so throughout this session, I'll be you'll see my slides with headings with different codes. Okay, and I picked up some of those codes here and just put it in one slide. Okay, not all of them, but this is the key points of this session. Okay, the gems, right? So know the enemy and know yourself, and in 100 battles you will never be in peril, right? That means if you know yourself and the other side, there's a very high chance you will win. And note that he's actually won most of the wars he ever fought, right? So that's a unique achievement. Do not engage an enemy more powerful than you, right? Subdue the enemy without fighting, right? Victories come from finding opportunities in problems. So yeah, so a lot of these things are very contemporaneous, right? These things make a lot of sense in our lives, right? Not just in wars like that, like when Sun Tzu was talking about this, right? Even the finest sword will eventually rust, right? So if some of these points you're not able to map to what work we are doing now or what this session is about, we'll see later, right? And the greatest victory is that which requires no battle, right? That's his key point, right? And of course, if you're impressed by these points and you want to know, there's like some dozen books out in the market about the art of war. I've just shown some screenshots here, and I have the book on the right is what I have with me. Okay, so let's see. Why do we want to avoid war, right? Why is war bad? So the cost is very high, right? Because it's not just the winning side, the losing side, or the losing side. The winning side also loses a lot. Right? So what Sun Tzu says is, victorious warriors win first and then go to war, while the defeated warriors go to war and then seek to win. Right? So without planning, if you're going and thinking of winning, your chance of winning is less. Okay, then why you need to avoid war is, and I've just mentioned here. The last point is the most important, right? So both sides lose a huge amount of losses on both sides, right? But it's the winning side, right? That has more soldiers standing. So this was relevant, maybe 2000 or maybe even 1000 years ago, where the bigger army always wins, right? Most of the time, right? Now it's changed, but this is relevant in the other areas, like the lockdowns and operations. This is very relevant advice. Let's see how it maps. Okay, so of course, coming closer to our time, right? What is the biggest war that we have seen, right? You think, right? We've been fighting a war for 18 months now, right? So the screenshots give you a hint, right? Now, this is kind of a, I mean, it may not be a weapon kind of weapons and boundary kind of war, but it's an interspecies war, right? We are at war with the virus, and this has been one of the biggest enemies of mankind, right? So it's not like one country fighting another. It's very strong. You can't really fight this individually, right? Never. And it has to be a community global effort. That's why we can't, even now, right, after 1.5 years, we can't say we have won the war, right? It's been both sides. So that's another, right? You recognize the stronger enemy. So Sun Tzu says, the greatest victory is that which requires no battle, right? You don't want to fight enemies, and do not engage an enemy more powerful than you, right? The virus is infinitesimally small, but do you want to fight the virus, right? You really can't, because individually there's no way you can win. That's the thing, right? So what do? You avoid, hide, maybe even surrender temporarily. Okay, these are the words Sun Tzu has used, right? Even surrendering temporarily is a tactic that he advises. Okay, so now one of our strategies, right, in winning the war against the virus has been lockdown, right? So social distancing is obviously a technique, right, that we are taking, right? Because there's no way a virus can transport itself far, right? There's a limit to that. So it's like a Trojan horse, right? Virus uses other humans infected as carriers. So you're distancing and avoiding, right? Avoiding the enemy and hiding even, right? So I've shown a tiger here, right? So if you, case you're wondering why this tiger is there in the slide, right? That's because the virus is an intangible enemy. I mean, you can't see it, right? It's not visible, right? You can't see or touch. So unlike a tiger, right? If the virus was a tiger, we would not need lockdowns, because everybody will hide in their own caves, no? Even if they didn't have their houses, they would hide in some caves just to save their lives, because we are used to visible enemies, right? So this virus is not only powerful, it's very highly invisible, right? So if this tiger were the corona, we would not need lockdown, because everybody would hide themselves. Government enforcement is not required. So let's see about operations. Okay, so now how does all this fit into operations, right? So let's look at aspect of operations which is relevant here, right, for monitoring and preventing failures. So operations team does a lot of things I've just defined here. Systems and processes that prevent catastrophic failures, right? That's operations. So failures happen every day because operations team, right, is there. We don't know about it, right? So some of the bigger failures, we come to know. Those are called catastrophic failures. And they support critical infrastructure, right? That means all of us have been able to work from home because of the telecom infrastructure, right? Otherwise, this would not have been possible. Imagine 100 years ago or 500 years ago, when plague or Spanish flu was there, people had to go out, right, to get food, to communicate, transformation information, even of course to work. There was no way most people could nobody could work from home, right? So of course the other aspect of the operations is the cloud, right? How cloud has been leveraged a lot in operations, and the huge growth of cloud, right, in the last 1.5 years is a testimony to that, right? I mean, if you want to have 1,000 virtual desktops by tomorrow, it's impossible to get that without a cloud systems. Okay, so now we come to the next level. Who is the enemy of operations, right? What is the enemy, right? When we say war, there's always two sides. Who is the enemy of operations? It's system failure, right? The catastrophic outage that we rarely see, right? But there's always outages because of the backup and redundancies built in. We don't see it. So of course, I've just shown some screenshots, right? So Facebook went down, Reddit went down because they depended on Amazon, right? So it's like the operations team, and the enemy on the other side is system failure, right? So that's what we are trying to avoid here. Okay, so how do we prevent these failures, right? So the brute force approach, right, like writing a brute force algorithm is, you throw money at the problem, right? Okay, have more people or more even better qualified and capable people. Is that a real thing? I mean, if those have written programs, okay, there is a limit to which you can add hardware resources and solve a problem, right? Okay. And the other thing, right, to win the war, right, we learn from experiences, right? So when we had the virus issue last year, initially, we were on the back foot, right? A lot of people were in hospitals. Just a minute, sorry. Just a minute. Yeah, so I got a telephone call. I need to. All right, let's continue. So how we have now got to the next level? That means at least a semblance of winning, right? So we learned what can be done, right? So we learned, okay, lockdown is really helpful, right? There are some medicines which will alleviate some of the symptoms. There are some of medicines which can actually help people in critical conditions, situations, right? And of course, we have also learned that the number of people who actually need to work from home, right? I mean, work from office is very less, right? Especially in the IT field, even many other fields like banking, even in some cases in government, people can work from home, and the communication, I mean, the transportation needs or the power needs, right, can be greatly reduced. So, are we, willing to learn from that? Many of our doctors, engineers, or decision makers have learned a lot of lessons. That's why we are we're seeing that, okay, we are winning, right, at some point, to some level against the virus. So, okay, let's look at Sun Tzu's advice again, right? Knowledge is key, right? So you know yourself and knowing the enemy, right? That is the key to winning. So this is especially when you look at the operations perspective, you catalog your knowledge. That means, okay, you learn from experience that I said earlier, right? So once a failure happens, a system failure happens at a smaller level or localized failure happens, how can we prevent that, right? So you document, okay, which are your critical business services, and how can those critical business services be made highly available and reliable, right? And but with your load testing or different kinds of tests, identify potential failure points, or maybe documenting the last maybe many months, right? You have seen system downs or individual server going down. Why they're going down, right? Instead of just throwing away that information and starting a new instance, there's a lot of information to be gained by analyzing why a specific VM went down. And of course, identify those in your team, right? Who can actually fix those issues, right? So just knowing that, okay, where it can fail is not enough. No, we need people who actually know who can fix these issues. And of course, map them. And once you have fixed something, then you actually document them so that you are not really dependent on that single individuals or single one or two individuals who can fix that. Others who are available at the time, right? A failure can help. Okay, so these are different ways, right? The DevOps team, right? Actually prevents failures, right? So you don't want a firefight to happen, right? At 2 a.m. you get a call, okay, server's down, you can't sleep, and you got to go to the office and stay, I don't know, the next many hours until the system is back up, right? So that is something that you want to, it's not just your personal issue, right? The millions and millions of dollars lost, credibility lost to the business, many other aspects too, right? Why you would want to prevent failures. So this is like the cost of war, right? You don't want this war to happen at all, right? So by the way, the picture that I've shown here, right, is actually a really thing. There's something called monkey testing as part of chaos testing that we do actually before going to production to see how to break your systems. Okay, so this is a good way to actually see. You release a bunch of smart guys who actually they're called chaos monkeys who can actually break your system in production, right? Okay, or maybe in staging, so that you avoid failures in production. So the greatest victory, right, that Sun Tzu says, right, where you don't have to do a battle, you don't want to do the battle, right, so that everything goes smoothly. Okay, now you've done all this work, right? Life is still hard because failure can still happen, right? So let's see. That's where monitoring comes in, right? So in operations, the monitoring part is where so people actually monitor, and if there is some issues happening, some alerts happen, and maybe the alert could be that okay, something failed or something's about to fail, right? Thresholds that you define in monitoring systems help you. And sometimes or many times you can automate, right? And the thresholds are hit, you can actually, especially the cloud systems, allow you to scale, right? Restart a lot of new and at lower cost, right? And if you're doing this in your data center, scaling and restarting or throwing away and starting a new machine, it will not be that easy and that cheap. And of course, so that's the idea of self-healing systems, right? So system identifies it that okay, something is going wrong, and prevent cascading failures. So the last point is pretty important, right? So you have a series of services, and you don't want failure of first service causing the failure of next service, right? Because so there are many ways, especially in Microsoft architectures and different patterns like circuit breaker, which actually prevent cascading failures. So this is actually a lesson from the virus thing, right? I don't know if you've followed the scientists and doctors, how this cascading failure is one of the reasons for death in the corona, serious case of corona. Your immune system has there are levels of gates in your immune system, and they keep failing one after the other, and this catastrophic failure of many of your cells and your organs and lungs. So you work to prevent that, right? So using steroids and stuff to actually, it's like a temporary surrender to a virus, but it's actually not that. What we are doing, steroids is, that's one example, to actually prevent cascading failures resulting in catastrophes. So there's another idea from how we fought the virus and how we could use in operations. Okay, so let's look at the monitoring systems, right? So monitoring systems, there are two aspects, right? Dashboards and alerts, two key things, right? Monitoring, the dashboards part is you keep viewing, right? Something that you view on screen, and then you decide, okay, what to do next, actions. So that's the advice here is, he who knows when to fight and when not to fight, right? So two aspects to this. when you want to fight, right? When you don't want to fight, you want to look at this your screens continuously, and okay, which server is going down, which is going up. Most of the time, there's no war, right? Everything's going smoothly. So that's the key thing about when you design your monitoring dashboards. You have to decide, okay, how can your operations personnel best use this? So let's look at the next thing. Okay, now if there are too many signals, the people or the team will get overloaded and they will not be able to act correctly. So of course, operations and monitoring has been going for decades, right? So there something called 5 golden signals that is helping you to design your dashboards and define alerts, right? What are the 3 area or 5 areas that you want to design your visualizations around? So if you have, so this is relevant if you are actually done this work, okay? Because when you start designing the dashboard, you have no clue, right? You interview people, everybody says different things, and developers have a view, testing team has a view, staging, the management or the operations team management all have different views, okay? And you would definitely come across, hey, you could not put all these views in 10 screens, right? So you can't have like 50 screens where a team keeps monitoring. That's too much, and too much cost, and mostly it's no signals to monitor. So if you can define your dashboards around these latency, errors, right, saturation. Okay, there's like one more that I put here. If you can define your signals around this golden signals, you can quickly narrow down where your issue is. So that's a key point, right? So somebody looks at the screen, right, and there is some anomaly going on in some of the tile, okay, some of the widgets, and says, how do I find what's going wrong, right? Because the monitoring view is a pretty high level view. So if you define around these golden signals, you can actually identify that, okay, it's related to maybe some this error. Suppose you see it's an error page that you're seeing, and you can actually say, okay, the error count for this service is higher than the threshold, right? So that means, okay, basically you can find the root cause and quickly resolve it. Okay, so when we're talking about monitoring, of course, you need to talk about site reliability engineering, right? So SRE teams, so because you may be confused, right? How does all these things fit together, right? So site reliability engineering is basically, to improve reliability of high scale systems, right? You engineer, right, your systems so that when you scale very high, right, and thousands, millions of users, right, you have your system reliable. They do not go down, right? And a lot of this load goes on the operations team, right, if your system is not engineered well. So there's a lot of work, not just the monitoring part of it, okay, there's like deployment, automation, patching, many of the things have to be done. And the SRE teams are basically a subset in the operations team, and they include a lot of developers and engineers who actually make your system highly reliable, stable, and scalable. And within SRE, there's more terminology, so I'm not going to spend a lot of time on that, like service level indicators, objectives, and agreements, right? So I've given an example here, what the differences, things here. So if you hear SRE, it's not just monitoring, but SRE uses monitoring to achieve certain things, right? So what is achieved is the scalability, reliability, and stability. So then APM is another terminology, right, in the field. So it's been there for some time now. And so APM is a set of tools, right? So basically you monitor things. So this talk itself is about monitoring, right? So application performance monitoring tools help you, capture certain metrics, measure them, and alert on thresholds. So that's what application monitoring, performance monitoring is. Okay, it's APM is kind of a terminology that's been used for many years now. So with this, by capturing this analysis data, right, in the system, in APM tools, not just monitoring and alerting you can You can also analyze the data and adapt the system to prevent future failures. So there's some of these newer APM tools have machine learning and AI built into them to actually help you prevent future failures, or maybe give some hints to decision makers. This could be the possible potential areas to fix or to avoid bottlenecks, and then engineers or architects can make that decision to change that to be more reliable. Okay, so now DevOps, right? So I just give a quick view of what DevOps is, right? So like I showed in the beginning, so DevOps are encompassing process and culture, right? So before DevOps, you have development team and operations team. With DevOps, the developers are also the operations team, right? So now, since the developers need to do the production support, it's not just the reliability and scalability part they look at, like in the SRE, the complete operations, right? The deployment, starting from deployment to monitoring, all, right? So then you get better insights from production support, and you incorporate that into your development cycle, and your insights from development cycle also go into the operations. So it's like a win-win. Of course, it's much more difficult because operations is 24/7 job. So maintaining such a team and increasing the size of the team in the DevOps mode is challenging, right? Okay. So let's look at maintenance, right? Another aspect of operations maintenance. So here Sun Tzu says even the finest food will eventually rust, right? So this is pretty obvious, right? So in operations, you need to maintain your systems. You keep maintaining, right? If you maintained an iron sword well, it will last 1,000 years. If you don't, think about the other aspect. If you don't, it will rust in a month, right? So I'm not spending a lot of time on that aspect. I think the Sun Tzu's word is actually directly mapping to maintenance, right? Okay, now we'll go a little more detail into monitoring, right? So the art of monitoring, the technology. So now most of our slides are going to be about technology. Okay, so we have seen enough of philosophy, right? So if monitoring can be split into 3 areas, right? It's capturing metrics, capturing logs and traces, and doing some actions on that. Okay, so let's see what these metrics are, right? So metrics are these numerical numbers, right? So what you see on your dashboards mostly are the metrics, but some of these are not captured only from metrics. So you derive metrics from different places, but metrics are this quantitative numbers. Okay, so the CPU detail is like a quantitative thing, right? Disk IO used, IO rate, network bandwidth, right? Response time for a service. These are numbers. Okay, so concurrent request count, right? Number of requests that came at this time, right, for the service. So these are the metrics that you capture, and normally these metrics are stored in kind of a time series database. Nowadays we have lots of NoSQL databases. Time series databases are best suited to store metrics. Okay, so they are captured in one way and also handled differently. And because it's metrics, the amount of data that you generate per day, it will be in millions, right? Tens of millions. Even for a cluster of small size, like even a cluster less than 10 nodes, you can easily generate 10 million records per day. So logs are the next thing, right? Is used in monitoring. Is basically files generated by applications. So this is what all of us have seen, right? All of us know about logs. So applications generate, and of course operating systems, any other servers, right? Database servers generate logs. And so the key point here is that if something happens, the log is written, right? So some developer has to write, okay, log.info or log.debug or something, log.critical in your based on your logging library, and that it'll be a free text. Of course, it may be indexed by time or something like that, but it'll be a free text that gets, and then of course that file has to be transferred to a monitoring system, because you just put it on a disk. It's not really useful for monitoring. So let's look at the next one, is traces. Okay, so traces is like, okay, it's like logs conceptually, but it's not, you don't need to generate files from that. And it's not that developer writes every trace entry, right? Because it's impossible to generate traces for a developer. So traces tell you like, okay, what function got, okay, where somebody called a service, like for example, you see what happened to user 10's request as it traverse various services and layers in the system, right? So it's pretty fine grained and noisy. So, and then HTTP request hit that Apache server, and then it went to the web server, right? So it called some get or post or any of those verbs. Then what are the parameters passed in? So a trace will have that level of information, and then to get the data from the database, which function was called and what are the parameters. And traces also overlaps with some profiling, because in a profiling system you actually capture, okay, this function was called with these parameters and how much memory it used, right? How much objects is created, right? So traces, it just says, okay, these are the functions called, and it's like a called hierarchy is generated and what are the parameters used. So it's very useful for debugging and analyzing. Very fine-grained information is generated. So this generates even more data, right? Very fine-grained data. And of course, you normally cannot do tracing in production. So it has to be, and even if you do tracing, it has to be a few minutes and you have to switch it off, because no production system can easily handle tracing. So there are like non-invasive tracing methods which are supported by many libraries. Okay, so that's when you use that kind of tracing, you can switch on tracing. But even then, you would not want to do that, because even if your normal data pipeline is not impacted in speed, the generated data is very huge. So you would normally switch it on, like when you want it, and switch off, because you can't handle the high level of how high amount of data generated by tracing, right? So by the way, so this logging tracing features are available in many of the monitoring tools. So normally you don't build it into your system, you just use some library or use some framework. So okay, so now next part is now in Azure Conference, right? So I'm just showing Azure Monitor as an example, okay, how this is done. So this is just architecture of the Azure Monitor features, a high-level view from the Azure website. So basically, Azure Monitor is a very comprehensive system. Okay, it has basically you can monitor all the Azure resources, and like I said, you can there are agents that capture data, store into metrics and logs databases, and a lot of services provided to do some actions on the data, right? You can actually visualize the data, right? Then, or you can just do a kind of a machine learning based analysis on the data, right? Then of course you can do responding, right? So something happened, right? The threshold is breached. You want to send an email, the default expected things. Of course, you can also enable auto scaling, right? Based on some alert being hit. And of course, there's a lot of integration features, right? So the native dashboards, and if it's not good enough, you can integrate with other systems or call other applications with Azure Monitor. Okay, so pretty comprehensive, right? If you want to provide logging and monitoring for the application. So the first part of it, right, the insights is what I said. It supports tracing, right? So if you want to trace how your Azure function performed or some logic app performed, you can enable insights on your function app or logic apps, and actually it will generate a lot of detailed trace level data, and it will also, especially in the microservice architecture, or even if your it doesn't have the function app, okay, your app is actually running on a VM, you can still enable application insights, and it will find out, okay, which application is communicating to which other application or sockets, and give you a visual map of what's being generated. And because it's Azure Monitor, it supports all the Azure services like container services, VM, SQL. So if you have a database, you can actually get insights about SQL using SQL insights. So for all this, right, it also uses the the concept of R, interestingly, because how it works is actually the Azure Monitor. The key power is, right, there are a lot of agents here. Okay, maybe I'll just go to the next slide and show. Okay, this is like a simpler view of the Azure Monitor architecture. So Azure Monitor supports a lot of agents for individual Azure resources like Azure VM, Data Factory, Postgres, SQL Server. Even lots of resources are there. There is a separate agent, okay, and for different kinds of activity on the same resource. Like for example, if I take the VM as an Azure resource, you can actually do diagnostic agent, then activity agent, then of course application insights agent. So same single resource has many agents that you can switch on and switch off, right? Some of these agents are already built in. You just have to use the data. Other agents have to be installed, right? So some of this, so it's like Azure Databricks, we have to manually install the agents with scripts and all. So the agent part, right, is a very powerful part of the Azure Monitor, right? Because you want the agent to sit right on the other side, capture the data and send. It's like spying, right? So Sun Tzu has stressed on the value of spies in war, right? You want to have spies because that's how you'll know your enemy, right? And they are very important to actually know your enemy so that you are prepared, right? Because his fighting styles, his weapons, all those. So like that, Azure agents are pretty useful because they do the core work of capturing the critical data, right? And your development team and to some extent the operations team also needs to know how to configure them, right? Configuring these agents is very complex because knowing the right way to do it, okay, not just installing it and capturing the right metrics, okay? Because some of these resources give you, hundreds of metrics. Now, out of this, you want to capture maybe 5 to 10 or 20 metrics. So deciding which one is the right one, right? I pointed out the golden signals, right? The right metrics for you is very important, and a lot of in-depth knowledge of the resource and your application may be needed to decide. Okay, there's a lot of design effort that goes into using this. So these tools are readily available, but design effort is high to actually do it the right way. And of course, so now you the agents capture the data and it's stored into metrics and logs, right? There are two databases that I've shown here because metrics is a time series database. Logs is kind of a relational database, right? So normally the metrics data will be very huge, of course, and storage and indexing is provided here. Okay, so Azure Monitor supports terabytes of data, right? Then the next part is the data analysis, right? So you have this data captured in your system. Then you need to query them, right? So that's the query engine provides that. It's a language called Kusto query language. It's like a SQL, but it's much more powerful than normal SQL because it provides much more aggregation analysis functions. And of course, there's a very powerful configuration engine. Okay. So this configuration engine is relevant across. Okay, so I've shown it here only, but this configuration engine can configure your agents, right? So Azure agents especially. Okay, so if you use Azure Monitor, you can install many other agents, but only Azure agents can be configured with this. Then you can configure your metrics and log how much data you want to capture, right? The access control, any other thing can be configured. Then of course, configuration engine also does configuring of, okay, when you want to alert, right? What is the condition under which this query results should generate an alert, right? So the alert engine on the data visualization part depends heavily on the configuration engine. And of course, it provides built-in features, right, for dashboards and workbooks. So dashboards are basically a view-only thing, right? You normally view things, and workbooks are also kind of theoretically dashboard except that it's a little more interactive, right? You can drill down deeper, on the screen itself, right? You can see more and more data. Some of the graphical elements provided in workbooks give you capability to drill down deeper into issues. So it's pretty useful, especially for providing L2 and L3 support. And of course, alerts, right? That's default thing. And you can have many kinds of alerts, right? SMS, email, calls. Even it can create automated tickets to other ticket generation systems. So it can call some app, or like I said, like I showed earlier here, right? You can actually do auto scaling, right? Using the results of queries, right? So these queries, now you can time them automatically, right? Every few minutes it will run and then generate the output and show in dashboards. Or maybe some of the queries will be used to decide, okay, whether we should generate an alert, right? So that's the part of what Azure Monitor. Okay, so let's look at some other interesting areas, right, which has been helping win the fight against system failures, right? Like I said, right, preventing system failure is the key thing, right, in operations and monitoring. So software defined everything, right? So at a high level, right, so I'll not go into detail. High level, software defined everything is basically many ways of doing it, right? Networking, software defined storage. So it's not that you replace the entire thing, okay? You just replace the control element part of it to a higher level, and the hardware is just a doer, right? The action commands are sent to the hardware, or for example, for networking, you say, okay, forwarding commands are sent, and for networking routers, just forward it. The control commands, right, algorithms that decide how to route it, complete thing, is elevated to a software level. So similar thing in software-defined storage or software-defined data center. This actually helps reducing the requirement, right, capacity requirement of the hardware, right? So the software, right, is much cheaper and much more available, right, or provisionable compared to hardware, right? You can't just get your hardware provisioned in a minute or a few seconds, right? So software can be. So the software-defined everything movement is actually helping improve the move towards cloud and automation, right? And the last point, I've actually expanded it. It may not be so familiar. So this is actually some work that I've done in my earlier research projects. So even in manufacturing, the same thing is happening. Okay, so earlier robots that did it, right, in manufacturing plants or where they make cars or any kind of hardware, or even packaging, right, retail packaging. The robots, you'd be given a command, they would have their own intelligence. So now in software-driven assembly, right, assembly lines or machines or robots are controlled by software. Okay, so that is coming. It's a nascent moment. So earlier it used to be some programmable logic controller, or basically embedded systems, which are kind of rugged PCs, which used to do that, but they were limited in their capabilities and integration functions. Now software-driven assembly systems, where software orchestrates the entire thing, is coming up, and it's being deployed at lower scale, but it's kind of a nascent stage. But that will also happen. Okay, we can see that in the future. Of course, next part that I want to talk about is the cloud, right? So the value of cloud is really, you can really understand. Imagine there was no cloud services, right? This complete lockdown solution way of winning the war would be impossible. And that's what my thinking is. I mean, imagine the Spanish flu of 1918, right? It's like 100 years ago, right? People had to go to offices, right? Go to buy groceries. You can't order food online and have it delivered, right? So the complete ecosystem has been enabled by the cloud, right? So the huge growth that cloud has seen, right, it will go even more. That's what I'm feeling. So the infra on demand that we have seen, right, and virtual desktops, the demand for that has skyrocketed after since the beginning of 2020, right? The other thing, of course, that if you all of us are working on Azure, right, or any other cloud, you would know the fine-grained level access control and permissions that cloud provides, it is very difficult for most of the organizations, in the world to implement by themselves, right? With the cost that is you have to pay for cloud, right? And security incident event management, that is also provided as a service now on most clouds, right? So that those kind of services were not available for most small enterprises, right? Because the cost involved and the skills required is too high, beyond the reach of most SMEs, So cloud has made that possible, and in my view, right? So one of the key, weapons that we have, right, in winning this war against failures and against lockdowns, right? The need for lockdowns against virus has been cloud. So that's my thing. So I have some references at the end. I've mostly finished my references here. If you're more interested, you can look at this. I think this presentations are going to be there online. So yeah, that's it from my side. Thanks.
Hello, Prachot. Yeah, that was an amazing session. We have got to know about monitoring things.
Yeah, thanks. Yeah, if anybody has questions, yeah, you can ask.
No, for now there is no questions.
Okay.
Shall we wait for one more minute, or we'll wind up this?
Yeah, we can wait. So
yeah,
okay.
Hello, Prajot.
Hello.
There is no questions so far. So
okay. So yeah, then we can. Shall I stop sharing?
Yeah, sure.
Thanks.
Thanks for joining us and sparing your time with us, Prajot. Thank you.
Yeah, thank you. Thanks for your support.
Yeah.
Bye.
Hello.
Hello, good afternoon it is, right?
Yeah, good afternoon, Glenn. So I would like to invite you, and it is very much glad for us to have you here. So, so here we have Glenn will be talking us on place your bets all in Azure IoT. Is that right? The topic is so interesting, Glenn. The stage is yours.
Thank you for the introduction.
Yeah, thank you.
All right, let's see if those slides come up. All right, great. So again, good afternoon or good morning or good anytime. I think people from all over the world are joining this great conference. I think it's my second year I've been here, so it's always nice to speak here. So today we're going to talk about what I will do is I will give you a guided tour on anything related to Azure and Azure IoT. So if you have any questions during the sessions, just drop them into the chat. I will keep an eye on them on my second monitor. So if at any time you have questions, I will try to pick up on those and get them answered while we go along. At the end, I will also leave some room for you to ask questions if you have any of them. So let's start with a small introduction. So my name is Glenn. I'm a Microsoft Azure MVP. I work at a company called Azure. You can reach me on Twitter or on my email address if you might have questions afterwards or if you want to reach out. So Azure is focusing on Azure Platform as a Service specifically. And we have been focusing on that since our foundation in 2011. We have 75 employees. We have 4 MVPs in our community, and we have offices in Helsinki and in Ghent, Belgium, where I'm based. We also have a lot of cool logos from Microsoft, which is very valuable for us as a Microsoft partner. So, but that's not what we're here for today. So today we're going to talk about IoT. And you've probably heard this already a couple of times during IoT talks or sessions about IoT. IoT is all about things, getting those things connected and creating insights and actions on top of that. But before you start a IoT project, there's a couple of important questions you have to ask yourself. First of all, the biggest question you as a consumer or a creator or a company that is starting with Azure IoT is the question, do I go for a platform as a service implementation, or do I choose a software as a service implementation? There's some pros and cons for both of them, and we're going to talk about those during the session today. But remember, the biggest advantage when it comes to doing it platform as a service, so building it yourself, besides the fact that you are indeed in full control of those things, it also comes with the biggest challenge, meaning you are responsible for the feature set, scalability, and so on. Next to that, beside the whole platform as a service, software as a service choice, it's important that IoT is not treated as a simple proof of concept or a simple project that is being done at the site. I've been involved in some of IoT projects where IoT is not implemented strategically or considered strategically within the company. And then you see that you do a couple of proof of concepts, you set up a baseline for their IoT architecture. And then basically because it's not integrated strategically, you see that the project after a while starts fading or is not used that often anymore. So next to the platform as a service, software as a service decisions, it's important to implement IoT strategically and make sure that your company or your customer is mature enough or is considering IoT as a mature product and want to implement it mature in their solutions. So before we dive into details, let's take a look at the IoT product portfolio of Microsoft. So Microsoft has some offerings regarding IoT that are more in the software as a service area. There's of course IoT Central, which is the software as a service platform for IoT from Microsoft, and it allows you to get started in a couple of minutes, connect your devices, and basically create a simple dashboards. Then there's the IoT accelerators, and that's a bit a special one. Those IoT accelerators have been discontinued by Microsoft. So they used to be an open source getting started reference architecture implementation of Microsoft, but they decided to discontinue that and implement it fully within IoT Central. But I'm coming back to the IoT accelerators anyway during this talk, because I do believe they still bring some additional value for you as an IoT developer or a customer that is considering IoT. And then there's the connected field service. That is more like Dynamics implementation of IoT. Then there's the whole Azure IoT services. Those are known as your Azure services. So your platform as a service components, where we have IoT Hub as a centerpiece. We have streaming analytics that usually comes into play within IoT solutions. And then there's time series insights, device provisioning service, and the new service, which is a pretty cool service, is Azure Digital Twins. I will come back to most of them during this conversation. So definitely hold on for more details on those. And then there's the Edge support. There's Azure IoT Edge, Databox Edge, IoT Device SDK, and Azure Services on the Edge. So it's bringing those cloud IoT capabilities from the cloud closer to your devices and bringing them onto the Edge. So, and then there's a whole offering regarding more devices or device-oriented, but I'm not going to in details on those during this conversation. But be aware, there are solutions out there that allow you to have microcontrollers or build solutions on top of devices with Microsoft products. So let's take a closer look at the Azure IoT solution. So as mentioned before, the Azure IoT solutions are more what you could say as the software as a service solutions. So getting started quickly and so on. So a couple of things before you start implementing a software as a service solution. So before you start creating your business on top of those solutions. First of all, there is extensibility. So important fact is that if you start using a software as a service offering, you have to make sure, or you have to challenge them on extensibility. For example, can you hook in your own business processes? Can you do additional things with it? Is there an API to call to do some customizations and so on? The next part is the offering. So think about how much of the offering that is inside the software as a solution package, how much of that offering is covering your use case or is covering your business requirements. If you are around 40 or 50% of coverage, then yeah, you might want to consider building your own solution. If of course you have like an 80 to 90% coverage of your business case, then probably that software as a service is a great match, especially in combination with the extensibility that you're having. And of course, the roadmap, the road ahead. How much can you as a user or as a developer on that platform, how much can you influence the roadmap? Or is the roadmap aligned with the roadmap you have set forward for your product? So those are those little things to take into considerations when you talk about these, when you think about implementing a software as a solution for your IoT solutions. So despite the fact that the IoT solutions have been discontinued and have migrated fully into the Azure IoT Central, I do want to take some time to briefly talk about them because they do bring some value that is still valuable for people that are building IoT solutions today. So to give a summary, IoT solution accelerators were open source, they were customizable, they were sort of a reference implementation for IoT solutions. And one of those was the remote monitoring. Remote monitoring had a whole microservices setup. They had device connectivity, data processing, data analytics, and a whole presentation layer. So what was interesting in the remote monitoring solution is that the existence of a rule engine. And I have been involved in quite some IoT project where there's usually always a requirement for some kind of rule engine. And it's great that you don't have to build those things from scratch. And this is where the open sourceness of those projects comes, of those IoT accelerators come into play. So despite the fact they have been discontinued, they are still available on GitHub. So you can go in on GitHub, grab some of the things you need, deploy them to your own Azure subscription, and start playing around with them. So what I did as an example, as a first demo, is take that rule engine, basically strip out the rest of the solution, just take out that rule engine, and run that rule engine on my Azure subscription. So basically, that would mean I'm having a rule engine for an IoT solution where I just took the code from GitHub and deployed it to my solution. So let's take a look on how that actually is working. So let's open the Azure portal. So what I did was I took the streaming analytics job available, and what I did is I just took the query that was available and pasted it into streaming analytics. You see that I've connected my own inputs, my rules from my database, and the alerts that are going out as just an example demo. So it's important to mention that this query is just available on that remote monitoring solution, and you can basically just deploy that to your own solution so you have a working rule engine. So the question is, okay, how do I define rules here? So the rules are defined, again, I took one-on-one the solution that was available on GitHub and started modifying the rules. So the rules here are quite simple, or are pretty easy to start defining. Let me zoom in a bit. So what you do is you give it an ID, just a name, description, and then you have to say, you have to give it an aggregation window. So that could be instant, or that can be like a sliding window of 5 minutes, of 30 minutes, and so on. And the most important things is, okay, what will he check? So he will check temperature. That is just a field within my JSON. And what it will do, this is the syntax that needs to be used for your rule to be enabled. So again, here, what I did, I took this set of rules that were available, took the same syntax, added some of my own rules, deployed that rules within my streaming analytics, and that was basically it. What I then needed to do is, excuse me, hook up my ingestion endpoint, and this is IoT Hub. And what I will do is I will just send alerts if a rule is triggered to a queue, and how that queue is pretty simple. What it will do is create a logic app. It will take the message from the queue, parse the JSON, and just post a message on Slack, just as a matter of an example. Imagine that you're running this in a real-life scenario. I can imagine if you are having a temperature too high rule, you would trigger some kind of business event or raise a ticket within some kind of support system or an alert to just warn about the high temperature. So let me start up my message simulator. So this simulator will just start throwing messages towards IoT Hub, if all goes well, of course. It's heating up, okay. So, and as you can see, immediately that alert is being triggered in Slack. So the temperature is over 20. If you would look here, where's the temperature? So it's 26 here, 28. As you can see, all these alerts will start popping in. So, and with a minimal effort, by just taking the streaming analytics jobs from the open source, it will, I was able to set up this alert within a matter of a couple of hours to just make the entire end-to-end flow. And as you can see, this this is still a valuable asset for creating IoT solutions, despite the fact that it's discontinued by Microsoft. So you just take it up and bring it there. So let's go back to the slide deck. So let me just quit Slack here. Otherwise, these things will keep on popping up as we speak. So they still are. So let me just ignore that for a second. So let's go back to the slide deck. So yeah, so this is just for your reference. Afterwards, the slides will be available. This is just how the demo setup is being used. What I did, I created in an IoT Hub. The streaming analytics is reading from the rules and is putting the output in a queue where I have a logic app posting to Slack. So, and this centerpiece where the rules are being created, monitored, analyzed at real time has been taken from the open source solution available on GitHub. So next to the open sourceness of those things, the flagship of Microsoft to do software as a service is IoT Central. And as I already mentioned, it's pretty easy to get started. You can connect devices. There's edge support available. There's basically everything you need when you start an IoT project. So there's ingestion, there's visualization, there's rules in action, there's rule-based access control, and so on. There's a couple of templates available, and this is where the IT solution accelerators have been moved into. So they basically transformed these accelerators into templates that were available. And then there's a possibility to have white labeling, multi-tenancy, and so on. So let's, now that we've talked a bit on the SaaS offerings of Microsoft, let's take a further look or dive into details on the platform as a service solutions. So again, some things that are important to think about before you start implementing your platform as a service IoT platform. First of all, there's your connectivity and device management. Your solution needs to be able to connect and manage devices. There's flexible and multi-tenant logic needs to be in place. So the code that you're deploying, your business logic needs to be able to be flexible, deployable, because we noticed that within IoT solutions, you need that flexibility as you go along. Cross-tenant insights usually are important. So creating those insights even are across tenants. So having insights on your IoT solution, or actually know what's going on within the entire environment, that's super important. And of course, you need your integration and flexibility. Once you have those insights from your IoT solution, you need to start integrating that within your business processes across your company or across your project. So imagine if you have like a sensor monitoring your factory, and you need a spare part to be replaced, that can trigger a workflow within your warehouse management system, and so on. For each of those requirements, there's a couple of services available within Azure, and I've listed a couple of them here. What we will do is we will go deeper into some of them during this talk. So first of all, the core, the centerpiece of any IoT solution is IoT Hub. IoT Hub has message processing, it has message routing, device management, jobs and queries, and message enrichment. So it's really, it has support for millions of messages and devices. It has device management, which allows you to manage your device twin. It has a global scale. It allows you to route messages to different endpoints or do some enrichments on top of them. And of course, some topic that wasn't mentioned here is the entire security that is super important within the whole IoT set. So remember, there's per device certificates, there's TLS support, IP whitelisting, and so on. So let's take a look at a couple of scenarios where IoT Hub really brings in the additional value, or IoT Hub enables a whole system to connect to the cloud. So first of all, there's the straightforward implementation, the greenfield, the modern devices, where you have a device that is able to talk one of the supported protocols on an IoT Hub. So AMQP, MQTT, or HTTPS. IoT Hub, excuse me. IoT Hub is able to talk one of those protocols, and will just connect directly to IoT Hub and start transmitting those messages. The next thing is the introduction of a field gateway. And a field gateway is a device or a computer that is deployed close to the devices and acts as a protocol translation between your devices and the cloud. For example, if you have a device that is unable to talk one of the supported protocols, for example, Bluetooth or anything else, you need a field gateway. So your field gateway will connect to the device, take in all the data on the messages, and start forwarding them to IoT Hub. The key of that field gateway is actually that the gateway is deployed close to the device outside of your cloud environment. The other way around, or the counterpart of that, is that you have a cloud gateway that is connecting to IoT Hub. Your cloud gateway is deployed within Azure, and your devices directly connect to your devices on that. So think, there's some protocols out there that allow you to do like TCP connections, but are unable to connect to IoT Hub, and then you need that intermediate step. Of course, there's also a combination of both possible, where you have your field gateway connected to your devices, and then you have a custom cloud gateway that is over VPN or over ExpressRoute, that is talking OPC or CoAP to your cloud gateway, and then is connecting to IoT Hub. The bottom of this drawing is usually seen in telco solutions, where you have that field gateway where your devices are connected, and then you have a batch or a big system within the cloud that is taking in those messages and forwards them to your cloud environment. Once you have that going, once you have that data flowing within your IoT Hub, you can start thinking about management apps. Those can be both within Azure or outside Azure. So think about your device registry, your monitoring, sending commands, and so on. And then once you have that data flowing, once you can manage your devices, you can start building applications or start processing that data within the cloud. So this is really the core of your system. So IoT Hub really brings those capabilities within Azure. So another service that is important or is a lot of used within IoT solution is the device provisioning service. Device provisioning service is a service that allows you to have automatically a provisioning of devices. So for example, what you can do is you can provision a device provisioning service that has a fixed URL and a certain set of keys, and you can bake that URL within your devices. So once a device comes online, it will go to the DPS service, so the device provisioning service, and asks, okay, dear device provisioning service, where do I need to connect to? Or what IoT Hub do I need to connect to? And basically the device provisioning service will be responsible for saying to that device, hey, device number 3, please go and connect to the IoT Hub of India. So, and once that connection has been made of device 3, it will always then from then on directly connect to the IoT hub because the device knows where to connect to. So, and the device provisioning service is really a powerful service to have that automatic rollout of millions of devices across the globe, allowing you to have multiple IoT hub, have some rules and logic on where devices to have to connect to. So it's really a powerful service that has its place within most of IoT solutions if you have that automatic provisioning needs. Then there's time series insights. Time series insights is a serverless service that allows you to automatically ingest, process, store, and query data in real time. It has a UI for queries and exploration, and where you can do some modeling and structuring of your data. There's two types of storage within time series insight, and that's a pretty interesting one. So first of all, there's the warm storage that's baked in within the service, allowing you to run queries on top of data and get that sub-second feedback within your data. Next to that, there's the cold storage, where you can basically start querying historical data that has been ingested within time series insight. Be aware, if you run like big queries, big historical queries, those queries can take a couple of seconds, but in my feeling, those queries have never been extremely long. So it's quite interesting or quite powerful to see how good these queries are done on top of the data. Also important is you can bring your own data, you can hook up your own cold storage into that, of course, if it's in a specific format. Again, here, there's a part of extensibility that's quite important. So it's an open and interoperable through Parquet files. So time series insight stores your files in Parquet, which allows you to have like machine learning on top of that to do some additional things on that. What you also could do is take those diagrams or those dashboard that are being created within time series insights and bring them to your own API. So let's take it back to the Azure portal to have some demo here. So what I have is let me zoom in a bit because I noticed that it's not that readable, so that it's better. So what I have is, just for the sake of a demo, I have a logic app created that is being run every 5 minutes. It's doing an HTTP call to the Dark Sky API. That's just a weather API. And what I'm doing there is I will get the weather data. I think I have Brussels and Helsinki here, which I'm just taking in every 5 minutes, and I'm ingesting that data within time series insights. So if we would go and look in time series insights, you see here that based on the hierarchy I defined. So I have a hierarchy defined. Let me zoom in a bit. I have a hierarchy defined called cities. Time series automatically recognizes that there's two instances of data being pushed in within time series insights, and then it allows you to query. So if we would go here, we would see two locations. So Brussels and Helsinki, which are by accident the two locations of the Azure office which is always nice to have a demo on that. So if we click here, you can see here that I have the possibility to add values that are available within the data. Those data are just data that has been extracted from the message. So let me just add maybe, let's add temperature for Brussels and add temperature for Helsinki. So in here you have a couple of options to start modifying that diagram. Let me just zoom in a bit more. Yeah. So what I usually do is, because we're talking about the same data, we can bring those data together and share them within the same graph. Here you see that that yesterday I can put like a marker here just to have some data. So you can see here yesterday at 3 o'clock in the afternoon, it was 9 degrees in Helsinki and 15 in Brussels. When I look outside my window, it's indeed good weather for the time of the year. So I'm pretty happy about that. But you can see here that you can start comparing those things. In the top, you see that I'm taking data from 1 year. If from 1 day, if I would open up that slide, you can see here that I'm now querying data from 3 days, and you can see here that again you can start doing what you want. What you can also do is select a certain area. You can zoom in. See what happened over there, select a certain time frame, and even explore the events, and then you will even get the raw events that have been ingested within time series inside. So you can basically do anything you want. So what I wanted to show here is that you see that this query that I'm running on hot storage is pretty fast. So I'm running queries of 2 days, of a window of 2 days. You see that those goes pretty fast. If I would open up that time frame to have like 30 days, you can see here that it's still pretty fast. Again, if I would say let's go for the last 90 days, you can see that it already took a couple of more time because he needs to grab in that historical data. And you see that a query took a bit longer. It didn't take like whole minutes, but just was a couple of seconds. You feel that it was a bit slower than the other one. So Time Series Insight, it's a really awesome service if you need that real life data on top of that. So there's also like a heat map possibility, and that one is really useful when you have a lot of devices. You can really spot heat maps of things that can go, or things that can go wrong, and you can immediately start seeing those visually. So let's jump back to the slides because we still have a lot of ground to cover. So, and what I want to mention here is if you start hooking up all those different services, one important thing that I would definitely recommend you to check out is the Azure IoT reference architecture. It's a reference architecture that allows you or brings in patterns and practices from partners, from Microsoft partners, and really bringing those best practices, those lessons learned for you within that IoT reference architecture. It's open source, it's from Microsoft, so I would say go and grab a copy, and you can read that during the weekend, maybe. So the next part I want to talk about is IoT Edge. So if you're having an IoT project in a remote location, in a remote mining, or you have a vessel where internet connectivity is super bad or super expensive, it's important to have that cloud capabilities on the edge. So having cloud capabilities on your edge is really key in IoT solutions. I haven't seen a lot of IoT solution that didn't have any sort of requirements of having something on the edge or something closer to the device. I always give that an example of an edge thing. So imagine you have a self-driving car. So your car is driving and someone jumps in front of the car, and your sensors in that car recognizes that there's a person within that car. So what you definitely don't want that those sensors need to transmit that data to the cloud, do some analytics in the cloud. That analytics would say, okay, there's someone in front of the car, send a response back, and then instruct the car to stop. No, that couple of milliseconds of latency is a difference between you as a car driver hitting that person or you as a car driver being able to stop on time. No, you want that analytics or that thinking of your sensors, those analytics, you want them on your device, so on your car. So if someone jumps in front, you want that immediate feedback, that immediate stoppage of your car. So that's the importance of the edge capabilities. So we all know what an IoT pattern is. So we have our things, those are connected to the cloud. We do insights and actions on them. But what is edge? So edge brings those insights and actions onto your device and have that closed feedback loop over there. So a couple of key components within Azure IoT Edge. So first of all, there's the Azure IoT Edge runtime. It has your fundamental services, it has your security, and your module management. So modules are just capabilities that are being added to the runtime, and you can see them, or they are simply just Docker containers. With those different Docker containers, what you can do is create a sort of processing pipeline. So for example, here in this example, you see that we have a protocol ingestion, we have data formatting, and then that telemetry is sent to IoT Hub. And of course, there's configuration and monitoring available. And that configuration and monitoring is fully done through IoT Hub. Also, deployment monitoring and other workflow are configured through that. So let's talk a bit on the road ahead. So the next, what we see is when we start building IoT solution is that a new trend is emerging within IoT solutions. So customers want to model their environment first and keep that physical model up to date with IoT data. So it's a more natural approach to having an IoT solution. So we're moving from connected assets, it used to be super important to just get those devices connected and get that data into cloud. But customers want to more and more have environments being connected. They want to model relationships between people, places, devices. So you can really create those connected environments. And once we're in that stage, you can imagine that we will start evolving to have like interconnected environments where we have and really start building those connected ecosystems, or really have a whole city being connected towards the cloud, or towards IoT solutions. So it's all about virtually representing the physical world with a digital twin that just models the relationship between people, places, and devices. So it's really having those context-aware IoT solutions. And I already gave it away. This is where the new service, Azure Digital Twins, comes into play. And it really allows you to create those next generations of IoT solutions that model the real world through an open modeling language, have a live execution environment, and have inputs from IoT and business systems. Again, what you can do is you can also have some outputs to time series insights, and you can run storage or analytics on top of that. So let's let's jump to a demo. On top of that, I have to switch my tenant here. So, and this is what digital twins looks like in the Azure portal. So digital twin is just a set of APIs that you can use, and you can start doing work with it. There's endpoints you can connect, and those endpoints are just it allows you to send data to other resources. So think about sending it to Event Grid or Event Hub and so on. So those are a bit similar if you're working with IoT Hub with your routes within IoT Hub. So it's a set of API that you can communicate with and module your digital your physical world. So if we open the Digital Twin Explorer, if all goes well, this should work. If I run query. So this is a, I can zoom or I can't. No, I can't zoom, unfortunately. So what it's, I do, oh, yes. This is, yes. So what I have here is inside Digital Twin, I've modeled out my, I've modeled out a house. So a house has a top property. It has a construction year. It has me as the owner, and it has 3 different floors. And if we take a look at that, those are just some ID that is available. And then there's some rooms available within that. And as you can see here, I see that the humidity and temperature is not being set here, but you can see here that I want to know what is the humidity and temperature of my bathroom. And this is done by a sensor that is being deployed within that bathroom. And you can see here that there is some humidity and temperature being available here. So that just has to flow through. But this is just a brief demonstration on how powerful this new service is. So you can really start modeling out your environment. So imagine you have a factory floor that you want to run tests against with, or simulations against with. This is where digital twins comes into play and really brings that additional value. So this just as a brief demonstration. So before we jump to open Q&A, I just want to do a small recap. So when you start building IoT solution, one of the biggest important decisions you have to make is if you want to go platform as a service or software as a service. Remember that the biggest advantage of platform as a service comes also with that responsibility that you are in fact of control of the feature set and implementation. With SaaS, you give away that control. You give away that control, but it allows you to get started more quickly. For customers that need that full control, and those feature set are crucial for their business. Usually, PaaS is the biggest value or is the best choice. So and that's more like a general thing, is especially with IoT, it's important to learn from your mistake and improve your platform continuously. So, and as mentioned in the start, do not try to start IoT with in mind, yeah, it's just a side project. No, really start integrating IoT strategically within your customers and your projects. So that's it for me. So before we jump to Q&A, I really want to thank the sponsors, the community partners, the learning partners, and all the communities involved within this great conference. If you want to reach out, I'm available on Twitter, or you can drop me an email and I will be happy to help you out. I didn't see any questions during the session, so if people have questions right now, do not hesitate to drop them into the chat, and I will be happy to try to answer them where possible. Thanks for attending.
Hello, Glenn. Thanks for joining us, Glenn. That was a great pleasure having you here. Thank you.
It was my pleasure. Always great to do these types of things. So I hope the rest of the conference goes super smoothly for everyone. So, and I hope there's some great. I saw in the program that there's some great sessions coming up on serverless and stuff like that. So pretty excited to stay tuned and to watch some of the other speakers giving their sessions.
Thank you, Glenn. That's a pleasure. Oh, sorry, I was unmuted. Okay, the next session is going to be taken by Adarsh Sean from infrastructure as code to environment as code. The stage is yours. Can you please share your screen?
Absolutely.
Yeah.
Okay. Can you see my empty desktop, I guess?
Yeah.
All right. Can you see the main slide?
Yeah.
Awesome.
Good to go.
All right. Thank you. Yeah. Thank you. Hello, everyone. Thanks for joining my talk. So my talk today is from infrastructure as code to environment as code. Challenges scaling ISC and how to resolve them. This talk is based on my and my team's experience working with and helping various companies adopt infrastructure as code and the challenges we have seen scaling infrastructure as code over the years. I will also introduce environment as code, which has helped us resolve those challenges. Some of what you will hear today around environment as code is new. So I would love to get your feedback, answer any questions, and discuss further. But let me introduce myself first. So my name is Adarsh Shah. I'm founder and CEO at CompuZest. We do DevOps and cloud consulting, and we have a product that helps you manage environments better in any cloud provider. So we all know what infrastructure as code is. It helps us automate provisioning of infrastructure resources. It is one of the key DevOps practices that enables teams to deliver infrastructure rapidly and reliably. Here's a typical evolution of your infrastructure as code. You probably start with a simple setup, a monolith ISC with a single run. If you're using Terraform, then that means a single state file. As you can see in the diagram on the left, it has networking, platform EC2, and S3 bucket all in a single monolith ISC. As you scale, you start breaking ISC into separate and smaller ISC runs. As you can see in the diagram on the right, there's a separate networking, then platform EC2, platform K8s, and Postgres that depends on networking, and then K8s add-ons that depends on platform K8s. This talk is focused on teams who have already broken down their ISC into smaller runs or looking to do so. If you have a very simple setup and can just execute it as a single ISC, you won't have most of the challenges we talk about today. For the execution of your ISC, it probably starts with running ISC on engineer's machine. But as you mature, you have more members of the team that want to run the ISC and want a more reliable and stable execution environment. You create an ISC pipeline or use GitOps to execute the ISC from a shared environment. This talk is focused on teams who already use pipelines or GitOps or looking to do so. Application teams need an entire environment, something like you see in the diagram, to deploy and operate their application. Just getting networking or the Kubernetes cluster or the database on its own is not going to allow them to run their application. They want the entire environment. If you want to get an environment like this using infrastructure as code, here are your options. Create a monolith ISC, but we all know this is bad. It creates tight coupling and is not recommended unless, of course, you have a very simple use case. The state files become large and it becomes painful to maintain them with a monolith ISC. Option 2 involves hand-rolling pipelines using tools like Jenkins, Circle CI, etc. to run the ISC and manage complex dependencies in the pipeline code. While your ISC is declarative and idempotent, these pipelines are not. You have to write a lot of custom code to provision an entire environment. If there are failures while running your ISC, or there are errors while execution, they usually get managed manually by engineers. As you can tell, these options are inefficient, costly, and typically requires a dedicated team. Here are some of the other challenges scaling infrastructure as code. If you want to follow principles like immutability for your environments or make it easier to share best practices implementation of environments across various teams, having a mechanism to easily replicate environments is critical. Since the pipelines I mentioned in the previous slide are not ideal for managing entire environments, it becomes painful to replicate them. Visualizing and understanding environments help that they provision using ISC. Teams usually struggle with that. Trying to find that information by going directly to the cloud provider's dashboard is even more confusing. If they want to troubleshoot an issue, share knowledge between teams, or make any changes to existing environments, they need to go through a painful and time-consuming process. A lot of teams create diagrams for their environments with various infrastructure resources and how they are connected using tools like Visio or Draw.io. But these diagrams get out of date soon with real environments. Instead of helping, they actually provide incorrect information and cause confusion. And then over a period of time, due to human error or indirect changes, provision infrastructure drifts from the desired state in the code. With existing solutions, drift can be detected since ISC is declarative, but only when that pipeline executes the ISC next time. And it will only find drifts within that particular ISC. Now that we understand the challenges scaling ISC, let's understand what infrastructure and environment as code is and how it helps resolve those challenges. So we can start by looking at a high-level diagram of environment as code. As you can see, it's just an abstraction over ISC. As you can see in this diagram, that environment as code in this case manages your networking, your Kubernetes cluster or Postgres database, and then your K8s add-ons, but it manages those various relationships and executes those in appropriate order. And in this example, I'm using Terraform, but you can use any infrastructure as code tool as well. So here are the differences between infrastructure as code and environment as code using the Lego analogy. So infrastructure as code automates various Lego pieces that might be your infrastructure resources or a combination of them, right? Let's say networking, which has your VPC, your subnets, your elastic IPs, and all of that together. On the other side, environment as code automates how those Lego pieces are connected to make up a Lego toy, which is your entire environment. Here's the definition. It's long. Let's quickly go through it. Environment as code is an abstraction over infrastructure as code that provides a declarative way of defining an entire environment. It has a control plane that manages the state of the environment, including relationships between various resources, detects drift, as well as enables reconciliation. It also supports best practices like loose coupling, idempotency, immutability, etc. for the entire environment. EAC allows teams to deliver entire environments rapidly and reliably at scale. Now let's dig a little deeper on how a provisioning workflow for environment would look like using environment as code. So you declare your environment as code. It's declarative. You push it to your source control. Then it gets picked up by the control plane, which you can run in a Kubernetes cluster. It could be a Kubernetes controller that actually watches a resource. So environment as code could be a custom resource. And then it manages the state of an entire environment. Now you'll see there is an environment state, and then each of those boxes down there have their own state because they are the infrastructure as code state. So the environment state manages dependencies or statuses, and we'll look at an example in a bit. And then the control plane detects any drift or reconciles if you're doing it for the first time. It provisions your networking. And then if you're using Terraform, it manages the state. Terraform manages the state for your networking layer. Then you go to the next, and then again, it manages the state for those layers. And then the KDS add-ons. So as you can see, it's an abstraction. There is a control plane that reconciles what's in source control to the actual state in your cloud provider or on premises. And then it reconciles it. It detects any drift and then reconciles it again. Here's a teardown workflow. It'll just do it from the bottom and just tear down and destroy those resources in the appropriate order. So what are the attributes of environment as code? So as mentioned in the definition, environment as code manages an entire environment. It supports defining the entire environment with various infrastructure components in an easy to understand format. It also supports specifying various relationships between those components. So let's look at this example, which is a YAML custom format. We actually use this for our products D lifecycle, but it doesn't have to be a YAML format. As you can see, we specify the type Terraform, we specify the dependencies. In this case, the platform EKS depends on networking. Another attribute is loosely coupled. It promotes loosely coupled infrastructure as components, like you see in the diagram, right? It brings these loosely coupled ISC components together to give an entire environment. It manages states for entire environment, as I mentioned. Like here in the example, it'll capture what operation was run, in this case, provisioning of an entire environment, and then what's the status? Was it successful, failure, so that when you try it again, it'll know. And then it also captures all the components and what their statuses are. There, it promotes loose coupling. Oops, I think I went in the other way. Another thing is it's idempotent and immutable for an entire environment. These are the key principles for infrastructure as code. How do you apply those principles to an entire environment? So I'm not going to go through this in detail, but basically idempotency means that if you keep running your infrastructure as code or environment as code as many times, and whatever your starting state is, will end up with the same end result. This simplifies the provisioning of your infrastructure or environment and reduces the chances of inconsistent result. So for a non-idempotent case, you will get 6 actual VMs if you run it twice, unless you handle that use case. And for idempotent use case, it doesn't matter how many times you run. If you want 3, you will get 3 because it manages for you. So environment as code allows you to do that for an entire environment. Same thing, configuration drift is a huge problem with infrastructure. And in case of mutable infrastructure, you keep you apply any changes or new versions of your infrastructure to existing infrastructure. This causes configuration drift over a period of time. In case of mutable infrastructure, if you make any changes, you actually provision new infrastructure, route traffic to the new infrastructure, and then get rid of the old one. So environment as code basically allows you to do immutability for an entire environment. As I mentioned earlier, teams usually create diagrams. With environment as code, since you have all the information about various relationships, you can visualize and understand the entire environments better. Environment as code has a control plane that contains a reconciler that observes whether the desired state and the current state have drifted and then reconciles them. You might be thinking this looks like Kubernetes controllers, and yes, it is based on the same concept, and you can use Kubernetes controllers to do this. In this case, though, it probably makes sense to have an approval step before bringing the actual state back to the desired state, as this might involve destroying or recreating infrastructure. Comparing and promoting changes between environments becomes a lot easier with environment as code. Since environment as code is an easy to understand format and push to source control, you can compare EAC for various environments and promote changes. You can also use GitOps for the entire environment. Let's look at it quickly. So as you can see on the left, you can push your environment as code to your source control. You can validate it during the pull request process. One of your teammates actually looks at it, approves it, merges the PR. Once that gets merged, the control plane is observing that in the source control. And then since there will be drift if you're creating it for the first time, or if it detects drift later on, it'll reconcile the changes with the actual resources. So thank you everyone for attending my talk. If you have any questions, let me know about infrastructure as code, environment as code. I would love to hear more.
Hello, Adarsh.
Yeah, hi.
So far, we don't have any questions. Maybe we'll wait for one more minute.
Absolutely. Yeah, and please feel free to, I think my contact details were there. Reach out if you have any questions. Yeah, would love to answer. Or if you have any feedback, because a lot of this, especially the environment as code concept and what we are using for our product is new. So would love to hear that.
Okay, then, Adarsh. Thanks for explaining us in detail about the infrastructure as code and environment as code. Glad to have you.
All right. Thank you. Thanks for having me.
Thank you. Yeah, thank you, Adarsh. Thank you. Hello, Divakar.
Hey, Niveda.
So we have Divakar here to give us a lightning talk on how to build serverless web pub sub using Azure functions. Yeah, good to go, Divakar. Can you
Okay.
please share your screen? Yeah.
Okay. Hope you could see.
Yeah.
Okay.
That is
Yeah.
yeah.
Hello everyone. Welcome to Azure Community Conference. Today we are going to see how to build serverless web apps up using Azure functions. Myself Divaka Kumar. I work as a senior software engineer at H&M. And this is going to be our agenda for the next 20 minutes. In the first module, we are going to see a little bit about the history, like how we evolved from the HTTP protocol to the WebSocket protocol. And in the second module, we are going to see an overview about a website or a tool that I developed to explain these concepts. And in the final module, we are going to see how to develop the Azure Web App Subservice using the Azure function and also how to deploy it in your Azure. So let's get into the first module. So in the early days, like the one of the pain point that we had is like how to establish the real-time communication between the client and the server, and also like this should be a two-way communication between the client and the server. Only then like you will be getting the push notifications or any updates of the data instantly at your side. But this is how it was earlier. Like if you could see, there is a client and there is a server. The client is going to initiate a call to get back the data from the server. Unless until like client is going to initiate the call, the server doesn't know like it should push the data from the database to the front end. So this was the earlier scenario that we had. And also like if you another pain point that we face in the early stages where like whenever we make a change in the drop down, like whenever the data is changed, we could see the page has been refreshing like for a considerable amount of time. So in order to avoid that, like in the early 2000, like we came to know of XML HTTP object, which actually implements the ActiveX interface, with which like we were able to silently call the server in order to get the data from the database and back to the client. So with this, like we were able to get rid of this refreshing the page, and also like we were avoiding this interruption of the user experience in the first stage. But we were still missing one another pain point, like that is the real-time communication between the client and the server. So that is where like we evolved this into like a polling mechanism where we repeatedly ping the server in order to get the data from the server. And with this way of mechanism, we were actually this is kind of an workaround, and it actually worked for quite period of time. And but the main disadvantage of going into this approach is like you were consuming a lot of resources at the both the side. Like even in the client side, you need to maintain the list of connections, and also at the server side you are using most of your resources. So that is where it is not an efficient approach. And then the HTTP long polling comes into the picture. So what it does is like the server effectively holds the single client connection that you are going to make a request, and it is going to be persisted for as long as possible, like only when the data has been received from the database and then published to the front end. So till that, like this client connection is going to be persisted at your server side, with which you were able to kind of achieve this two-way communication. But the major concerns over this HTTP long polling mechanism is the guarantee on the message ordering, and also like the delivery guarantees. Those were like the major concerns when we are moving into this HTTP long polling mechanism. But whoever is using the Signal service would be familiar with this HTTP long polling mechanism, because they are internally using this as a fallback mechanism as well. So this mechanism was quite familiar, and it was suitable for most of our business use case. But it is still not achieve this zero lag connectivity between the client and the server. So that is where like we thought of switching between the protocols itself. Like we no longer need the HTTP protocol to make this two-way communication, and we upgraded our protocol to the WebSocket protocol. So that is where the WebSocket comes into the picture, where the client and the server mutually agrees upon a single TCP socket connection, with which you will be able to achieve this two-way communication without interrupting the user experience. Like you can send the WebSocket frames back and forth, and you don't need to interpret the user experience. And also like server will also be able to initiate the call using the push mechanism, by which like the data will be published back to the list of subscribers that are listening to those events. So by this way, like we were able to achieve this real-time communication in the recent days. So that is where like we evolved from the HTTP protocol, and we upgraded our protocol into the WebSocket protocol. At the end of the connection, like if both the entities agrees to close the connection, they will be exchanging the close frame. By then, like both the entities knows that it needs to close the connection and clear the connection. So that is how they will be, both of these entities close these connections. So in the next module, like we are going to see like how I have implemented this in a website that we are going to see in a little bit. So this is going to be the high level architecture of our website, and we are not going to cover all of these. In the center portion, you could see there is a front end client that is built over the Angular framework. And this is going to listen our voice using the browser plugin, and it is going to transcribe it into a text and also translate it to different languages using the Azure Cognitive Services that I have in place. But our focus is majorly on the WebSocket service channel that is in the leftmost corner. So once these translations are done, like these translations will be passed on to this WebSocket service channel, which in turn will be published to the upstream events. In our case, it is going to be our Azure functions. So in the Azure functions, we are going to massage these data and manipulate on based on our business use case, and we are going to reply back the message to the WebSocket service channel. And then this service channel will be communicating with the front end using the WebSocket transport, and that is how like list of subscribers who are going to join this particular session will be able to see that see those translations in their own preferred languages. So in a bit, like I'm going to show how it is looks like in the real time. So what I've done is like I have opened two browsers using different credentials. In one of the browser, I am going to enter a particular session, and I'm going to join the same session in my another browser. So now I'm going to start this particular session. So what is going to happen is the browser, with the help of the browser plugin, it is going to detect my voice, and it is going to transcribe my voice into text, and then it is going to translate into these different languages using the Azure Cognitive Service, which is then published into the WebSocket service channel. So from this WebSocket service channel, it is then passed to our Azure functions, where it actually we play with the business logic, and we will be sending back to the WebSockets. And once you listen to this particular browser, like you could see, like you can listen whatever I speak here in your own preferred language in the in the different browser. Consider this as a different person sitting in different world, so different place in the world. So you will be able to choose different languages, and you can instantly like transcribe those text into these different translations. So that is how like the WebSockets is help us to establish this real-time communication between the client and the server. So I'm going to stop this, and I'm going to switch back to my presentation. So now that we have seen like how this can be like implemented in this real world, let's see like how to develop this in the first place. So Azure Web Pub Subservice is the main service that we have used in order to establish this WebSocket service channel. And this is how the workflow looks like. So there is going to be a client, and the service is nothing but the Web Pub Subservice. And between the client and the service, the entire communication is going to take place using the WebSocket transport. So they are going to transmit these frames, and in turn, the service is going to publish these frames into the upstream events. In our case, the server is going to be our Azure function. And this communication takes place over the cloud event HTTP protocol. So the cloud event is nothing but a model that is a standard specification across the event-driven service, which is actively taken care under the Cloud Native Foundation. So that is how like you will be able to communicate with the upstream events, and from the upstream events you like perform certain business logic, and you will be sending back to the WebSocket service channel using the REST API. And then it is actually published to whatever the subscriber that you have defined in your client connection. So that is how like you were able to see those translation in the other browser. If in case you don't need to have this server in the first place, if you have only a limited business use case, then what you can do is, like, when you are creating this WebSocket service channel, there is a service supported sub protocol that you need to define as part of your WebSocket connection. With this, what it enables us to do is the client can directly communicate with the service, and it can do this pops up pattern, and it doesn't need to go to the upstream events in order to publish the message back to the different subscribers. It can directly do this communication between the client and the service itself. So let's see like how actually the web pops up trigger works in the first place. So there is a client, it is going to initiate a call to our pops up trigger. This is going to be the HTTP trigger in the initial stage. And with this, you will be getting back the client connection. So with this WebSocket access token, like, you will be establishing the connection to the web sub service. So this is going to be the input binding trigger that you will be defined based on out of the web sub service. And in turn, the service is going to interact with the function app, and you will be publishing the message back to the service using the output binding of the web sub, and then it will be published back to the client. So this is the actual workflow that is happening in the when you are developing the web sub service using the Azure functions. So the Azure function is not the only way that you can define a server. There are other ways where you can implement the server. So it is just an upstream event which is going to handle your events, and it is going to perform some business use case, and you will be publishing the message back to the service channel. So let's see like how it looks like in the code. So whatever we seen as a pops up trigger is nothing but this solution. So at the end of the demo, like, I will be sharing this GitHub link so that you can go and try out yourself. So this is the web pops up trigger that I was showing about. Like in the first stage, like once the initial handshake has been done, like this connected event will be triggered, with which you can add the particular user to a particular group, with which like you will be able to listen to the messages that are published to that particular group, and you will be able to send the messages as well to those group as well. So that is what I have done in these pops up triggers. As you could see, these are the input binding web pops up trigger, and also I do have the HTTP trigger in the first place in order to get the WebSocket connection. So this is how like you will be implementing it in your Azure functions. So once you deploy this into your Azure, like let me show you how it can be done. So just go into the Azure portal, and here it is same as how you create your function app, but the only main difference is once you publish the function app into your Azure portal, so there is a key that you need to note down, which you will be able to achieve this webhook connection with your web sub service. So this is the key that I was telling you about. So this web sub extension is used at your web sub service, with which like you will be able to establish this WebSocket connection, and the communication will be happening through the cloud events, and then in turn it will be from the server, it will be communicating with the service using the REST API. So in order to create the web sub service, just search the web sub service, and then you will be able to create it. So I have already created a web sub service. Let me show you how it can be done. So in the first place, you need to choose the resource group in which you want this resource to be deployed, and then just provide a name to this pops up service. And since I believe this is still in the public preview stage and it is not generally available, so you can find these are the available regions that you can choose of, and I'm just gonna have it as a default East US region, and I'm gonna point it to the free version. So this unit count is nothing but like consider for a single unit, you will be able to establish 1,000 concurrent users at the same time. So maximum you can mention it up to 100 units that you can define as part of your web sub service. So once you define and once you review and create this, you will be able to get something like this, the pop-up service. Under this, like you need to make sure these keys are at your functions level. So let me unmask this. So these are the key that you might need at your trigger level, so that you will be establishing this output binding trigger with which you will be able to communicate between the server and the service. And also, like as I said earlier, there is a place where you need to register this webhook. So this is nothing but the function URL that you have created as part of your Azure function, and also the key that you get into the app keys that we have seen earlier. So these things you need to mention it as part of this template, and also you need to mention the hub name. So this hub name behaves like a logical container with whatever the message that you pass on to will be flowed into this bucket, and you will be able to publish it to the list of subscribers that are listening to this particular hub. And also, like you will be able to handle the system events as well. There is a capability of doing that apart from the custom events that you might have with respect to your business use case. So right now, like there are 3 system events, and I'm going to handle only these 2 system events at my functions level, and this connect level is going to be handled by the PubSub service directly. So that is how you will be able to establish this web PubSub using the Azure functions, and also you will be able to establish similar kind of workflow with your real-time application as well. I think that's all I had for the today demo. So let me get back to the slide. Okay. Yep. Anyway, I'm done with my presentation. If there are any questions, I am ready to answer it.
So far, there is no question, Divakar. It
Okay.
was really a lightning talk, Divakar. You sounded great. Thank you so much for joining.
Thank you.
Yeah, thank you. Hello, Maxim.
Hello, hello. Hello, everyone.
Okay, so we have Maxim here to give us a lightning talk on Azure Cloud for web front-end developers. Yeah?
Yes, let's make it.
Oh, yeah, good to go. I'll share your screen.
Yep, thank you very much. Okay, so let me have a session about what Azure brings to the web front-end developers. Microsoft's global mission is to empower every person and every organization on the planet to achieve more. And this is absolutely applicable to the scenario when we have Azure and when we have web front-end developers. Individual developers or teams of the developers, we empower folks to achieve more with maybe even less efforts. My name is Maxim Salnikov. I work as a developer engagement lead at Microsoft Norway. Let's stay connected on Twitter. WebMaxRU is my handle. I tweet mainly about cloud, about web front-end development, about progressive web apps. So yeah, my Twitter could be a source of interesting and fresh information for you. And I build web solutions myself for more than 20 years. In addition, I organize developer communities and events. I'm a big fan of these technical communities, and you'll find often me on speaking on virtual and physical stages of the conferences. I speak, train, blog, and create content. And I have another side of my personality. I'm a hobby DJ and music producer. You can ask me, Maxim, why do we ever talk about this part of your life on this particular session? Well, because the project I want to introduce is directly connected to that my hobby. So as creative DJ, I need one particular tool to help me mix one track, for example, which I produce on the fly with something pre-recorded. So I need a tool which listens to audio stream and calculates, estimates its tempo, or BPM, beats per minute. I couldn't find tool which is free, which is stable, which is always available, neither on application stores nor on web. So what do we developers do in that case? Right, we create this tool ourselves, and I created the one which actually browser-based application, so that works in every modern browser, on every modern operating system, and this is purely web front-end application. At least it's a core part which listens audio stream from the microphone, literally real time on the fly. Using JavaScript, it applies some filters to this audio stream and calculates peaks. So this is why this is actually how we calculate beats per minute number. And yeah, this is as I mentioned, front end. So this is HTML, JavaScript, CSS, classical static web application. And yeah, I'm a big fan of progressive web apps, so I created this as PWA, so you can install it on your machine, on your device, any device, any operating system, and this will behave like a first-class citizen application on your device, and it works offline. So since it doesn't send this audio stream to any servers, and all calculations happen on device itself, yeah, why not to have this offline ready? And I was so happy with this application, I even gave a name to this. I call this BPM Techno. And yeah, I have this running locally for my DJ streams I do from home. And you know, I started to think, is it enough to have this application running on my local machine, on local host? Maybe not. And this is why I have this roadmap for this particular application. What's next? I really believe that this application could be useful for the global DJs and music producers community. So I really want to share this with everyone who might benefit of this application. So I started to think how to go, you know, from the local host to the global distribution of this application. Next, I have some extra features on the roadmap. For example, why not to create a simple user account where you can track the music you love to play, love to mix, just to provide some simple stats on your favorite tempos, your favorite BPMs. So some simple user authentication needed. And at the same time, I really want to focus on what I do and what I love to do. This is web front-end development. So how to achieve everything that on this roadmap without going out of focus from the web front-end development. Definitely, we need some help, some support from the cloud vendors. And I started to think, what could be my wish list to the global cloud vendor for my particular application. And my requirements are not something exotic. I believe many web front-end developers and web front-end teams want, wish, and need exactly the same. So what are my wishes for the cloud vendor? Hosting itself, no doubts. It should be fastest, it should be reliable, always on, 24/7, no downtime. Next, as I mentioned, I want to have this distributed over our planet, because producers and DJs are everywhere, right? In every country, on every continent. So it makes sense to have this application hosted as close as possible to their country. Next, this is front-end web application, and many of the modern ones are either SPAs, single page applications, or like kind of new trend use server-side rendering. And in that case, some extra support from the hoster side needed. So this must be included. Next, I registered custom domain name for my application, and I'm super proud with this one. It's bpmtech.no in Norwegian top-level domain zone. So connecting domain for free to this service is absolutely must-have. And the same must-have is service secure socket layer certificate, SSL, to serve everything under HTTPS. I believe nowadays this is absolutely must-have for all web applications. So personally, I feel insecure and do not use sites hosted over HTTP at all. Then deployment. I'm a web front-end developer, and currently I don't have plans to dedicate too much time for learning how the operations work, how to have this flow from code on your local machine to being globally distributed over multiple servers. So if it could be automated, this will simplify my life a lot. At the same time, I need a bit more sophisticated flow with staging environments. In simple words, I want to have some test environment, which is also publicly available, hosted somewhere for particular branches of my application. When I want to test some new feature before pushing it to the main domain, or I want to gather some feedback about this feature from again global community. So and at the same time, I don't want to learn too much about how to create this staging environment, how to make sure that on every push to a new branch and every pull request, this environment is updated, all these DevOps things. Maybe later I will dive deeper into this knowledge, but now I want to focus on the web front-end development. Plus, I have some features on my roadmap, and why not to create a couple of API endpoints, for example, to gather feedback from people. Was BPM detected correctly or not? Just to have some simple voting API endpoint, and this data goes to some database for me to understand if this application really works. So API endpoints is number one. Second, I already mentioned that I would like to have simple user account, and for that I would like to get some support on authentication and authorization of the users. I could create all this mechanism myself with login form, with database, with the users. But I'm completely fine if it all be outsourced to third-party identification providers like GitHub, Twitter. So people will use their social accounts to log in. And this way, again, I focus barely on web front-end development with only a bit boring how to organize this user account. If we talk about API endpoints and user authentication, it might be a bit challenging to reproduce this environment on your local machine. And in that sense, I really would like to mimic completely what happens on cloud to have the same environment, same behavior on my local machine. So I can test, develop, debug my application, for example, when I'm completely offline, right? And in that sense, we need some for example, mocks, if we talk about user authentication, or some runtime on machine if we talk about hitting API endpoints. So this would be cool to have this support from cloud vendor. Last but not least, this is my hobby project, and I invest time to this project, and I don't want to invest dollars to this project. So I would like to have quite a good free tier. At least something for me to start, something for me to validate my idea, something for me to share with global community. Maybe later, when I have 1 million visitors every day, it will be a good idea to think about some paid tier. But to start, I need all these points you see on the screen for free. And you know what? I found this kind of service. It's called Azure Static Web Apps. And I'm super proud that I took some part in the development of this service. I contributed my feedback to the architecture and helped the team to provide proper developer experience. So I started with Azure Static Web Apps. I succeeded with this. Now my application is online. Now I want to share my experience, my knowledge with this application with you folks. How to start? Imagine you have web front-end application written in React or Angular, Vue, Svelte, your own framework, without framework at all, whatever, just a static web app. How do you push it to the cloud? Not just to the cloud, but to the global cloud with such an awesome helpers and for free. The simplest scenario is to install extension for VS Code. Yeah, it's not a secret that many developers love this IDE. I personally use this as my main code editor, and it has a really awesome ecosystem of extensions. And you'll easily find an extension called Azure Static Web App. So you literally open folder with your application and do some steps. You can do the same, you can achieve the same using Azure Portal. You just go there. If you don't have subscription, just get free trial. You'll easily find how to register this free trial account, and you'll have some dollars for you available in if I remember correctly, 12 months duration. And after this, your application can stay there for free. You remember that we have very good free tier for static web applications. So in both cases, you will be asked to provide only a couple of points of the information. First, you point to a particular source code repository. Not a secret that majority of the projects we store as a source code on some source code repositories, right? Let's take GitHub as an example. Then only a few questions about application configuration. Literally just the location of the application itself within this repo. For example, for majority of scenarios, this will be just a root folder. If you have a monorepo, you just point to the folder where your front-end part of the application located. You also provide the path for build artifacts folder. For example, for React application, this is something like /build. For Angular application, this is dist/project name. So you know where exactly you have your build artifacts. Then you count 3, 2, 1, and basically in a few seconds, or maybe minutes if you have quite complex build flow, you will see your application hosted online, and not just hosted, but distributed globally over multiple data centers. Isn't that cool? And yeah, immediately you will receive some test address to randomwords.azurestaticwebapps.net, something like this. So something to start with, something you can share publicly immediately, and then you can connect your custom domain, of course. What will it take to deploy a new version for your application? Okay, let's again, let me put my web front-end developer hat on. What do I normally do to build a new version of the app? Well, I build the code, right? I update my code and push it to the source code repo, either main branch or some test branch. So this will be step number 1. And you know what? There is no step number 2. This is all you have to do after you connected your repo to the Azure Static Web Apps. Literally, 0 actions, 0 extra actions, 0 efforts for you to have this complete flow from your local code to the global distribution. Yeah, of course, under the hood, many things are happening. So after you merged your new code to your main branch on GitHub, GitHub actions based on the workflow file, which was automatically created for you when you created Azure Static Web Apps resource. And as a part of this GitHub Actions, it finds the command, build command you have provided in your package JSON. And by default, this is npm run build. If you have some really custom, you can configure this later. So GitHub has this set of artifacts. In many scenarios, this will be index.html, your main JavaScript bundle, your main CSS bundle, something like this, maybe some images. And yeah, or copies this over multiple data centers on multiple continents, multiple countries. And by the way, if you use Azure for storing your source code via Azure repos, and you use Azure pipelines for CI/CD flow, it's also possible to set this up with static web apps. And then how to develop things locally. I already mentioned that in case of testing API endpoints and authentication, some help needed. And after all, why not to have one more nice development static web server? We have another helper called Azure Static Web Apps CLI, command line interface for you, which performs exactly this point. It emulates whole environment you have on the cloud on your local machine. So how to start with this tool? Well, it's classic. You just install corresponding package from npm. Totally makes sense to install it globally, so -g, and then you will have SWA command available for your command line, for your terminal. Yeah, you just provide few configuration endpoints for the application. For example, for the generic React application created with create React app utility, this will look something like that. So you start this one command and you have everything ready. So it builds React application, it starts a static web server, and it emulates API endpoints and authentication. Well, what's next? Next, let's have a really short demo, and basically my main point is to show you the GitHub repo. So let me stop slideshow for the second. This is how it looks on your Azure account. So you see, I have a resource called BPM counter, and I connected custom domains to this, and application itself hosted here on bpmtech.no. Feel free to use this. And I really want to show you GitHub repo I have, because here I have described complete flow on how I created this application and all core features of Azure Static Web Apps, including staging environments, including authentication, including API endpoints. Yeah, it's impossible to cover everything during this lightning talk, but in a few seconds, I will share a short link to this repo, so you always have this available for you to reproduce some similar application, or maybe it will inspire you to run similar session about Azure Static Web Apps for your team, for your community, for your friends. Yes, and by the way, let me demonstrate that this application really works. So if I clap, you see it tries to calculate BPM. Of course, yes, since it's not music, it's quite random numbers. Yeah, let me show the slide again. Yes, so it was a really short demo. It's a lightning talk after all. How to continue learning. My last minute will be dedicated to a few links I want to share with you. We have set of learning modules on our Microsoft Learn resource, really from zero to hero guide for you to implement this or that feature. Of course, we have really detailed documentation on every single feature of Azure Static Web Apps, and maybe main link for you, which contains all other resources, aka/SW demo. It directs you directly to my GitHub repo, which contains flow for the demo and all other resources. On that, thank you very much. It was my pleasure to deliver this session. Let's stay connected on LinkedIn.
Hello, Maxim. Yeah, that was really a lightning talk, Maxim. Glad that you have joined us today. Thank you so much.
Thank you for having me.
Yeah, thank you. Bye bye. Hello. So we are commencing the last session for the day. So we have Cameron, who is going to give us a talk on why do most of the machine learning projects never make it to production.
Hello, everyone. I am attempting to share my screen right now. All right, there we go. Thank you. So welcome. This is actually the first time I'm giving this talk, so pretty excited to give this one because this is a topic that I come back to a lot. So I do consulting primarily, and this is one of the first things I talk to new customers about because it's a really important topic and something that we have to figure out how to navigate as a consultant in the machine learning space. So this topic, nothing here is directly focused on Azure, although I do Azure day and night. But everything here actually ties back to Azure, and Azure helps to solve a lot of these problems. So we'll talk about that as we go through. So let me dive in here. So thank you to Azure Community Conference for having me. This is a little bit of a unique one as far as time-wise for me. So I'd like to thank everyone for having me here. And just like to mention the various sponsors of this conference. Thank you. Your support for these conferences is really appreciated because this is what helps to pull us together as a community and allow us to give conferences like these, and some of the partners as well. So I'm Cameron Vetter. I've been in the Microsoft space for about 20 years professionally. I've struggled to figure out what to call myself. So I kind of refer to myself as a technologist, but some of the real roles that I'm doing in my day-to-day work, I'm a fractional CTO for a couple of companies. I do a lot of enterprise architect work. I do some ML engineering. I'm a mixed reality enthusiast, kind of waiting for that space to explode. And I am a Microsoft MVP for artificial intelligence. And I work for the Octavian Technology Group. We're a Microsoft partner, and we're really focused on machine learning and cloud architecture are the big two things we do. We do fractional services, and we also kind of lead all of that out with innovation workshops where we help lead companies through what the next steps are for them to bring technology in their business domain together. So I'd like to be a little bit interactive here. It's really helpful to me as a presenter. So if everyone could grab their phone, their laptop, their computer, whatever they're on, and just go to this address and enter in this 6-digit code. And let me, so I've just got a few questions that I'd like to ask to kind of bring some context to this presentation. So the first one is, what is your organizational role? So I know everybody doesn't neatly fit into these categories, but what's the closest one to what you do in your day-to-day job? So I'll give you guys a second. Hey, we got first person submitting. Nice. That's why I would expect to see quite a few developers at a conference. Yes. Anyone else? Okay, well, let's press forward here. So, this is a free-form question. So why did you choose to come to the talk, and what, as we go to talks like these at conferences, I find that each person kind of has a different reason for attending talks, and sometimes there's very specific reasons why we join. Okay. Better understanding of what ML enables. And practical. Okay, that's perfect. That's spot on with what we're kind of talking about here. But I think we'll also kind of indirectly cover the other. Okay, let me keep pushing forward. And then my final question here for the audience before we really dive in is, have you ever taken part in a machine learning project, and how far did it actually get? Right. Who knows? Okay. All right. Well, let's dive in and see what we've got. So I've kind of got two sections to this talk beyond this intro. So first is kind of the problem statement. So, I make a very bold claim in the summary for this talk, which is that 85% of machine learning projects never actually see production. So I want to start out talking about what goes wrong and why does it go wrong. So the what is kind of factual, the why is kind of why these things happen. And then we're going to talk about the solution. So how do you avoid becoming a statistic? And what's my advice as to how do you set yourself up for success in machine learning projects? So let's dive right into the problems. So the first problem is just a bad foundation project. And so the very first premise is you've got a leadership team and they're throwing money at machine learning. So this happens in larger companies. I see this quite a bit, actually. So oftentimes we'll get our one leader will read something or have a conversation with, and the conversation will basically be like, machine learning, aren't you doing it? Everyone should be doing it right now. So they immediately start chasing machine learning. And with companies with deep pockets, oftentimes that means just throwing a bunch of money at the problem. But what they don't realize is money money isn't going to solve everything. You'll get a project spun up, but if you don't have solid foundational plan of what you're trying to accomplish and where you're trying to go as an organization using machine learning, you're going to just kind of do stuff without having any real direction. And I see this really, really common. And this is actually one of the first things I try to guide people through, because this can be a starting point to actually start to use machine learning in enterprise. But you need to actually turn people towards, okay, what are we trying to do? And then the next is a lack of leadership support. The one I see the most is, following up on what I was just talking about, they see machine learning as an experiment for their organization. They're not really expecting it to succeed. They're not really expecting it to fail. They're just kind of throwing it out there and seeing what happens. And if you go at it with that attitude, you're kind of setting it up to fail to begin with. The other big issue I see is that it's kind of one leader's pet project, and it isn't something that the entire leadership team believes in. So really, the team's misaligned. They're just kind of letting that person do their little project, and then they're kind of expecting it to fail, go away, and then get back to business as usual. So if you don't really have the entire leadership team pulled in, you're setting up for failure right from the beginning. And then the next aspect is a poorly defined return ROI, right? So what exactly are we trying to do? Why is it critical to this organization? And what does it bring to the company? Are we expecting to get increased revenue, lower cost, a new line of business, and then when will this all happen? If you can't answer those three questions, you've really again, you're setting yourself up with a project that doesn't really have an end goal. It doesn't have a benefit, so nobody's really excited about it or pulling for it. So this is a big one, and this is really common with any new technology. The thing I'm describing here, I've seen similar things in enterprises with blockchain, for example, and it's really about helping people, and I feel like this is the best way to back into it, is by helping to define that ROI and getting people excited about what this could bring for this particular company. So next is the ownership problem. So now we're going from here. It's kind of a little bit more tactical. So who actually owns the stuff that's being created? What we'll often see is in large companies, they'll have a data scientist or a team of data scientists, and they get really focused on this experimental model creation that they're doing. They're trying to solve this problem, but they're doing it in a very experimental way. And at the point that they get a model that works, they kind of have this, well, my work is done here. I've got this model that works, so let's just toss it over the wall to the engineering team. And so now you've got your data scientists that created this model. They don't feel ownership because they tossed it to the engineering team, but the engineering team didn't create it, so they don't really feel ownership of it either. And even worse, what they'll often get when the teams are broken up like this is they'll get something that's not scalable. It may not be computationally or financially possible to run this thing at scale. It may be too slow to provide production level performance. When you're experimental, if something takes a few seconds to run, no big deal. But when you're trying to do something in real time for production, that may end up as part of the end user UI. A few seconds can feel like a lifetime waiting for that model to complete its work. The next problem we often see is it's not refactorable. So the model was built, it was kind of hacked together. Data scientists are typically not engineers first, they're more mathematicians instead, focused on statistics and like that. So they're not necessarily designing refactored or engineered into production. And finally, kind of the one nobody thinks about is we have to have some inputs that go into this model to get expected output. That's kind of how most machine learning work, is that we're taking in some facts, putting it through the model, and then getting a prediction as output. Well, in some cases, that input shape may be really hard to achieve in a production environment, and it may not even be possible to do in real time. And so that may also mean, but what I'm getting at here is this whole thing, if it's just done in an experiment and tossed over to engineering, oftentimes what engineering gets is basically unusable and not something that can be moved forward. And ultimately what this leads to is we get each group feels that this is not my model, it's the other team's model. One feels like they handed it off, The other feels like it was just tossed to them. And ultimately, nobody takes ownership of the model. And this is the point where I see a lot of machine learning models in larger companies fall apart. The data scientist has felt like they nailed it, and the engineering team feels like they didn't, and this thing isn't usable. And this is kind of the point where the project ends oftentimes. So the next problem I want to talk about is starting simple. So teams often will start chasing the unicorn. So they'll look for this earth-shattering, company redefining machine learning project. And this will be the dream. Everybody will chase it. Everybody will get super excited about it. So we'll succeed maybe in doing some of the first things I talked about, getting everyone on board. But now we're chasing this thing that is so hard and so complicated that it's really difficult to get there. And instead, you should be looking at what's something that's simple and achievable. And the reason that's really important is you want to make sure that you're always demonstrating progress. Just like any other software project, you need to have incremental, demonstratable releases that you can put out there that are showing progress and showing actual business value that you're contributing. Because if you don't have that business value, well, eventually your project just becomes this thing that's going on over there that's a distraction, and that eventually gets it killed by the leadership team to focus on the things that have more demonstratable business value. And another one is the never-ending project. So the project gets so large or so infeasible that it drags on forever. And what you get is something that I call organizational fatigue. And it's, again, it's the entire organization going, there's that project. It's been going on forever. It's not going anywhere. We know it's not going anywhere. So eventually the project dies, or it gets cut down to a bare minimum staff or low funding, and it prevents the project from ever succeeding. And all of this is kind of centered around not having an MVP plan. So this is something that we talk about in all software projects, right? Is the idea of coming up with that minimum viable product. So what is the smallest thing I can actually build that brings business value? So oftentimes we forget about this in machine learning projects because we think we're doing this big, great experiment to build this model, and we're not thinking about what it looks like to get that model in production and what's the bare minimum that we need to get something that demonstrates business value to our end users. So the next one is talking about the composition of the team. And I've been alluding to this already, but the first question you have to ask yourself is, are these guys actually a team? Is this really a team we're looking at? Or is it that group over there and that group over there? And each one is trying to do some aspect of it, but none of them are collaborating as a. This is a classic problem. I mentioned I'm 20 years in industry, and as we've seen things like Agile and Scrum, those sorts of things really take hold of the industry and get, I've seen them emerge and become really popular, and now seeing them fade away, or more like becoming just a part of how we do business as development teams. And but when I go back and think about what was life like before that, it was a lot of people kind of running on their own and not necessarily operating as a team. And the same thing can happen here. And I've been kind of talking about, the idea of the data science team kind of off on its own. That's the really common one. But it's even worse than that. So let me talk a little bit about the roles that I see in a high functioning machine learning team. Excuse me. So typically we've got this really important role that everybody forgets about, and that's the data expert. So they're the person that knows the data inside and out within the organization. They can tell you where it physically exists. They understand how the different data relates to each other, how it ties back to the business domain, and they provide that context for the rest of the team. So data is super important to machine learning. It's actually a lot more of the work goes into the data than the actual building of the model. So it's really important to know who this person is and treat them and integrate them as a member of the team and not just that person over there that knows the data. The next is the data scientist. So, when I think about, and the data scientist term has become really overloaded. I've seen people doing all different things, calling themselves data scientists now. But when I think of what a real data scientist is, in my opinion, it's a person, they've probably got a PhD, or they're working towards one. They have really strong math and statistics background, and they know how to apply world-class techniques to digging into the data and finding information. And the thing they typically aren't is really good at coding. They know how to do enough to get the job done, but that may not be their first thing. And you'll notice that I put optional on here. And so the thing I want to emphasize, and you'll see as we go further into this presentation, the data scientist is not critical to every single project. And usually I discourage teams that are just digging in to machine learning from pulling in a data scientist right away, because there's a lot of low-hanging fruit with machine learning that doesn't require a big experimental project. But nonetheless, this role, when they do become a part of the team, they should be on the team and not just working off in a corner, as I so often will say. Next is having a business sponsor and having somebody that's really strongly positioned within the business. And it's really important to have them as your champion for the project, and they need to really believe in it. They have to be able to easily speak to the business benefit and when it will be delivered. If this person doesn't exist or can't really speak to the business benefit, your project is going to be in trouble right from the beginning. An ML engineer. Oftentimes the lines between data scientists and ML engineers are a little bit blurred. But an ML engineer, in my thinking at least, there's somebody that's a really great engineer. They understand design patterns, development. So a lot of what we look for in a really good engineer. But what differentiates them is they understand how to apply machine learning. They're most likely going to be proficient in things like Python and many of the frameworks used in that space. And they're going to also have the ability to build custom ML models. So they're not going to be as necessarily as deep as a data scientist, but they're going to have significant overlap between the two. Next is the MLOps engineer. So the MLOps engineer, so this is an often forgotten about role, but they're the person that's going to understand how to manage everything. Where do we put the code? Where do we put the data, the models? Where does it live? What's a versioning scheme for these things? How do I create and manage a pipeline to automate training, testing, deployment? And what they're going to do is bring that rigor and repeatability of traditional software development into your machine learning project. And what's really nice about in this space right now is Microsoft has made a huge push in this area. And they brought a lot of the tooling that's necessary has been brought out with Azure Machine Learning. So a lot of these used to be really big, really hard problems that didn't have good solutions. But now we actually have really good tooling within Azure to solve a lot of these problems. And finally is a data labeling team. So this is the often forgotten about team or team member. And they're going to be able to go through the training data. They're going to be able to apply business domain knowledge to it, and they're going to do labeling on the data. So oftentimes they can be some of the lower cost members of the team, and they can be kind of not really thought about or not really a focus as you're spinning up the project. But the truth is, the quality of your machine learning model is going to be directly related to the quality of your data labeling team and the quality of the work that they put out. So they, in a sense, can be the most important members of your team, and they are so often forgotten about. So as I kind of went through all of these, that's a lot of different team members, and obviously some of these roles can be shared and have the same person performing multiples, but it's really important to know who is doing each of these things, because if any of these are left out, you will find yourself with a project that has a really low chance of success. So the next one I'd like to talk about is missing process. So the space around machine learning is still kind of young. At least what we're doing today with it is kind of young, and we're having some of the same growing pains that we had decades ago in software engineering, and a lot of those really revolve around low or no process. And I mentioned how experimental that machine learning work can be. Well, what people will often do is they'll often just run and start doing stuff. They'll start coding, and this is what we used to see, decades ago in software development. And eventually, we started to get SDLC emerge with waterfall and Kanban and Scrum and countless other processes. So just like in that space, it's really important to get that process in place and understand how you're going to move forward as a team. Similarly, having a testing strategy. So testing's a lot different in this space, because now I've got this model and it doesn't have these distinct algorithms in it where I can say, if A and B are the inputs, I expect to get C, because this is something we've trained and has learned. We know for a fact that the model will not be perfect, and it will only be accurate to a certain percent. So what is the validation strategy that we're going to use, and how will we prove that this is going to work in the real world and is production ready? And finally, what's our release strategy? Teams just expect to throw it out there, similar to how they do with the software project. But realistically, models are a little bit more complicated to deploy, because oftentimes how they behave when they get into a production environment can be unexpected or different than anything you saw in your test environment or when you're testing. So it's really important to have a strategy of how you're going to mitigate that problem. And one of the things that we often focus on is doing side-by-side releases of different models. So when I release that new model, I keep the old model out there, and maybe it still takes 90% of the traffic and only 10% goes to the new model. And that way I can kind of watch what's going on with the new model. And that gives me a way to roll back. I can simply turn off the new one if needed, or I can roll forward and start to give more and more traffic to the new one. But it's really important to have a game plan and a strategy for how you're going to get your models out there. So the next thing I see is people not really thinking about the data. So often teams will go into machine learning projects and just assume that they have the data, or it'll be easy to get. And it turns out to be one of the biggest problems that we have in in machine learning projects. So what we'll often see is that access to the data is limited. It can be siloed into different business units. And oftentimes there's resistance within those businesses saying, well, that's our data. We'll think about giving you access. And there can be a lot of conflict. The advice I give is don't even start your project unless you know how you're going to get access to the data for the entire team that's working on the project. The next problem we see is the format of the data. It's often found in different databases. The databases can be in different technologies as the back end. Can be different storage mediums. Even we'll see data that's hiding within images and videos. Understanding what the format of that data is and how you're going to pull it together into something that's actually usable for building a machine learning model. So many machine learning projects kind of die at this point because they find that the data is something that they can't use or they can't figure out how to use. Another issue is privacy and security. So is it even possible to use this data? Are there rules internally that prevent it from being used? Are there regulatory bodies involved that prevent that data from being used for privacy reasons? Is there enough of the data? So often, I shouldn't say so often, every single project that I work on, there's never enough data. We could always use more. Figuring out what your strategy is going to be around getting more data is really important, and how will you collect it? Especially as you try to iterate on your models later. One of the key areas where you're going to want to iterate is to have more data available to work with. And finally, labeling. I mentioned that as a role in the previous section, but what's the plan around labeling, and how will you get the vast amount of manual labor and domain knowledge that's needed to actually do that data labeling? So all of these are problems, but when you put them together, it's really, really challenging to ensure success with your data and getting to a point where you have enough to do your machine learning project. So the next one is a lack of customer focus. So have you thought about, what's important to your customer? Because they don't care what the perfect model looks like. It's so often I will see teams that are trying to build that perfect machine learning model. And they have that goal in mind and they're chasing that perfection. But when you go and find out what the actual customer needs, oftentimes there's a much earlier point that's just good enough. What do I really need to know? What is the level of accuracy needed? When I look at a medical application, the accuracy required might be extremely high. I might require 99.99% accuracy before it's ready for real world use. But if I look at something that's maybe a marketing scenario where I'm just trying to decide who and how I'm marketing to, which is a common one we run into, that might be, 70% might be good enough for that to bring big value. So really understanding what that value is and knowing what good enough looks like so that you have a target is really important. And then figuring out what exactly does the customer want. Now, no customer is going to come to you and say, I would like a machine learning model. But what they will say is they would, they'll have a desire for this thing to be automated or this prediction to be made. So how can you define what that actually is, and how can you relate that to what the customer actually needs? So often there's a big difference between what a customer wants and what they need, and oftentimes our MVP can be what the customer needs, and then we can chase what the customer wants so that we're incrementally getting to where they would like us to be. But so, what I just talked about there, that doesn't sound any different than any other software project. At least I hope it doesn't sound that way to you. And so I'm not sure if this is actually an Americanism, but we often talk about the not invented here syndrome. So Wikipedia has a definition that I just want to share with you guys in case you're not familiar with this concept. But not invented here is the tendency to avoid using or buying products, research, standards, or knowledge from external origins. It is usually adopted by social, corporate, or institutional cultures. Research illustrates a strong bias against ideas from the outside. So we'll often see this from teams. And what it results in the machine learning space is that we get the pursuit of building this handcrafted, perfect model. And what we're missing is the easy success from some external source. Now, when I say external source, that could be many forms of off-the-shelf solutions. It could be machine learning as a service. So in the Azure space, that's the cognitive services. So Microsoft has given us this wonderful selection of pre-built machine learning models that are targeting these generic situations, and each one solves a very specific problem. And if you're able to actually apply that, you get this huge head start, and you get this model that's had a huge financial investment into it, and it has been tested and is ready to go. In a maybe a less obvious way is we have open source models. So people will do these in open source just the same way as we have open source software units that will consume in our software projects. So starting from an open source model can give you a huge head start. And third is AutoML. So in the Microsoft space, they literally call it AutoML. It's a part of Azure Machine Learning. It's a part of ML.NET. And it's basically, machine learning that helps you create your machine learning models. And what we've found as we've applied these, especially in the last year or so, as these solutions have gotten more mature, is that they actually can solve problems in a way that are good enough. So it may not be as good as that handcrafted model that I would spend a few months building, but it may be good enough, and I'll be able to actually build it in maybe just one day. So the importance of using that off-the-shelf solution can be gained there quicker, faster, and cheaper. And, all of this comes back to, if you're not willing to use something off the shelf, you're going to be missing out on a huge opportunity in this space because there's so much available. I used Microsoft as an example, but in reality, most of the cloud providers out there have solutions that are off the shelf. There's tons of them on GitHub. And there's many, many other ways to find them out there. So not being willing to use those can be a big problem for your team. And my final problem here to talk about is a lack of explainability. So, So can your team actually explain how your model works? And, when we train a model, we're actually teaching it based off of a data set. So your instant reaction should be, well, no, I can't explain how the learning works, but what we have now is we have a lot of explainability solutions out there that you can tie into your model building and training that will actually provide you information of how your model works. So again, in our space, Azure Machine Learning has some wonderful tooling for this that's baked in. And if you use it properly, you can start to explain how the model does what it does and why it does what it does. Because if you can't explain your model, you have to ask yourself, will your industry accept it? And, going back to medical as an easy example. So in the medical industry, we have regulatory bodies that we have to deal with. In the United States, we have the FDA, which I'm sure some of you have worked with in the past. And the FDA is not going to just accept me saying, yeah, I trained a model and it works. It's great. They're going to want documentation and explanation on how it works. And each industry is going to have different guidelines for that. And each one's going to have different regulatory bodies that might be involved. So you need to be able to understand what that level of explainability is. Too often, and especially in the medical space, we'll find that we've gotten this model put together, it works well, but we aren't able to explain it enough to make it through the regulatory bodies to actually get it to production. So I just covered a whole ton of problems there. These are all the common problems that I see that often are driving machine learning projects to failure. And hopefully as developers, as you're listening to this, you're thinking to yourself, well, that all sounds familiar. These are all similar problems to what we have in software development in general. And it really is just a new spin on the same old problems. And there's kind of different aspects of them, but there's still the same problems there. So what you should be realizing by now is the solution to this can be really focused on applying good software development process. So what are the solutions? So that's kind of the next, how I want to wrap up is just talking about solutions and recommendations. So my very first one is making sure that you understand your business needs. And there's many aspects to that. So what are the user needs? So whatever you are doing, your business needs should always tie back to your user needs. If what you're doing is misaligned with what your user needs, you're going to have a problem. And even if you make it to production, it's probably not going to provide a lot of value. What's the bottom line? What's the return on your investment? You should, before you even get started, you should always translate your machine learning project into an impact on the business bottom line. You should be able to say that I expect that this will increase revenue by this %, and we will see this happen within this time frame of releasing the project. And once you do that, now you have a story that you can tell about your business needs, and that makes it really easy for your champion and the business champion to be able to tell the story of your project and help you promote that project outside of your technical team. And if you find that you're not able to really find a good business champion for your project, you likely do not have a viable project and you shouldn't start it. And that can be a little bit tough to swallow for teams, but ultimately, if you don't, you're going to end up with a project that fails at some point because it's going to be cut off, or at the first sign of problems, the project will be ended. And finally, managing expectations. So making sure your promises are realistic and you have a fairly short timeline. And now that's not the overall timeline, but your timeline to actually showing business value should be something that's measured in months and maybe even weeks. and something that you can actually show that you're making progress within your overall machine learning efforts for the company. Next is when you plan your project, make sure that you're planning a multi-phase project. Every machine learning project should start with a proof of concept. It should be something that's designed to fail fast. You should be pivoting fast, and you should be repeating until you prove that you have a feasible project. So often people start by targeting an MVP, but they don't really understand if it's even feasible or possible to achieve, because again, with machine learning, we're doing training and there's all sorts of external dependencies on data that may be out of your project's control. So making sure that you do that proof of concept and make sure that you fail fast. A proof of concept should be weeks in length at most. It should not be something that goes on and on for months and months. And what it should be leading up to is once you have that POC done, now you can start talking about your minimum viable product, lock in what that target is and get there as quickly as possible so that you can get this model in front of end users, have them consume it, have them work with it, and have them give you feedback. Because just like anything else within software development, you should expect to iterate. But what's a little bit unique in the machine learning space is you should expect to iterate extremely quickly, especially at the beginning of the release cycle. Oftentimes, you will release multiple models in the same week, and you should expect to do that because as I mentioned earlier, sometimes machine learning projects have unexpected results when you get them to production, things you can never prove in testing. And so you may find that your model did not work as well in production. And you may find that you want to iterate really fast, having a new model ship within a day or two of the last one. So you should be prepared and have a plan for that. And a lot of that revolves around how your process and how you're actually deploying into production and making sure that you have that all in place. Next is, before you ever start that project, you should be evaluating existing solutions and looking for what the off-the-shelf solution is and how it could be applicable to this project, making sure that you really thoroughly look at what's out there and what's available. And as you look, especially towards your first machine learning project as an enterprise, you should really avoid handcrafting. Those initial machine learning projects, you should not be trying to carefully design some new technique within the machine learning space and deploy it within your enterprise, because it's going to take too long and your team isn't going to have the experience with everything else around machine learning yet to be able to succeed in this space. So if you find yourself handcrafting, you should really pivot to a different project. Always start with something that's simple and off the shelf so that you can demonstrate to your company that machine learning has value and here's a success that we did, so that you can build up towards those more complicated projects where handcrafting and building a custom machine learning model is something that makes sense. But if you just start there, you're kind of setting yourself up to fail. The next advice I have is creating a data plan. So, having your overall game plan of how you're going to tackle the data. And this, again, should be happening before you start trying to build a model. So you should do some exploratory data analysis. So you should be reviewing your data, understanding where it is, how it relates to each other, what your access is, how you can use it from a regulatory perspective. And all of that should be done really before you get started doing that evaluation. Understanding, is the data correct? And is there enough data? If you do get to that point, then you're going to want to collect that data and understand if you need to collect any additional data before you can actually get started. Oftentimes that's the answer, and believe me, especially as a consultant, this is a really tough one for me to go to a customer and say, you know what, we're going to need to collect data, and it's going to be a year before we can start this project. That can be a really difficult thing to say, but sometimes you do have to pause and shift to another project, or your project actually becomes figuring out how to harvest and collect the data that you're going to need and getting that into production so that that data is being collected. And then once you do have your data, having a game plan for how you're going to do feature engineering and understanding that this is going to be a significant portion of your project. Oftentimes I see teams going in thinking that feature engineering will be something that they do for a day or two. And oftentimes it can be the largest part of the project, dominating much of the timeline for the project, getting that data into the right shape and engineering the features to be suitable to feed into a machine learning model. Next is having the right team and the right process in place. I kind of alluded to this in earlier, but there's these different roles I talked about earlier. I identified 6 of them. That may not be the complete list depending on your project, but making sure that you understand who's in each of those roles and what they're responsible for, but more importantly, coalescing everybody as a team and not trying to have a machine learning team that's running with a data expert elsewhere in the company that you have to go and talk to, a data scientist elsewhere in the company that's working on the model, but not on your team. So often I see that happening, and it always sets up a project for failure or for being extremely slow with a lot of overhead. And establishing that this team is the team that owns the model and will maintain the model, and making sure that you give them ownership of it. And finally, having a game plan for process. What will ML ops look like for this team? How will they have pipelines and get this stuff in place? What is their SDLC? What's the tooling that they're going to use? And making sure everybody's on the same page and using all of the same tooling. Again, in the Microsoft space, we have amazing tooling at this point within Azure. So we've got all this great tooling. We already know how to do SDLC. We have Azure DevOps and GitHub for that. So how do we apply all of these things and apply them to a machine learning project? Oftentimes it gets forgotten, and we think about machine learning as something special that doesn't need these things, but it really needs to have a process game plan right from the start. Then, what does our test and release planning look like? We should have a documented test plan to be able to say that this is what testing the model will look like. And we should know what good looks like for the model before we start. Is it a certain level of accuracy? Does it need to make it through a certain data set correctly? What is our story for testing? And then once we have a tested model, what will our real world validation look like? In a perfect world, I'd always love to have a small test group of real end users that can really hammer on the model. But if you're not going to have that, how are you going to get that real world testing before turning your entire user base loose on this particular machine learning model? And then what's our release plan? What does the go, no-go look like for our project? How do we establish metrics of what success looks like so we know when we're ready for production? How will we do that A/B style transitioning I talked about earlier? And again, we have great tooling. Azure Machine Learning brings great tooling for doing this, but what's our game plan for how we're going to transition those models, and how will we roll back if we need to? So hopefully as we went through this all, a lot of these solutions feel familiar and feel like something that you've done within software development already. And it's really just kind of a different twist on the same thing. But I hope that you guys gain something from this and, are able to help defeat that 85% failure statistic that we see in machine learning projects. So once again, I'm Cameron Vetter. Thank you for watching this. My contact info is on the screen right now. And if you have any questions, I think we have a couple minutes for questions.
Hello, Cameron.
Yes.
We don't have any questions so far. We'll wait for 1 more minute then.
I'm sorry, I didn't hear that.
We will wait for 1 more minute for
Okay.
the question. Yeah. Okay, Cameron, there is no questions.
Okay. Well, thank you again for listening and joining my talk. And I hope you'll, I think there's a closing section that's coming up for you guys to join in a few minutes.
Yeah. That was great having you, Cameron. Thank you.
Thank you.
Mm. We would like to thank all our attendees, speakers, and volunteers who joined us today. You're all an important part of the conference, and we sincerely appreciate your attendance on day 1. We hope you learned something new, had fun, and can't wait to see you all tomorrow for the session on day 2. So until then, bye from Azure Conference team. Thank you.